here, it shows that this is here on top here. So if you draw the structure formula, you see that this one is here, which shows that now this hydrocarbon, sorry, this carbon, it has this side and also has this carbon which is attached to the carbon atom with a functional group. So D becomes the most correct answer. Yes. So just guys, these are just my suggestions. There are so many ways how we can do so many questions we're gonna see, because we have different methods we use when you are doing these calculations. So let's see if we can what you wrote is what I'm going to write. So if it's a different method but you get the answer, then it's cool. Which one of the following is hydrolysis? Hydrolysis, people who watched my prediction, you saw. So this one is saying that which one of the following is hydrolysis. It means that which one of the following is hydrolysis reaction. So here you have this to form this. You have this to form this. This can't be hydrolysis because you are not adding water there. So you see this and this is the same reaction, but it's a reverse reaction. So this is not, this is hydration, and then this is obviously not, it's no because we're not adding water there. So this one becomes the most correct answer. So yeah. Then we go to the next question, which is 1.4. They are saying that hydrochloric acid react with the excess. When you talk about excess, it means that it cannot be a limiting factor in that regard. So it means that just a moment. Just a moment, guys.
Recording in progress.
Right. Let's continue. Let's continue from where we stopped. I hope everyone is hearing me, né? Yeah, because it is just a live. Né? Yes. All right. If you don't hear me, okay. We go to the next question. What are they saying? Hello, everybody. Yeah. Go to the next question. What are they saying here? Zinc plus hydrochloric acid gives you zinc chloride plus hydrogen. Different conditions are shown in the diagram below. The mass of zinc is used is the same in both test tubes. Okay, meaning that the mass of zinc which is used is the same, but what is different? Remember, zinc is in excess, so it means that zinc cannot be a limiting reagent. But now what is happening here? If you look at here, is the same concentration. What is different here is the number, the volume. So what are they saying? Will the initial rate and the final volume of hydrogen produced in the test tube Y compared with that of X? So what will happen here? Initially, saying that how will the initial rate of reaction and the final volume, initial rate. So because it's initial rate, okay, produced in test tube Y, as compared to test tube X. So if you look at this, in test tube Y, what will happen here? Initial rate of reaction in Y, and then initial volume of hydrogen in Y. So in here we shall see that we're gonna have more of Y, and then we're gonna have initial rate of reaction in Y. So here is gonna be this, and this is the most correct answer. So the answer becomes B. Then we go to the next question. We see that 1.5, the diagram below represent the mixture of nitrogen dioxide and nitrogen dioxide and dinitrogen tetraoxide. The nitrogen tetraoxide molecule at equilibrium in 1 decimeter cubed of container at T. All right. They're saying that the balanced equation for this reaction is this. Okay. What is here? You have 2 moles, here you have 1 mole. Okay. None of the following is true for the equilibrium constant Kc for the reaction at Tc. So they are saying that Kc is 24. No, Kc is greater than 1. Kc is greater than 1. Yes, it could be. Is Kc greater than 1? Let's have to find out. We have to find out, because now Kc, remember Kc is equal to the product concentration to the exponent, maybe X in the product, okay, over reactant. So if you look at this is the product, but they say this is this. So how many are they? 1, 2, 3, 4, 5, 6. Just in case that this is 6. We don't have any unit here. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If this is 12, and then this is 2 of them, so automatically this can't be 1. So Kc can't be greater than 1. Why? Because of this. So this is out. Kc is equal to 1. It can't be because they are not equal. Kc is greater than 0, yes, but is less than 1. I think that is the perfect answer for this, and then that becomes D, the most correct answer. Then we go to the next question. The next question, they are saying that all right, they are saying that next question, they are saying that the volume, okay, the reaction is at equilibrium in a closed container according to the following balanced equation. Copper is equal to copper 2. Copper oxide is equal to copper 2. Still is the same. It's copper. This is copper 2. This is copper 1. Gives you copper 1 plus oxygen. This is already as copper 1. This is already as copper 2. So if you don't know, sorry, but it's not for explanation everything. It's just to see which one is the most correct answer. Yes. The volume of container is now increased while the temperature remains constant. The new equilibrium is, okay, the volume is increased. So volume, how is the volume affect the Kc? Okay, we shall see. While the temperature remains the same. The moment temperature remains the same, means that Kc is always the same. But if you increase the volume, what does it mean? If you increase the volume, so here you have 4 units, 4 moles, while here you have 3 moles. So if you increase the volume, it's going to favor the reverse reaction. So let's go to the table and we see. Concentration of this decrease, no. Concentration of this one increases. So whenever there is remains the same, it is probably to be correct. But now the number of moles of this is gonna decrease. So we look at this. So now this one goes. So there is no any other option. So B becomes the most correct answer. So the concentration of oxygen remains the same. So 1.7 nitric acid and the ethanoic acid. Yes, what happens? Nitric acid and ethanoic acid of the volume and the concentration are compared, meaning that you have nitric acid, you have ethanoic acid. Yes, so you compare the volume, they have equal volume and the concentrations these two are compared, consider the following statement regarding to these regarding to this what solution. And what are they saying? That they have the same pH. They have different pH. They can't be with the same pH. Why? Because this is a weak acid, so it ionizes partially, while this is a strong acid, meaning that the pH of this is a little bit lower and this one is higher. Remember, when it's higher, it means that it's a weak acid. So now what happens? Both have the same electrical conductivity. No, amino acids, they have a strong electrical conductivity compared to others. So this is out. Both solutions require the same number of moles of potassium hydroxide for componentization. They're saying the same number of moles. They're not saying the same concentration, meaning that now the volume can be different. Let's see if both of them, they are monoprotic acids. Yes, if you look at nitric acid here, it has one hydrogen. And also if you look at this, it produces one hydrogen. So both of them are monoprotic acid. However much one is different. So therefore, it requires the same number of moles. I'm saying not concentration, meaning that the concentration might be different to reach neutralization. In other words, the volume used will be different, because if the volume is different and then the number of moles are the same, definitely the concentration will be different. So this and this, they become most correct answer. So do we have any option which has that? Yes. So C becomes the most correct answer. Yeah. We go to the next question, and then we see the apparatus in the diagram below is used for titration. Yeah, we use this to do the titration. But they are saying that hydrochloric acid and potassium hydroxide. Cool. In titration, the learner accidentally exceed the endpoint. Which one of the following will be true for titration mixture? If you are, both of them are strong acid and strong bases, so we expect the pH to be at least 7. But now the learner accidentally, remember, you have hydrochloric acid, you are pouring it into the, you're not having the other way around. So it means that the pH is gonna be a little bit lower, or it's gonna be a little bit of acidic. So now the hydrogen ions will be greater than potassium hydroxyl ions, and the pH will be greater. Then now this one messes it up. Then they're saying that hydrogen ions will be less, no, because we have more acid now. Then you're saying that then this one is also no. Then automatically this one becomes the most correct answer. But let's go through it. Hydrogen ions are greater than OH, yes, and the pH is less than. Is less than what? Is less than 0. Did I say that? This pH is greater than 7. No, man. No. It's this one. This means pH is supposed to be less than 7, meaning that 7, yeah. So this one becomes the most correct answer, not this one. Yeah. So the pH here, this one, hydrogen ion, will be greater than this, cool, and the pH is supposed to be less than 7, so that now it is acidic. This one is makes it to be wrong, né? Yeah. So the most correct answer there is A. Then we go to 1.9. 1.9, what are they saying here? The following hypothetical statement, standard reduction potentials relate to a galvanic cell. Okay, you have this, gives you this. You have this, gives you this. Okay, consider a statement in the galvanic cell. The EMF of the cell is equal to 20. Standard condition. If you have this minus this, then it gives you the volume, the voltage as that, or EMF. Okay, cool. Why is an anode? Why an anode? No, why can't be an anode? Why? Because, and then X is oxidized. So if X is oxidized, let's see. Yes, X is gonna be oxidized. If this is oxidized, yes, this is cool. And don't forget, yes, so X is oxidized, then automatically Y is gonna be reduced. So it can't be the what? The anode. So the most correct answer is this and this. So you have to look at 1 and 3, where is C becomes the most correct answer. Then 10, they're saying that which one of the following have equation below will be the main reaction at anode during the electrolysis of concentrated. Now this word, that's why they even put it in capital letter. The moment they say concentrated copper chloride, yes, so it means that they are looking like molten copper chloride. It means that we're going to have much more of, remember, we're going to have much more of chloride, understand? And the anode is a positive in electrolytic cell, so the chloride will go to the positive charge. Therefore, chlorine is going to be released there. So the most correct answer here is chlorine is going to be released, so therefore D is going to become the most correct answer. Then we go to the next question, that is now the section whereby just you have to talk about the naming, the nomenclature. Okay. Here, yes, let's go to the nomenclature and then we see how this one is going to be. Then here we are saying that A to H, below the table, 8 compounds. Okay, sharp. Yes, A is B, right? Okay, let's go. Define the organic molecule. Basically, organic molecules are compounds with the one or more carbon atoms that are covalently linked to one another, or to one another, or with another element. So basically, the organic molecule, organic compound, it must be basically carbon atoms. If it's more than one, it must be linked to one another. That's why we call them that carbon atom can have that ability of catenation, like joining one atom of carbon with another and then forms a long chain. It's one of the good properties of carbons, of carbon, yes. So basically that's an organic molecule. Write down the IUPAC name of compound E. So if you look at compound E, what are you going to say here? First, find out the longest chain, compound E. 1, 1, 2, 3, 4. No, 1, 2, 3, 4. Because here I have the double bond. But when I was going through this structure, as you see it there, something was not right. I don't know whether they did it on purpose, but it can't be, because this is a mistake. I don't know how it did happen. Maybe through printing. This molecule does not exist. See this? It's supposed to have 3, but they didn't put a 3 there. I don't know how they will mark it, but it had to be with a 3 so that it is a methyl. Yes, but let's just assume that we put a 3 there so that we have a correct naming as methyl, right? So it's gonna be 1, 2, 3, 4. So it's gonna be but. It's gonna be but. But because it's a double bond, so it's gonna be but. So it's 1 is on carbon atom number 1. But 1. You see, it's on carbon atom number 1. So it's gonna be but 1 in. But 1 in. Now I have this side group and I have this side group. So you have the first side group is on carbon atom number 2. So it's gonna be 2, comma. The second side group is 1, 2, 3, 3. Then dash di. What is it? These are methyls. Dimethyl butene 1 in. 2, 3 dimethyl butene 1 in. So basically, how many marks are there? They'll give you a mark there, and they'll also give you a mark there. At least you get those 2 marks. Yes. Then we go to the next question, which is what is H? I pack name of H. Where is H? H is here. This is a carboxylic acid. It is a carboxylic acid. So, this no, they are not looking for this. They're looking for H. So this is a ketone. So 1, 2, 3, 4. So it's gonna be butane. Remember, I told you that when it's not alkyl, if it's not alkene. So here you have to write up to there. Butane. This is a ketone which ends with on. So it's gonna be butane 1, 2, 2 on. So butane 2 on. So basically that is it. So that you get you 2 marks for the chain and then the position there. Then we go to write down the structural formula of compound B. When they say the structural formula of compound B, let me just clear it up so that we see exactly what are they saying. The structural formula of compound B. What is compound B? Okay, it's here. What is it? It looks to be an ester. So it's gonna be CH3. You put hydrogens. The hydrogens are supposed to be there. Might not put them here. And then this one, because there's no shortage of hydrogen here, so automatically this becomes a chain. CH, that's 1. CH, that's 2. CH, that's 3. Now I put C. 1, 2, 3. O there, and then O, and then hydrogen. So you put the hydrogens. No man. Yes, you put the hydrogens. Yeah, it doesn't end with it's an ester. So it's C. You put the hydrogens completely. Yeah, so that's what the structural formula, what they are talking about in here for compound B. Then we go to structural formula for compound C. Now it is compound C. So here they want the structural formula for compound C. Okay, let's write it. Xn. Xn is 1, 2, 3, 4, 5, 6. It's Xn. Difluoro is 3, 3. 3, 3 difluoro. Let me just count from here. 1, 1, 2, 3. So I have a fluoride here and I have a fluoride here. Okay. And then you have 4 methyl, meaning that if I come from this 1, 2, 3, 4, so I have a methyl here. Is it methyl? It's ethyl. So I put hydrogens. So you're supposed to have now the hydrogens. You fill it with the hydrogens. So that's the structure which you're supposed to draw when it came to that. Then I don't understand what you are saying. Aneliswa. Don't understand. But I think we are getting there. Hope you are hearing me properly. Yes. If you're not hearing me properly, let me know in the comment section. Yeah. All right, let's go to the next question and then we see how did we perform this paper. Hey, you guys, I salute you. At this time, you are awake. Okay, all right. Let's go to question 2 point. Yes, H, we are done with it. Write down the structure formula of B. Did I write? Yes, I'm done with this. I'm done with this. I'm done with that. The general formula of homologous series to which compound E belong. Where is compound E? Compound E is an alkene. Remember when I was reminding you how to write this? I said that alkene is CH2N. We don't add anything because alkane we add 2 and alkyne we subtract 2. Yes. Structure formula for functional group of F. So we go to functional group of F. F, it is a keton. Therefore, here you just come and write the structure formula of so that's what you're supposed to write like that. However, sometimes some people they put a bracket like that, so it's the same thing. It's cool, né? Yes. And then sometimes people add alkyl group that side and alkyl group that side. Still, it's cool. You'll get a mark in that regard. So in that case, the structure formula, we say that it looks like that. Whatever you write it is cool. Then IPAC name of alcohol needed to produce compound B. Where is compound B? Compound B is, we say that compound B is an ester. Né? Since compound B is an ester, let's see which alcohol is used to do what? To remove or to form this ester. Remember I told you guys that the alcohol comes from the carbon atom without a double without the hydrogen. No, that's the carboxylic acid. So you see this carbon atom, then it means that this part came from the carboxylic acid because this carbon atom didn't have a hydrogen, and then this is where the alcohol is coming from. Since it's one carbon atom, therefore it's going to be CH3 or H. Did I say structure formula? If they say the structure formula, IPAC name of alcohol, they just want the IPAC name. Therefore, if the IPAC name, then I'm just gonna say methanol. That's it. Because methanol doesn't have the name, the position, because it's just one carbon atom, and ethane doesn't have the position because it's two carbon atoms. Yes. They are saying that write down letters of the compound that is functional isomer of compound G. Functional isomer of compound G. So now we go back to compound G. G is the carboxylic acid. They are saying functional isomer. If it comes to functional isomer, then it means that they want an ester. So you have to look for the what? For the ester. But it must have the same number of carbon atoms. So the only ester we have here is this. But we have to find out if they have the same number. 1, 2 times 3. Meaning that 1, 4, yes, 5, 6. So we come here and we count 1, 2, 3, 4, 5, 6. So automatically B and G are functional isomer. What did they say? So the answer here becomes B because they are looking for the functional isomer of G. A chain isomer for each other. Chain isomer. Let me check here. Functional isomer of G. Functional isomer of G. Yes. Okay. We got it. Then they're saying that chain isomer of each other. Chain isomer. Chain isomer. Okay. This is a carboxylic acid. Do you have any other carboxylic acid? This is another carboxylic acid, but this is heptanoic acid. This is hexanoic acid, so it can't work. This one is a carboxylic acid. Let's look. 1, 2, 3, 4, 5, 6. So it has 6 carbons. And even hexanoic acid is also having 6 carbons. Yeah, so definitely D and G. D and G. So D and G, they are chain isomer. Remember that it's supposed to be the same functional group. It's just a different arrangement of atoms on the parent chain. It's the one which changes, so that now, yeah. So we go to the next one, the next question, and then we see. So we have got it. We've got that one. We have got that one. Oh, we finished question 2. Okay, let's go to question 3, and then we find out how did you perform this question 2. They're saying the relationship between the boiling point and the molecular mass of aldehydes, carboxylic acid, aldehydes, carboxylic acids, and primary alcohol is investigated. Okay, the curve P.2, PR, and S are obtained. All compounds used a straight chain. This is a key point, a straight chain. So it means that you won't be disturbed. Define boiling point. This one you know. Temperature at which the vapor pressure of a substance is equal to the atmospheric pressure. And then, yes. So definition you know. In most cases, I don't talk about it. Yes. 3.2, because it doesn't change. Write down the conclusion that could be. Okay, could be made for P. So where is P? Without even looking at what is P, but you see that it increases. The boiling point increases as this is increasing. We always start with the y-axis, because the y-axis depends on x-axis. You can't say that the mass increases as boiling point increases. No, it's the boiling point increases as the mass increases. Yes, why? Because the mass causes the boiling point to increase. If you have reversed, maybe they could give you a tick, but that's the most correct answer. Then they're saying that explain the answer and the structure. Okay. In this case, because it is the same molecule, because the same molecule, it means that you will have the same type of intermolecular forces of attraction. But as the mass increase, the London forces increase. So it means that as the mass increase, the London forces for this compound P increase, and then this will require more heat to break these bonds so that it can boil. You understand? So that's how we're supposed to explain, talking about London forces increasing the boiling point because of the high amount of energy which will be required to break those bonds. Then you get it. Yes. Then they're saying that curve R represents alcohol. Curve R represents the alcohol. Okay, if this is alcohol, then automatically this is carboxylic acid, and then this is aldehyde. Yes. So if this is alcohol, then this is carboxylic acid. So why am I saying that? I'm just saying because they have said R is alcohol. And then if you look at the intermolecular forces of attraction here on S, on this one has dipole forces and London forces. This one has hydrogen bonds and the London force. This one has London, hydrogen, and then dipole. You see, it means that this will require more heat to be broken down. Therefore, its boiling point is a little bit higher compared to alcohol, and then this one, hydrogen bonds, is stronger than dipole. Therefore, the boiling point is higher than that of. Okay, let's go to the question and then we see. which homologous series is represented by S. So we have said it. So it is an aldehyde. Then they are saying that explain your answer. So I've tried to explain that it has the London force, and dipole forces, which are weaker than the hydrogen bond, yes, which are, and the London force, which are found in alcohol. Therefore, alcohol will require more heat to break its bond so that it can boil. Hence, its boiling point is higher than that of the aldehyde. So basically, that's what you're supposed to explain. My words could be that too much. Maybe you explained in a different version. Yeah, still it's not a big deal. As long as you have talked about the things which they want you to talk about. Then we go to the next question, which is saying that molecular mass of compound with a boiling point 97. Okay, R is right, graph R, write down the molecular mass. Okay, we have to go back and we'll find out where it's 97. They say 97. Yeah, unfortunately, boiling point 97. The graph can't show nice of R, the boiling point around 97. So if you look at 97, just check here on this paper if I can find 97 is around here. So I have to draw a line touching down. Yes, and basically if you check here, it's gonna be was 50, 70, then automatically it's 60. But if you calculate the boxes, the small boxes, you'll find out that it is 60. So the answer here will become 60 because that's the molecular mass. So the molecular mass is going to be 60. So the IPAC name of compound is, this is 2 marks. 2 marks there. Where do I get those 2 marks from? So basically here, you need to find out which alcohol has 60. That's all. Yes, which alcohol has a 60. So it's easy to calculate. How do you calculate? You can use the formula of CnH2n, yes, plus 1. Yes, plus 1. So basically that's the formula you're supposed to use, and then you're able to find, if you substitute, you'll find out that it is CH3, CH2, CH2, OH. Why this? Because why not branched? Why not secondary alcohol? Yes, because it could be here, because here at the beginning they said these are straight chain molecules, so that makes it to be not that way, not to talk about the branched or yes. So they're saying that, so the answer in this case is supposed to be, they say IPAC name, so it's gonna be 1, 2, 3. So it's gonna be propanol. That's what they want. Propanol. Yes. Maybe they will give a mark for that, and also they give a mark for the main chain. So guys, that's how you're supposed to answer that question. J. Okay, let's go to the next question. Someone is telling me that, yeah, just go check 1.9. Okay, I'll check an NC. Yeah, I'll check an NC. But let's go to the next question. What are they saying? They are saying that, oh, I'm skipping. Okay, I'm skipping a question. 3.6, they're saying 2 compounds A and B used in this investigation have a molecular mass of this, okay, and it has a boiling point of this. A and B have the same molecular mass, ne? Good. And it has a boiling point of this. Okay, B boiling point is this. All right, explain the difference in the boiling point by referring to the structure of. Yeah, definitely, if the two compounds A and B are used to investigate, okay, in this investigation, have the same molecular mass. The moment they have the same molecular mass, so what is going to make them to be different in terms of the boiling point and melting point is going to be whether it's a straight chain or it's a branched chain. So in this case, it's gonna be A is gonna be okay sharp, and then this shows so it means that the one which has the highest boiling point is going to be a straight chain, and then one which has the lower boiling point is going to be a branched chain. So how do you explain this? So B has a higher boiling point, so B is going to be straight chain, while A is going to be branched chain. Why? Because when it is straight chain, it has a large surface. It has a large surface or a large size, and then this creates a large polarity. And then once there is high polarity, you require more heat to break these bonds. While B, while A, yes, which is a branched, will have a small surface, therefore it is compact. The polarity is going to be small, or it's going to be lower, and then it will require less heat to break these bonds, hence slow boiling point. So when you are explaining this, you are supposed to explain using the size and how this side accommodate the bonds, the polarity, yes, and then how much heat do you need to break these bonds compared to the other one, and then you are able to get those 3 marks. Yes. Then we go to question 4. Question 4. Question 4. What is happening in question 4? All right. Let's look at question 4. Let me just give you 1 minute. Just 1 minute. Back, just wanted to take some water, because yeah, when you talk too much, yeah, they happen. All right, let's continue to the next question, and then we see. Okay, they're saying that cracking. When you talk about cracking, you are breaking a molecule. Oh, the definition is there. Define cracking. Cracking means breaking down large molecules into smaller useful molecules. They want the word useful. Large molecules into smaller useful molecules. Yeah, the smaller useful molecules can be, yes, used in different activities. Okay, write down the value of x, y, and z. Now this you have to balance the equation. So that's it. 3 marks. So it means that you need to know what is x, you know what is y, and you know what is z. Okay, let's start with X. Let's start and we see carbon, 6 carbon. 6 carbon. 6 carbon akarne. So, this is 16. So it's 6 plus 6. See, 6 is equal to 6 plus 6. So that's 12. What is short here is equal to 4. Is it? Is it what is short there? Is it 6 plus 6? Yeah. So what is short there is equal to what? Is equal to what? Is equal to 4. So automatically, then it means that okay, and then Z Y. Is Y? Yes, Y, and then X. Okay, sharp. Now you have X. This is 16. Eh? This plus this is 12. So the balance here is gonna be what? It's gonna be 4. So okay, we put the 4 there. But don't forget that this is 2. So automatically, then it means that Y is supposed to be 2. You see? Yeah, if Y is 2, then automatically carbon atoms are balanced. Why are they balanced? Because 2 times 2 makes them 4, plus this makes them 10, plus this makes them 12. So it means that Y is equal to 2. Y is done. Then now, if I have hydrogen here, hydrogen. Okay, now let's go to X. X here, X hydrogen is 34. Ne? And then you can divide, you get the answer, but hydrogen is equal to 34. So how do I get this and this? First of all, this, how many carbon atoms makes it to be an alkane? That's the first option you can go with. Yes, if is C6 CnH2n plus 2. Ne? Yes. So so if this is 6, what is X? So it's gonna be times 2, which is 12, plus 2, which is 14. So it means that X is gonna be 14. You have different ways how you can find it out, because what they want here, they want to say this is 14. That's it. And then now, yes, so Z is gonna be what? Z, now I have this carbon atom. There are 2. So if there are 2 here, then definitely is gonna give you H. Oh, this is times 2. So it's gonna be 1, 3, which makes it to be CH3, CH3. You see? Yes. To make it to be 6, in the other words. So it means that Z is equal to 3. So that's how you're supposed to say. We say that X is equal to, what did I say here? X is equal to 14, Z is equal to 3 and Y is equal to 2. I was putting this in a different angle. Yes, Zx is equal to 14, Y is equal to 2, and then Z is equal to 3. Then they are saying that X is equal to 12. No, X is not equal to 12. Someone said, don't talk about that. All right. Okay, let's continue, guys. All right. Saying that this undergoes complete combustion. Guys, whenever they ask you about combustion, it's a simple thing. Why is it a simple thing? Is you're supposed to do the same thing. See, you produce carbon dioxide plus water as a product. But now they're saying that this compound CH14, yes, CH14. Even here is showing here CH14. So automatically this is 14. You see, it can't be X12. You see, yeah. Anyway, you can also use that technique just to identify it. CH, okay, CH14, C6H14 plus oxygen, then the reaction. So here you have to balance the equation. I try to balance. You know, this is it first introduced 2. After that, had to increase because oxygen was not balancing. I had to introduce a half, but we don't teach halves here. So this is 2, and then this was 19. Oxygen was 19, and then carbon dioxide is 12, and then oxygen, water is 14. So basically, after balancing, that's what I found out. That C6H14, then this one was 2, and then plus oxygen, which is 19, gives you 12 carbon dioxide plus 14 water here. Yes. So if you check and you find out that this is a gas, and then this is a liquid, you find out that it is balanced. Yes. So this is what they wanted you to write. If it's, yes. Then we go to the next question. Let's go to the next question. Consider the reaction 1 and 3. Consider the reaction 1 and 3. Ish. No. Kids, I hope you guys pass. Yes. Consider reaction 1 and 3. 1 to 3. 1 to 3. We call this reaction synthesis, manufacturing. A and B represents organic compounds that are positional isomers, meaning that is the same molecular, same structure, just the position of the substrate is different. In other words, one is a major product and one is a minor product. That is what is behind this. Remember, when you're doing this, we produce major products and minor products. Okay, let's go to the question and then we find out. Define position isomer structure. Molecules the same molecular formula, but different position of the substance or functional group. Yes. All right. The type of reaction represented by 1. Now, let me see. You have this is an alkene. It has a double bond. Know why? Because here there is not 2 and here there is not 2. Meaning that there is a double bond in there. It's a condensed structure formula. Ne? Yes, so it's a double bond. So it's an alkene. Alkene. You understand? Then you added this. So now there is something which you need to do. No. 1, 2, 3, 4, 5. Ne? So 1, 2, 3, 4, 5. Whereby you have this, a double bond there. You have a double bond there. So it looks like that. There's something which I want to show you. Yeah, the double bond is 1. The bond is there. And the other side plus hydrochloric acid, you produce A and B. So the first compound, what's going to happen? The first compound, then let me show you another compound. The first compound, this is going to break. Hydrogen is going to come here and the chloride is going to come there. The second compound, chloride is going to come there and then hydrogen is going to come here. And this one is the major product. This is a minor product. But now, look, if you look at this and this, it's the same molecule. But now, remember now this one is gone already because after it has broken. This and this is the same thing. But what happens here is these are just positional isomers. The position of this has changed. This is on carbon atom number 2 while it is on carbon atom number 3. Yeah. That's why they said this. And then they say that they used A. Now, among those two, which one is A? Okay, we're going to know A by this. See? You see that now this OH is on carbon atom number 2. So it means that in this case, they used the one which is on carbon atom number 2. They use the minor one. Understand? Yes. Okay. Now, they are saying that write down the reaction that takes place by 1. There is 1. Because this, I'm adding this. So it's going to be hydrohalogenation. Would be additional reaction or hydrohalogenation. Both answers could be correct because they are not specific. Structure formula of compound B. We talk about structure formula of compound B. You see now, they are talking about the major one, major product. You see, this is what you're supposed to write. But don't forget to put hydrogens. See, yes, that's what you're supposed to write in that case. So automatically, this is the hydrogen and then this is hydrogen. The hydrogens must be there. These bonds, they don't hang outside just like that. So there you get the answer. Let me see, someone is saying okay. All right. Let's go to the next question. And then saying that yeah, so we are done with this, and then we go to this one. Go to this one. Saying that write the structure formula of compound B. Okay, we are done with that. Formula of X. Now where is X? X, now remember I have this which I added on A. So now this is hydrolysis. I don't know why they brought it back, because they brought it already before. There is a question I saw where they are asking about hydrolysis. So automatically this plus this it gives you that. So it means that this was this one is going to be removed from this, so that yes. So the structure formula, they're saying that the structure formula of compound of, what did I say, is going to be hydrochloric acid. Why? Because the hydrochloric acid was replaced by water. Actually, the chloride is the one which is replaced by water, but don't forget that water comes with another hydrogen. Therefore, X becomes HCl. Yeah, it can be hydrochloric acid or hydrogen chloride, but since it's in aqueous, then definitely it is hydrochloric acid, and they want the formula. Then they're asking you inorganic reagent in a reaction 3. You are removing the water to alkene again. Definitely this is going to be what? It's going to be dehydration. So it's going to be sulfuric acid, sulfuric acid. Don't forget that when you're forming that, you require some heat, but they are not asking you, they are saying inorganic reagent. So in this case, sulfuric acid would be the best answer. However, if you wrote concentrated phosphoric acid, is also correct. Maybe the books, they are not talking about it, but it could be there in the what? In the memorandum. Yes, so concentrated phosphoric acid is also allowed in that regard. Then we go to the next question. Beside heat, write down the reaction condition needed for this conversion. Beside heat. Yeah. Compound A. Let's go back to compound A. Compound A, all right, we saw it. Compound A can be converted directly to compound E. Okay, yes, from here to here. From here, from hydrogen halide, this one, to direct to alkene. So what do you need there? In that case, the first thing you need to know that no water is needed. Yes, that's the first thing. Then number 2, strong base. You use a strong base. In this case, maybe you said strong base, potassium hydroxide, or you can say sodium hydroxide. Still, when you say that, still you give you a mark. Write down to, as I told you, that this is just there are so many answers. I may not finish everything, and the way how you do the calculation, as we shall see, might not be the same as long as you get the correct answer. Now, write down the term, 2 terms that describes the type of reaction. So the type of reaction, remember you are from hydrogen halide, halogen from this, the haloalkane. You are from the haloalkane, then you are going to an alkene with a double bond. So it means that first of all, I'm removing this and this. So I can say elimination. Yes, so you saying elimination. Let me see, what did they say here? Oh, they said
Recording in progress.
I'm back. Just that you, yeah, we are in Mzanzi. Yes, secretary had gone. They're saying that someone is asking me, is concentrated or, yeah, when you say concentrated, when you say dilute, then definitely there is water there. So it's better to say concentrated. All right, let's continue to the next question. let's go into the next question. But we will mark the strong base. Concentration strong base is fine, but we want that strong base. The base must be strong and no water, because we said no water. Definitely can't be dilute. Okay, we go to the next. This question is finished. All right, let's go to the next question. All right, they say here we are saying that the reaction below, the reaction between excess, guys, the word excess is very, very paramount here. You have to take note of that. Hydrochloric acid and the sodium thiosulfate is used to investigate the factor that. All right, this internet is disturbing now. All right, they're saying that the time taken. All right, the time taken. All right, okay, let me come back. Of the reactant with the time. So when you say the word rate, then automatically you have mentioned the word time. So change in the concentration of product over time. Understand? Yes. Or it could be volume, it could be mass, it could be as long as what you say there is related to time. Write down the independent variable. Here, independent variable, basically we look at what is changing in this experiment. And then based on what I see here, they say that the volume of sodium thiosulfate is changing 50, 40, 30. And also the concentration is changing. Definitely, even this one is changing. So concentration will determine the rate or the time, how much time is being produced. So this, yes, could be the first, or you can say volume, even volume here. Why? Because basically when you find the number of moles, definitely it's going to relate it to the concentration. This is changing, we control this, we also control this, and then we keep on changing this to see what is happening here. So probably the people who wrote volume will get a mark, and the people who wrote concentration might get a mark in there. So calculate the value of P. It's 3 marks. So what does it mean? It means that it is something which is small, and then you can get the marks in there. So what are you going to do when you reach to this? So let's try and find out. This is some of questions which are not general questions. They're just, you have to think. All right, here we know the volume which we started with without any addition, and the concentration. So it means that we can find the number of moles which is in run number 1. For example, you will say that number of moles is equal to concentration times volume. So in this case, we're going to say that number of moles is equal to concentration, which is 0.13 times volume, which is in this case it is 50. But don't forget that this is not decimeter cubed, so I have to go convert it into decimeter cubed, and then I divide it by 1,000, and then when you divide it on your calculator, it is mostly likely to give you 0.065. You have to calculate. Did I say 0.065? So you have to calculate and then find out the actual answer. Maybe when I was doing it, did not do the perfect calculation. Yes, but that's how you're supposed to do it. But now, since now I know this, I can go to this. Yes, you understand? I can go to this, or I can use what I've got here and then I compare it with what is here. I can use number 2 to prove that my method is correct, but because we have 3 marks, so we have to rush to the answer. So in this case, we're gonna say that the number of moles here, let's look at the number of moles here. The number of moles here is gonna be equal to, yes, this 0.0065, yes, times the volume, which is 30. So I'm comparing this with this, yeah, but divide by, in this case, this is 30, but the total volume is 30 plus 20. So the number of moles are in this of sodium thiosulfate are in the 30, but the total volume is what? Is 20. So, sorry, no, it's not 20, it's 20 plus 30, which makes it to be 50. So the number of moles in this case will be, when you calculate, you will calculate and then you find out the perfect answer, and then 0.0039. So now these are the number of moles. These are the number of moles which we find here. You understand? So we can use this and then we find the concentration. So therefore the concentration, the concentration is going to be equal to, in this case, we supposed to, now we have the number of moles divided by the volume. So the concentration is going to be equal to 0.0039, because these are the number of moles divided by the total volume, which is 50. But now 50, because I'm looking for concentration, this is 50 cubic centimeters, so I have to convert it into decimeter cubed, and then once you get here, it will be approximately 0.7, or maybe let's take decimal places of 3, 0.078 molar. So this will be this. And then this also shows you that if you had got a bigger answer here from this, then your answer is what? Is wrong. So that's why this answer is supposed to be in that direction. So that's how you're supposed to calculate. If you have another method you can use, because this is just find out what exactly they use. There's no general formula for this. Yes, so it's still, once you get the correct answer, still they'll give you your marks. So we're done with that. Then let's go to question 5.4. They're saying that when 0.2 grams of sulfur has formed in a run 1, yes, 0.2 grams of sulfur has formed in a run 1, the cross becomes invisible, meaning that that's the end point. Yes, calculate the average rate, rate with respect to sodium thiosulfate. So what am I going to look at here? Remember that rate, let me clean up here. Remember that rate of reaction is equal to change, because they said here in terms of this grams per second. So it means a change in mass over change in time. Let me check and see if there is someone talking to me. Acid and bases, show me who is the boss. Okay, sorry. Okay. All right, let's continue, and then we go to the next question. Then here, calculate the average reaction rate with respect to sodium thiosulfate. So now we have seen that we know this. Rate is equal to mass, change in mass over change in time. But now we know the time here, which is 20.4. So, but we don't know the mass. So it means that we're supposed to look for the mass. So how are we going to find the mass? Remember that we can find the number of the mass. Remember, mass is number of moles is equal to mass over molar mass. But how are you going to find the mass? Because we don't have the mass, have any mass. Still, we can use number of moles is equal to concentration times volume. At least we have this. We have the concentration, we have the volume. So number of moles is equal to 0.13. We know it here. 0.13 is there. And then times the volume. The volume, do you know the volume? Do you know the volume? Yes, we know the volume as 50. So we know volume as 50, but it's supposed to be molar volume. So I divide it by Alright, yeah, this is just internet which is disturbing. Alright, we're saying that number of moles here, now we know the mass, we know the number of moles. So now number of moles in this case is going to be 0.0065 is equal to the mass which we don't know over the molar mass. In this case, you have to look at the molar mass. With the molar mass? Molar mass of sodium thiosulfate. So automatically, sodium thiosulfate, which this is 23 plus 32 times 2 plus 16. Let's check on the periodic table because I'm getting it from the head. Plus times 3. Yes. So when you add, and then you have to add, and then it means that it's this times this. So the number of mole mass is going to be equal to, when you multiply this, the whole thing, this with this, you understand? The mass is going to be 1.027 grams. Understand? Yes. So now it means that that is the mass which we started with. So it means that why? Because guys, don't forget that this hydrochloric acid was in excess. So it is zinc which is going to act as a limiting reagent. Therefore, all of it was used up. When you're subtracting, it's supposed to be subtract. Remember, it's final and the minus initial. So all of it was used up. You understand? Yes. And even when you check here, here with the sulfur, you find out that it is the same thing. All right. So now we say that now rate is going to be equal to 1.027 minus 0, and then divided by 20.4. Is it 20.4? Let me check and confirm. Yes, 20.4 minus 0. So rate of reaction, in this case, rate of reaction is going to be giving me, did I say rate? Yeah, in terms of grams. Yes, it's going to be 0.03 grams per second. Yes, then that makes our answer to be that. Then we go to the next question. Go to the next question and then find out. When we go to the next question, we'll find out that. Okay. Next question is they're saying that another investigation is performed at a different temperature. Sketch the Maxwell distribution curve for reaction at 20 degrees C. 20 degrees C, when you look at it here, 20 degrees C, where is it? 20 degrees C. Okay, means that here, 20 degrees C. Okay, yeah. So it means that the 20 degrees C, and then label it on the same axis, then it will be obtained at 35 degrees C. So in this case, you are increasing the kinetic energy. So whenever you talk about Maxwell distribution curve, so automatically it means that you show us which one is going to have enough kinetic energy. So particles, number of particles. So if this is the first, and then that is the number of particles with enough sufficient energy, when you increase the temperature, yes, it's gonna flatten and increase the number of particles. It's gonna flatten and then it increases the number of particles. Yes, so you see that the number of particles, yeah, like that. So all this now, which are added more, yes, it means that now more particles will have. Then you tell us this number of particles, and then you put a caption so that maybe we give you a mark here, we give you a mark here, and then these labels of the axis. Then they are saying that explain the effect of temperature on the reaction rate in terms of corrosion theory. Increase in temperature increases the number of particles with sufficient energy. So it means that you will have more perfect collision per unit time, resulting in increase in the rate of reaction. So basically, when you increase the temperature, you're increasing the kinetic energy of the system, and then this will lead to more effective collision and then per unit time, and then this increase the rate of reaction. So basically, that's what you're supposed to talk about or to link. Let's go to chemical equilibrium. I think chemical equilibrium was very simple and easy to interpret. And those people who watched my prediction, I think I gave you a question which is almost the same like this, exactly. If it does not, okay, let's look at it. Consider the hypothetical reaction of this is the volume. It's very important. Close the system container, okay, sharp. And they're saying the graph below shows the change in the amount of reactant and product over time. Okay, cool. Then they're saying that write down the meaning of reversible reaction. What does it mean? Reversible reaction. It means reactants can be converted to product, and product can be converted to reactants. That's when the reactants and products can be converted here. Yes. So state Reaction's principle. This one is also. Some people, they just talk their words. There are some things we are looking at when you are answering these definitions. They don't change. It remains the same. A principle remains the principle. But here you have to talk about the equilibrium, and then to have to talk about the stress which has been introduced. Then you have to talk about how is the system going to counteract this stress, and then how is the equilibrium going to shift. So basically, as it shifts, it tries to remove the problem or the stress you have introduced. But some people, they just leave some points, and then this is a principle whereby you get it or you lose it. It is all or nothing law. Either get all the marks, the 2 marks, or you lose everything if you skip out something. Okay, a change with the change was made at equilibrium at this point, this seconds. Okay, write down the change that was made at this point. So if you look at it, this is the product, and then they added a product. See, so there is addition of product or addition of A. Then they're saying that and then the moment you added, then it reversed. You see that now it became a reactant. You see, yes. Okay, they're saying that the Chinese principle explain how the system react to this change. Use this principle how the system react to when when the product was added. Yes. So what is the stress? So it means that the system had to shift so that to reduce the amount of product you have added. So therefore, it will favor the reverse reaction so that the amount of product which has been added can be decreased. So you talk about the stress. How is the system going to change based on the stress or based on the what you have added in there? So basically, that's why it's 2 marks. Calculate the equilibrium constant at equilibrium constant. Okay, now you need to what 120. Yes, okay, they are looking at 120 after it has reversed. Okay, let's look at what you talk about here. You can use a different method or you can use Rice method. Because it's 4 marks, it means that it doesn't have that much details. You're supposed to do Rice. And then this is elements, so you have A, you have B, and then you have AB. Something is very important here. Look, guys, here the reaction reversed. This was the reactant, but here is the product. See, so this is the product now. And then the one which was, you see that this was a product, now it became a reactant. So A and B, they are reactants. Yes, that's why I put them on this side. So mole ratio, based on the mole ratio, this is 2, and then these are 1 1. So meaning that you have 2 here, have 1 1. Initial concentration you just get from the graph. Here it is 2. Is it 2? Yes, it is 2. A B is 2, ne? B is, check, it's B is 2. So I come here, I put 2 on B. They say that no. Look, this is the initial what you started with. So what you started with here, B here, initial I started from here, so it's 4, and then A started from 10, and then AB started from AB started from 10. AB, ne? AB started from 6. You see, yeah. So it means that A started from 10, and then B started from 4, and then AB started from 6. You see, A started from here, which is 10, AB started from 6, and then B started from here. All of them, they started from here, started from 4. Now, since I know what I started with, now what is at equilibrium? Okay, now AB, it is 10. AB, it is 10. That's what is at equilibrium. And then B is 2, and also A is 8. So B is 2, and then this one is 8. Now to get the change, what happened at equilibrium? Yes, this is what they used. So now I need to know what is remaining at. Yes, so now this minus this, I'm gonna get 2. This minus this, I'm gonna get 2. And this minus this, I'm gonna get 4. Actually, it shows us check. It's 2, 1, 1. Now, how much volume did they use? How much volume did they use? Used 4 decimeter cubed. Therefore, I'm gonna say 2 divided by 4, which gives me 0.5. 2 divided by 4 gives me 0.5. 4 divided by 4 gives me 0, which gives me 1. Yes. Now I say Kc is equal to the concentration of AB, because it is the product over, but how many moles? There are 2, squared over the concentration of A and the concentration of B. Yes, but Kc is equal to A is 1. See, the concentration is 1 squared divided by A, which is 0.5, and then times B, which is 0.5, which gives me Kc to be 4. So basically, that's what you were supposed to do when it came to that. Okay. Then we go to the next question. The next question, what are they saying? Next question. All right. Then they're saying that, so we are done with that. They're saying that calculate, okay, at 130 the temperature of the system decreased. 130, let's go check. 130, okay, temperature decreased. When it decreased, what happened? The reaction increased. So it means that this reaction is exothermic. Yes, it's exothermic. So let's look at it and we see. The temperature decreased, which means that the reaction is exothermic. Okay, they're saying that write down the potential diagram for this reaction. So automatically, if it's exothermic, then the potential diagram talk about exothermic. So the energy is lost. Yes, whereby here is gonna be AB, and then here just progress, reaction progress, and then here is the potential energy. Then it's gonna be A plus B, and then this is gonna be activation energy, and then this is gonna be change, enthalpy change, and then this is gonna be activation energy. So basically the graph is gonna be like that, but it wants to show that it is an exothermic reaction. We go to the next question. What are they saying? Initial is okay. Will the equilibrium constant Kc at 100 be greater than, less than, or equal to at explain your answer. Definitely is going to be greater than. Why? Because this reaction is exothermic. It is going to be favored by decreasing temperature, and then more products are going to be formed. And then once more products are formed, a Kc value is going to increase. Don't forget that Kc value can only be increased by temperature. All right. Then we go to the next question, which is question. The initial reaction takes place in the presence of a catalyst at this. Describe how the change will be observed on the graph at T0 and T60. When you say T0 to T60 here, definitely the catalyst just speed up the rate of chemical reaction, but that doesn't change how much is going to be formed at the end of the day. So basically it is going to shift to the left, but it finishes very fast. Even here it shifts to the left and then it finishes very fast. So basically that's what you were supposed to draw when it came to that. Thank you. Question for chemical equilibrium. We have smashed it. Then we go to the next question. Which involves calculations. Yeah, it involves good calculations. Okay. Question 7. Here they're saying that identify metal M in unknown metal carbon, yes, and then produce. Okay, procedure is carried out. You have this mass of impure with this reacting as nitric acid. Yes, so the excess nitric acid will react with this sodium is barium hydroxide. Okay, assume that the volumes were predictive. All right, the following reaction takes place, and you're saying that you have this plus this gives you that. Okay, define the term strong base. This is a definition. We usually talk about it, but please define it. Strong base basically it must be able to dissociate completely when it dissolves in water. Yes. So they are saying that the number of moles, calculate the number of moles of barium nitrate, barium hydroxide reacted with the nitric acid. So we have to use the excess, whereby this one is not that big deal. How do we calculate that? So in this case, we're gonna say that a number of moles of barium nitrate is gonna be equal to the number of moles of barium hydroxide that reacted with excess. So but here we know that we know that. So you can use first principles or you can use formula. Yes, concentration times volume, whereby number of moles is equal to concentration. You have the concentration, which is 0.15 times volume, which is 20 divided by 1,000. So that number of moles, let me check if I calculated it. Yes, I hope I calculated it. Yeah, it is equal to 0.003 moles. So that's how you can calculate the number of moles of that. And they're saying calculate the pH. The pH of solution after step 1. The pH of this solution after step 1 is determined by how much nitric acid was remaining. So in most cases, so this pH, because they said excess, so it means that we have to go for step number 1. Understand? Yes. But now we have to first compare the number of moles of barium nitrate, the number of moles of barium hydroxide compared to sulfuric nitric acid, because you know the number of moles of barium nitrate, barium hydroxide, then automatically we can find the number of moles. Okay, let's start by saying that mole ratio. Barium hydroxide to nitric acid. So barium hydroxide, barium is 1, and then nitric acid is 2. So what we're gonna do is we bring our barium hydroxide 0.03, yes, 2. So I have to multiply. It's gonna be 0.006. So this is the number of moles of nitric acid which are reacted with barium hydroxide. But now I need to find out the concentration of this in this 25 cubic centimeters. So I will say that concentration is equal to times volume is equal to number of moles. So we have the number of moles of 0.006 is equal to concentration, which is I don't know, times volume, which is 25. Yes, because we want to know how much is in the 25, but this is not decimeter cubed divided by 1,000. So that now concentration is going to be equal to this divided by that. Yes. So this times that divided by 25. So we just reciprocate it. And then now when you calculate, you get almost concentration 0.24 molar or moles per decimeter cubed. If you write capital M, it's still fine. So now C, the concentration is that. Now you need to take note of that, of this, before you go for this concentration. If this number of moles, if this nitric acid was a diprotic acid, I would have multiplied it by 2. But because it is a monoprotic acid, one hydrogen will be equal to the number of the moles of nitric acid will be equal to the number of hydrogen which are being produced. Understand? If it was sulfuric acid, I would have multiplied it by 2, because one molecule gives you 2 atoms, 2 ions of hydrogen. Yes. So I'm clear there. So now, since it is monoprotic acid, everything is supposed to be flowing. Then the pH is equal to negative log of hydrogen concentration or hydrozonium ions. So now we know already the concentration as this. So pH is going to be equal to negative log of 0.24 yes, and then the pH is supposed to be acidic, gives you 0.62. You can calculate and find out if it is the figure I've given is the perfect one. So yeah guys, that's how it's supposed to be obtained when it came to that. See, yes. So it was not that very difficult if you knew how to interpret it. Now let's go to the next question, which is percentage purity. Okay, in percentage purity, base showed me who is the boss. Sorry, subscriber, sorry. It showed you who is the boss. So who is the boss? Tell me who is the boss. Is it you or is the base? This calculation. Sorry. Okay. Let's go to so we are done with the pH. Those 5 marks. Let's go to the percentage purity of this. Now we need to analyze something. Before you start doing any calculation, you need to first analyze and see exactly what happened. Yes. Okay. Now they say that this is an impure with this mass, so it means that you're gonna use that mass, but they say that in that mass only 85% of it is what is pure. Only 85% of it is what is pure. So it means that we have to find out how much number of moles are in that pure substance. All right. Now, number 2, they say that excess. They reacted this with the nitric acid. Understand? But the excess nitric acid, you see, excess nitric acid was reacted with barium. But now we don't know how much we started with, how much reacted, and how much remained after reacting. So now we have to calculate all that so that we can score these 8 marks. So now, how much we started with, we can calculate. How much we used, we calculated it already. Then after that, we can subtract. When we subtract, then we can know how much was used. And then we can use that to compare, and then we find we can find the number of moles, and then after that we can find the mass. Did I say the mass? The molar mass. Let me just show you what I'm trying to say when it comes to this. Okay, let me start by saying that already now we know what is in excess. We calculated it. Did I rubbed it off? But we know what is in excess. So now what we're gonna start with is let's find out. So let's start with what is in here. How many number of moles are in here? Then we know how many moles which is here. Then after that we can subtract. Okay, say that 25 volume is equal to 25, and then concentration 0.4 molar. Let me just say molar, and then this one is cubic centimeters of what? Of nitric acid. Nitric acid. Now we need to find out the number of moles of nitric acid which is in here. So we're gonna say number of moles is equal to C. We have different methods. You can use these generals, but also first principles is still also fine. Times volume. So number of moles here is gonna be equal to 0.4 times 25 divided by 1,000. So number of moles here, when you do in the calculator, is gonna be 0.01. If you find an answer which is deviating a bit, please, it could be when I'm trying to press the calculator. Yeah, it could be, but the method remains the same. All right. So this is all the nitric acid which is in there, plus the excess, plus the one which reacted. Now let's find out what is in excess. Nitric acid excess. So nitric acid excess, we calculated it already, isn't it? By finding it here, isn't it? Yes, we calculated it already, and then we said that okay, let's do it. 20, still the same thing. Number of moles is equal to CV, whereby number of moles is gonna be 0.05, 0.15 times 20 divided by 1,000, so that I get to know remember it's supposed to be in decimeter cubed. Number of moles, this is the excess, the one which reacted with barium hydroxide, and this is the whole nitric acid. Yes, so the answer is going to be 0.003 moles. But these moles, these are the moles of barium hydroxide. You understand? But now you can use the mole ratio to find, because that's barium hydroxide. The mole ratio is 1 to 2. So it means that nitric acid is 2, while barium hydroxide is 1. So barium hydroxide is 1. So it means that if this is 0.003 for barium hydroxide, then nitric acid is going to be 2 of them, meaning that I have to say 0.003 times 2, which gives me 0.006. So these are the number of moles of nitric acid excess. Yes. So now once I get the number of moles of nitric acid in excess, now I can subtract this from this. So I'm going to say that number of moles of nitric acid used, because that's what we want. We want to know what is used, because the one which was used to react with this impure, so that yes, we know exactly. So now here I'm gonna have this is gonna be, let me see, 0.01 minus 0.006. You see, that is the number of moles. When you subtract, you must subtract it nicely, then 0.004 moles. So these are the number of moles of nitric acid used at the first run, the first instance. So now, since now I know the number of moles of nitric acid which got used, check. Now I know the number of moles of nitric acid which got used here. Now I can find the number of moles here, so that now I can use the number of moles is equal to mass over molar mass. Yes, so now since I know the number of moles which got used here, so now I can, let's do the mole ratio again. Mole ratio is equal to nitric acid. How am I writing it? Nitric acid to M carbonate. Yeah, and there is something which you need to know here, that this M, because this is it must have a charge of 2, so that, remember, carbonate is like this, so this M must have a positive charge, so that this cancel, and then you form M carbonate. So it means that this element is supposed to be in group 2. Yeah, must be in what? In group 2. So anyway, this is that. So we got it in, okay. I said this is 2, and then this is 1. Am I right? Let's go back. Yes, it's 2, it's 1. Good. Now, this is a number of moles, so this is 0.004. Yes, so automatically this is going to be 0.004 divided by 2, which gives me to be 0.002. So these are the number of moles of this. So now, once I get the number of moles of that, now I can find number of moles is equal to mass over molar mass. I can find it. Yes. How am I going to find it? How am I going to find it? All right. Number of moles now I have as 0.002, yeah, is equal to mass. Do I know the mass? Yes. They said it here. They say that only 85% of the impure, so it automatically, we have to first calculate this out, and then we find out which one is impure. So if you look at this, because they say that 85%, so I have 0.198, 0.198 times 85%. So this is going to give me the mass of pure sample. You understand? And then this gives me a figure of 0.1683 grams. So these are the mass. This is the mass I'm supposed to use. So in this case, I will say that 0.002, yes, I'm now substituting here, is equal to the mass, which is 0.1683, yes, then divide by the molar mass, M carbonate. Yeah, M carbonate. So M carbonate, because we don't know M what is M, but we know what is a carbonate, isn't it? Yes, we can find out what is a carbonate. So now, this we can find out by this goes here, because if I want to find this, so it means that M carbonate is going to be equal to 0.683, yes, divided by 0.002, which gives me 84.1. Yes. So now if I get 84.1, then automatically I'm going to say M carbonate is equal to 84.1. But now I need to find out what is M plus 12 plus 16, which is oxygen times 3, is equal to 84.1. So now, since I've got that, now I'm able to find out what is M. So M is going to be equal to, when you add this, is 48. This is 48 plus 2 is 60. So it's going to be M, then the 60 goes the other side. 84.1 minus 60. So M is going to be equal to 24.1. So I have to go to the periodic table and find out what is 24. What is 24? I have to come here to the periodic table, then I find out which element has 24 as the molar mass, which is here, and the answer is magnesium. So M is equal to magnesium. So that could be the answer, and that's how the 8 marks got or came from. So it came all our way, all along from there. 1, 2, 3. Yes. That's how we got, or that's how we were supposed to get that question. Yes. Then we go to the next question. So I'm saying that is less than because the forward reaction is endothermic. saying here. Let me check and see what you are saying. Okay. Let's go to the next question. Okay, I'll come back and then check and see. I don't understand what you are saying here. Because at temperature system decreased to this. No, they decrease the temperature at the forward reaction is endothermic. When they increase the temperature, they decrease the temperature. At 130, the temperature of the system decreased. Yes. I don't understand. I have to check see what you are saying. Yeah. Okay. I think that one is also done. Let's go to the last. This is the last. The second last question. All right. You are dying. You can't die now. I'll come back to you. I'll come back to you and then find out what you are saying. All right. Let's go to the next question. A cleaned pure copper. A cleaned pure copper. Question number 8. Yes. A cleaned pure copper is placed into a beaker. So okay, they placed it into the beaker. Question number 8. Okay, let me check and see. Okay. A cleaned pure copper strip is placed in a beaker containing colorless silver nitrate solution okay, shown. After a while, it is observed that the beaker becomes blue. Okay, what happened? Write down one other observable change that the solution beside the solution turning blue. So basically the solution turning blue because copper is dissolving. So another thing is the mass of copper is going to decrease because the copper reacts to form copper 2 ions plus 2 electrons. So the mass of this copper is going to keep on decreasing. So that's another observation. Then 8.1.2, name the formula of the oxidizing agent here. Oxidizing agent, it means that it is reduced. It means that it's supposed to be lower in oxidation. It must have a weak reactivity. So it means that is oxidizing agent. It means that for it is reduced. So in this case, copper versus silver, you have to go to the reactivity series. You'll find out that silver is down. Therefore, silver is down. Mechanism of reducing oxidizing agent. You see, silver is here while copper is there. Yes. No, it's this one. Because it's copper 2. Okay. Then we go to the next one. Are they saying that? Name the formula of the oxidizing agent. We are done with that. They say the formula, so you write it like that. Then they say that explain the answer by referring to the relative strength. So we have said that in this case, silver is a strong oxidizing agent so that it can easily reduced or receive the electron from copper. So silver can easily receive electrons from copper than copper receiving from silver. Why? Because copper is more reactive, so it is easily give out the electrons, and then silver is able to pick up those electrons which have been released by copper. Hence, it becomes silver becomes an oxidizing agent. It causes copper to be oxidized. That's why it's called an oxidizing agent. A galvanic cell is now set up using copper and silver strip as electrode. A simplified diagram of the cell is shown below. So if the simplified cell is shown below, okay, saying right name or the formula of electrode A. Electrode A. This is electrode A sharp. So since we are using silver solution, so A will be silver. And then solution B, because yes, this could be because it's silver, so in most cases we use silver nitrate. Therefore the same copper, so therefore it's going to become copper nitrate. It's copper nitrate. So did I say the formula? Yeah, the formula will be copper nitrate. Because copper is in group 2 of the transitional elements. Overall balanced net equation for the reaction. So automatically silver is what's going to happen. Silver is going to receive from copper. Therefore, we'll say that copper, basically copper gives you copper 2 ions plus electron. And then silver 2 ions plus 2 electron. Silver is 1. Plus electron gives you silver solid because it is reduced. Therefore, when you write this copper 2 plus silver ion gives you copper 2 ions plus silver solid. But now this is 2 electrons, this one, so I put a 2 here, I put a 2 there, so that is balanced. This is a solid, this is aqueous, this is aqueous, and that's a solid. So that is the equation which you're supposed to write. Then 8.4, they're saying that the salt bridge contains nitrate, sodium nitrate, potassium nitrate. They're saying that write down the ion that will be moving into the silver solution, and then choose potassium and nitrate. Obviously, because this one is reduced, silver is reduced, the strong oxidizing agent. So in this, the one which is reduced is always the cathode. Then one which is oxidized is always the anode. So, and don't forget that anode is the negative, and then the cathode is the positive. Yeah. So now the positive charge will go to the positive, and then the negative charge will go to the negative. Why? So that it keeps it be positive. Why? Because this is a negative charge, negative terminal. So electrons move from there to here. So when they move from there to here, it leaves this to be less negative and start to become positive. So what happens? So the potassium will the nitrate will come and then keeps it negative again. And then this one, the potassium, because now it receives the negative from this side, it keeps on neutralizing this, and then now it becomes less positive. So the potassium ion will come and then it makes it more positive so that the reaction can continue. So in this case, we shall say that potassium will go to silver, and then the other one nitrate will go to the copper. That is the question. Write down the formula of the salt into silver. So in this case, it is potassium. So you just say potassium ion. Give a reason, because silver is on the cathode, which is positive, and then the electrons try to neutralize the positive charges. Therefore, to prevent the cell from being impaired, positive charges must be supplied so that it keeps the terminal more positive. Yes. Then the last question, the last question. Okay, the last question. Let's writing geography. So you will make it. Okay, let's just go to the last question. Okay, the last question is saying that also requires some calculations. All right, let's see if we can do the calculations, and then we can win it. All right, they're saying that define electrolysis. Electrolysis basically is splitting water using electricity. Or use this other compound, you split them, decomposition of these compounds using electricity. So basically that's electrolysis. And then electro is electron, which means electricity, and lysis comes from the word split, which means you split the substance or decomposing the substance using what? Electricity. Yes. Write down the reaction that you need to first read. An electrolytic cell is electrolytic cell. It means it has a battery. Is put to purify this the piece of copper that contains silver and zinc as impure. And then they're saying that the simplified diagram of the cell is shown in the electrode sharp. All right. Now they're saying that what is the cathode? It's the cathode with anode. Okay, basically this is the anode, and then this is the cathode. Why? Because anode is where oxidation occurs, so it gives the electrons so that the electrons can move in that direction. And then the anode, the cathode, it's the positively charged, and this is the negatively charged. So yes, did I say that? Yes. Okay, now we are saying that now electron this is gonna dissolve, so it's gonna dissolve, and then in this case this what impure copper is gonna be this, and then the small pure copper is gonna be that. So it means that copper 2, which is a solid, is gonna give you copper 2 ions plus 2 electrons. Then the electrons will have to migrate to this side and then react with the copper ions from the solution, and then after that it forms more solid. So that now this one increases in the size. All right, let's go to the question and see. Write down the reaction that takes place at Q. Definitely, because we say that copper ion 2 ions plus 2 electrons gives you copper solid. Why? Because now it moves to that side, and that's where reduction takes place. So this is a reduction. Yes. In which direction does the electron flow in the external circuit? Okay, we have said it. That's the direction of electron, and then I'm saying that calculate in which direction also. So it means that it's gonna be R to Q. R to Q. They are saying calculate the current needed. To form 9 grams of 9 grams of copper when the cell operates. This you have different methods you can use, but also you can use first principles. It's also cool. But now you need to find out how many number of moles. So you have these formulas. You have these formulas which you're supposed to use. See? Yes. So basically, we're gonna say that number of moles, we need to find the number of moles. Number of moles is equal to the 16 divided by the molar mass of copper, which is 63.5 from the periodic table, and then it gives you 0.252. Maybe they'll give you a mark there, sharp. Then after that, but now I need to know how many electrons are supposed to be now we are converting these moles into number of moles in terms of electrons. So now it's going to be copper 2 ions plus 2 electrons gives me copper solid, so that it is deposited in here. And then now it means that each 1 mole of copper requires 2 electrons. Therefore, I will say that 0.252 times 2 will give me 0.5039. These are the moles, yes, moles of electron. Understand? Yeah, for that reaction to take place, that reaction to do what? To take place. Then you have another what are you supposed to do here? Now we need to convert this into charge. So let's convert this into charge, whereby we apply the Faraday's law or Faraday's constant, whereby charge is going to be equal to 9648385. That is a constant, yes, times this number of 0.5039. So basically the charge here is going to be equal to 4.862 times 10 power 4. Yeah, and this charge is measured in coulombs. Understand? Yes, after finding the charge in coulombs, then it means that it's easy. But check here.
Basically, it is a molecular formula. If I divide by 2, divide by 2, divide by 2, here I'm going to get C3H6 and then O like that. So do we have anything like this on this question? Yes, the answer becomes D. So that's how you could get your 2 marks. By the way, if you have any question, let me know so that I can address it, as this class is live. Then let's go to number 2. Number 2, they're saying that which intermolecular force are present between molecules of this. So what is this molecule? You have to first identify which molecule is this. If you look at this last group, it shows that it is either a ketone or an aldehyde. So if we take it to be an aldehyde, so it's going to be like that, and then the rest of this are just carbon atoms and then hydrogen, carbon and hydrogen, let me just call it alkyl group. So meaning that the number of carbon atoms are there, meaning that there are 7 of them. So which kind of intermolecular force of attraction which exists here? This is we experience here a dipole force. But carbon atom and hydrogen, it has what called the London forces. London forces. So it means that this molecule will have the dipole force. Look at which one has dipole forces, and then London forces only. There is no hydrogen bond here. Why? Because hydrogen is not bonded to oxygen. So hydrogen is scooped out. So the answer becomes B, and then you get your 2 marks there. Then we go to the next question. They're saying that yes, the structure formula, the structures of organic compound are shown below. Then they're saying that which of compound will decolorize bromine water. So here, I was emphasizing this when I was doing the final revision the day before. And then I was emphasizing this, that bromine water will only be decarboxylized if you have a double bond between carbon atoms or a triple bond between the carbon atoms. So basically, you have to look at that. The double bond is there, but it's not between carbon atoms, so this is out. There is no double bond here, this is out, so the answer is supposed to be related to compound 2 and compound 3. So we come here, we find compound 2 and compound 3 becomes B. So B becomes the most correct answer. Yes, Kevin. Oh, you removed the message. All right. Let's continue to the next question, and then we see. They are saying that which of the following statement best explain the role of catalyst? Catalyst. What do they do? They give an alternative. Basically, they give an alternative way in which a reaction can take place. And then in this alternative way, it increases. It means that it allows, it allows compounds to react faster. Yes, for example, you want to go from wherever you want to go. Let me just give an example. You want to go to Pretoria. You are from maybe Kasi, and then what happens? You don't have enough money for the taxi. What is another alternative you can use? You can use a train. So train becomes an alternative way. So it becomes a catalyst for you to reach Pretoria. You understand? From where you are coming from. Why? Because the price is a little bit what? Less. So when you look at it, you have to look at something which has lower activation common, no, increase the concentration, no, provide alternative pathway with low activation, yes. But let's look at the last one, it increases the activation, no. So the answer becomes C. So C becomes the most correct answer. Then let's go to 1.5. They are saying that the energy distribution curve for a fixed mass of a gas at two different temperatures. So in this case, what are you looking at? Two different temperatures, okay. What's the question? Which one of the following is correct interpretation of the curve for change in the temperature T1 and T2? T1 and T2, okay. Let's look at it. Activation energy, what about it? Stays the same. Activation energy stays the same. Okay. Yes. Why? Because when you increase the temperature, you're increasing the number of particles which have sufficient energy, but the activation energy does not change. It will remain the same way. The minimum energy required for the reaction to start remains the same. But what you do is you just boost the other particles so that they can reach that activation energy. So the activation energy remains the same. So it could be A or D. The number of effective collision per unit time increase definitely. Here this is wrong, so this makes this one to be out. So these ones are out already, so we can't talk about them. So the most correct answer is the most correct answer here is what? Is A. Then the next question is asking the next question. Each of the reaction represented below is at equilibrium in a closed container. In which of the reaction will increase in a pressure? In which of the reaction will increase in pressure? Which of the reaction increase in pressure favor the formation of product? Favors the formation of the product. So in this case, increase in pressure means that you're decreasing the volume. So it will favor the reaction which will have minimum amount of moles. Yes, meaning that if you have 4 versus 2, it will favor the one which has 2 because you have increased the pressure, you are decreasing the volume. So in this case, we have to look at what this is 1 mole, then this is 2 moles. So it can't form that. This is 1 mole, this is 2 plus, this is 3, this is 2, this is 1, this is 1, this is 2. So you see it's the same trend. This is check. This is 4, and then this is T. So it shows that it will be increasing that direction. This is T, and then also this is 2. So this is equal. So basically, because they say that will increase the pressure, favor the formation of products. So because it's small volume, small number of moles from big number of moles or large number of moles, whatever. So it gives you C to be the most correct answer. Then you go to number C. Number 7, container have A and B is illustrated below. So in this case, you have to look at 20 cubic centimeter of sodium hydroxide solution in the beaker is added to a solution of sodium hydroxide solution beaker 2, which of the following represents the correct calculation for the new concentration of sodium ions. They are looking for sodium ions in beaker. So in this case, what you need to look at, don't forget that they are saying that they're not saying that all of it is going in there. No, what they are saying that is only 20 cubic centimeter is being added. Yes, meaning that you have to find the number of moles which are found in here in 20 cubic centimeters. So in this case, they're also saying that. So basically, when you add this to this, you find out you have 170 cubic centimeters, and then it means that if you put it in decimeter cubed, you find out you have 0.17. So it means that if you don't have 0.17, so this one becomes wrong. So basically, the most correct answer becomes A. So that becomes the most correct answer. Then 1.8, when the galvanic cell delivers current, the purpose of salt bridge is to what is the function of the salt bridge? If you check in our distinction material for was clearly it is clearly indicated there that the function of the salt bridge is to bring about electrical neurality. Why? Because this one requires some bit of explanation. But why is because you find out the positive charge and the negative charge. The one which is positive will be receiving, will be giving out electrons to this side, and then the oxidation will take place there, and then you will find out that it will become, the positive charge, for example, positive charge and negative charge. The positive charge you receive the negative one, and then the negative one will be receiving the positive one. So meaning that the negativity is going to keep on decreasing, and then the positivity is also going to keep on decreasing. So what is the function of the salt bridge is to bring back the ions. For example, the potassium ion will come, which are positive, will come to the positive charge, and then nitrate will go to the negative charge, so that it keeps this continuous. So it means that it brings about this reaction to continue to go in that manner, whereby it does not stop, it continues to be spontaneous. So because these ions are being neutralized by these potassiums and then the nitrates, so it brings about the salt becomes neutral, so that to prevent that, the cell from stopping producing energy, this salt bridge is supposed to give these ions, hence to ensure this electrical neurality in the cell, and the answer becomes more B, or B becomes the most correct answer. That one requires to watch a full video when I explain that, if you don't get it now. So you just go to Thundereduc and then search for that subtopic. Which of the following metal is the strongest reducing agent? So here you have to look at which one is. When you talk about a strong reducing agent, it means that it's oxidized. So the oxidized component, it means that it is high in the reactivity series. So if you look at it here, if you check here, you'll find out that the one which is, you have zinc, aluminium. So you come here and then you check it. You look at it, lithium on top. So you'll find out that the one which is on top, if the one which is on top, if lithium is here, so you see that as you go up, you're increasing the strength of the, not that one, this one. Yes, you're increasing the reducing ability or reducing agent, meaning that as you go up, if you are there is one which is up, becomes more oxidizing agent, and then down becomes becomes more reducing agent because it is oxidized, and then down one it becomes more oxidizing agent because it is reduced. So when you come back to the question, you'll find out that the question is saying yes, the question is saying that which one of the metal is the strongest reducing agent. So in this case, when you go to the reactivity theory, you'll find out that aluminium is above all. Yes, aluminium is above all of them, meaning that aluminium is going to be the answer in this regard. It can reduce all of them. It can reduce silver, zinc, copper. So it means that aluminum is a strong reducing agent. For it, it is oxidized. Then we go to the next question. The gaseous chloride used to disinfect water in public swimming pool reacts with the water according to the following balanced equation. The addition of chlorine gas the pH of water in the swimming pool. Which of the following? So basically, you have chlorine plus hydrochloric acid give you hypochlorous plus hydrochloric acid. So they're asking you the addition of chlorine gas, the pH of the water in the swimming pool. Which of the following substance must be added to the public swimming pool periodically to increase the pH? Meaning that to reduce the acidity of this. So when you say increase the pH, it means that you are trying to increase the alkalinity of that substance. So in this regard, it can't be this. It can't be this. It can't be this. It must be this. Why? Because when sodium carbonate reacts with any acid, it could be the hypochlorous or this, it is gonna reduce this. How does it gonna reduce this? It's gonna reduce this by giving sodium the salt, maybe sodium chloride, whatever, and then plus carbon dioxide plus H2O. So it makes it a little bit neutral, and then the pH starts to increase. So B becomes the most correct answer. Why is A wrong? Because the salt bridge is completes the circuit. Yes, yeah, it's one saying that why is A wrong? Because the salt bridge completes the circuit. Yes, which question was it? Don't remember that. Okay, let me just explain. In most cases, when a voltaic cell delivers current, check. It means that it's already delivering the current. They're asking you, yes, it's already delivering the what? The current. You see, the reason why A is wrong is you're saying that it completes the circuit, but they are saying that it's already delivering, meaning that the circuit is already complete. You see, the answer could be correct, but what is the most correct answer? Yes, this statement makes it because they're saying that when a galvanic cell delivers current, the purpose of the salt bridge, meaning that the current is already, the circuit is already complete. Then, if the current is already complete, what is the function of the salt bridge? That's why B became the most correct answer. I think you have got it right. So please don't rush. Don't rush when it comes to questions. Why? Because in most cases there are some questions which are hidden. It requires you to at least to think twice before you get the most correct answer. So let's look at the organic very fast. We talked about this before even the paper. Consider organic compound A. Okay. Is it a primary or secondary or tertiary alcohol? Give a reason for your answer. A, look at this carbon atom in the OH group. It has 3 carbon atoms which are attached to it. Hence, it becomes a tertiary alcohol. Sorry. Then they're saying that write down the give a reason for your answer. Here you can say that the carbon atom to which the functional group or which has the hydroxyl group is bonded to 3 other carbon atoms. Is bonded to 3 other carbon atoms. Yes, so that becomes the most correct answer. Then they are saying that write down the APAC name of the above compound. They want you to write the APAC name of this compound. So what are you going to write here when it comes to this? Saying that, so you have to look at the longest chain. So in this case, what is the longest chain? The longest chain is 1, 2, 3, 4. 1, 2, 3, 4. So 4 becomes butane. Remember I told you that you write up to there. The side, so it means that this becomes the side group. So it becomes 1, 2. So it is on carbon atom number 2, or because if I count from this side, it's on carbon atom number 3, 1, 2, 3. So I'm gonna go with that. And then now I have to keep the direction. So 2 or I have a methyl. So I have methyl, it's meth, because the side group becomes methyl, and then it is on carbon atom number what? It's on carbon atom number 2. So it's gonna become 2-methyl butane 2 or. So that becomes the most correct answer. So in most cases, we mark you for the methyl and we mark you for the parent chain. Then they're saying that the above mentioned compound undergo elimination reaction. Write down the structure formula of the above product. The above reaction, above mentioned compound undergoes elimination reaction. Write down the structure formula of the major product. When this undergoes elimination method, so what is going to happen here is going to use what's called the mechanical flow. So this OH is going to be lost. So the compound which is going to not the compound, the atoms which are going to be involved is this carbon atom and this carbon atom. Why not this carbon atom? Because here I have only one carbon atom, while this one has 2 carbon atoms. So the inductive effect, okay, we don't study inductive effect here, but the force from this side is going to be greater. Therefore, it is this carbon atom which is going to be involved. Therefore, it's going to lose a carbon, a hydrogen, and then loses this so that it forms water at the end. And then this one, since they say the structure formula, therefore it's going to be C, 2 of them, then it's a double bond, and then this. So basically it's going to look like that. So the number of 1, 2, 3, 4. So these are hydrogens. So the double bond is introduced here. This is what I'm saying, that it's going to be like that. So this one I've just drawn it down, but it's the same thing. And then this one is this. So basically the compound is going to be like this with hydrogen throughout. If you don't put your hydrogens, you're going to lose it. You might only get the one for the functional group. Yes. So the next question, they're saying that the above mentioned, okay, we are done there. Compound, consider the organic molecule B. When you talk about organic molecule B, which one is yes? Pentan 3-on. Okay, how about it? They're saying that consider, okay, we have considered it. Define functional isomer. Whenever I talk about functional isomer, isomers, they have the same definition, but what they have stated there is what changes. Organic compounds with the same molecular formula. That is, whenever they ask you about what is Isomer, whatever isomer they have asked you, it's the same thing. Organic compounds with the same molecular formula. If they say position isomer, but different position of organic molecules, functional isomer, organic molecules the same molecular formula, but different functional groups. So like that. Structure or chain isomer, so it's the same thing. So in this case, because they're asking about functional isomer, is organic molecules the same molecular formula, but different functional groups. So that's how you're supposed to define that question. Then they're saying that the homologous series to which the above mentioned compound belong. To which homologous series? Homologous series to which the above mentioned compound belong. Compound B. So compound B, it is a keton. So it belongs to ketones. Then they are saying that IUPAC name of the functional isomer. Functional isomer. If it is pen-3 on, then the functional isomer is going to be an aldehyde, which is pentanal. Pentanal. Simple. The letter that represents its positional isomer, meaning that when you talk about its positional isomer, so we have to look at it. Must be of the same culture. It must be the same keton, because they're saying positional isomer. So 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5. It's 5, and then this one also 5. This is the carboxylic acid. This is ester. Yeah. So it becomes E, because it's the same thing as a keton, but in this case it is pentan 2 on, and then this one is pentan 3 on. So that it means that one becomes the most correct answer. That's yes. So we have got it. Write down the balanced equation for molecular formula of the complete combustion. Whenever they ask you about combustion of anything, the product I told you that is always carbon dioxide and water. And then the only challenge where it comes from is when they ask you to balance. Obviously, you have to balance, but they're saying compound E. Compound E. So it means that how many carbon atoms is 1, 2, 3, 4, 5. So I'm gonna come here and I say there are 5 C, 5. How many hydrogens? 3 plus 2. That's 5 plus 2. That's 7 plus 2. That's 3, 5. Did I say E? Let me check. Oh, F. Sorry guys, it's in F. Okay, is 3 plus 2 times 3. You see, this is 6 plus 9, 12. Hydrogen is 12. Carbon is 1 plus 3, which is 1, 2 plus 3, which is 5. So it's meant the same thing. So basically it's like that. When they said combustion plus oxygen, yes. So that's the first, that's the reactant. And then the product is obviously is going to be carbon dioxide plus H2O, of which it's 6, 5, it was supposed to be 8 there, and it was, yeah, and then it's balanced. So combustion, always this is the product. You understand? Yes. So we come, we give you for writing the correct symbols, we give you for writing the reactant is basically correct, and then balancing it, obviously balancing is gonna get 1 mark in that regard. So yeah, that's how we were supposed to write this and get those 3 marks. Let's go to question 3. What are they saying on question 3? Is there anyone who has a question? Someone is saying that I'm not sure. I want 1.2. in the multiple question, choose alkyl. I try to explain that. F not E. F not E. 1 point. Okay, I'll go back there maybe when I'm done with this, and then I don't understand what you're saying. F not E. If not E. Metric Mokatu. Please try to elaborate on your question. Okay, let's go to the next question, and then they are saying that the structure formula, the structure isomer with the molecular formula, this are used to investigate the effect of branching of on the physical properties of hydrocarbons. So here we are talking about the branching. Don't forget that we have three things when you talk about the properties. We have the boiling point, melting point, and then boiling point, melting point, and then vapor pressure. Vapor pressure increase as the branching increase. Melting point decrease as the branching decrease. The boiling point decrease as the branching increase. Yes, you have to know that principle so that at least you are able to understand all the questions. They're saying the results obtained for the first two investigations are shown in the table below. Here, a little bit straight, more branched. How many branches are these? Yes, and then here, 1, 2, 3, 4. 1, 2, 3, 4. Okay, more branches. All right, let's go to the question. They're saying that define boiling point. Boiling point is the point at which the temperature of is the boiling point is the temperature at which the solid and the liquid phases of the substance are at equilibrium. That's what's called the melting point. The solid and the liquid are at equilibrium. Their phases must be at equilibrium, meaning that what goes to the solid is what goes to the liquid. But don't forget that in this case, this is all or nothing law, as I explained that. It's a definition. You don't give all the points, you get 0. We don't have here trying, no. Write the independent variable in this investigation. What do you think is the independent variable in this investigation? If you look at it, basically the boiling point, the melting point, or the boiling point or melting point, one of the two, will depend on this ABC. But how about them? It's the same compound. So it means that how branch it is, the length of, it could be the length of the chain or the branching. And this branching is going to result in the surface area. How big is the surface area? Yes. So the answer could be the branching, or it could be the chain length, or it could be the surface area. So whatever you give, it could be correct. Then they're saying that explain why the three organic compounds are called structure isomers. Why are they structure isomers? So we say that what are isomers? Isomers are molecules with the same molecular formula, isn't it? We talked about it. Yes. But we are saying structure, meaning that what is changing is the structure. Simple. A different structure formula. They have the same molecular formula. But the structure, how the atoms are arranged in space or in vicinity, is different. But everything is the same. Only the arrangement of the atoms. Therefore, they are isomers. If you count the number of carbons, they are the same. Count the number of hydrogens, are the same. Hence, they are structure isomers. They are saying that. Explain why. Okay, I'm done. Write down 3.4. Write down the type of intermolecular forces present between the atoms. Don't forget that all these alkenes, The moment the alkanes, then the type of intermolecular forces of attraction, alkenes and the alkynes, the type of intermolecular force of attraction is London forces. So we only talk about London forces. Yes. And then they're saying that explain the difference in the melting point between A and B, between molecule A and B. So what are you going to talk about? The melting point. They're saying explain the difference in the melting point between A and B. If you look at A, the melting point is negative 154, and then B is 29, meaning that, yes, in this case, the melting point as what are you going to talk about? So let's go to molecules, and they said A and B. So if you look at A, the more it's branched, the more it becomes spherical. You understand? So in this case, this one and this one. So this one is more spherical than this. So you can say that this one is less spherical, and then this one is more spherical. Since this one is less spherical, therefore it has weaker intermolecular forces of attraction in that regard, and then this one has strong intermolecular forces of attraction. And since it has weak intermolecular forces of attraction in terms of this melting point, therefore it's going to have a lower melting point. Well, this one has, because of its spherical nature, it is going to have require more energy to break it, therefore it's going to have a higher melting point. But when you say it has a higher melting point, because you're comparing the two, then it means that the higher melting point is B compared to this, not comparing to this. So you're comparing to that. So basically, less spherical, more spherical. Okay. Then this one, since it's less spherical, it means that weak intermolecular forces of attraction, more intermolecular forces of strong intermolecular forces of attraction, less boiling point, more boiling point. That's why you see it in that regard like that. This is more negative, and then this is more positive. Yes. As I say that, as for the case of the melting point, the more branches, when the branching is happening, it means that you're going to have strong intermolecular forces of what? Strong intermolecular forces of attraction. So the melting point becomes more positive than more negative. Yes. And it is the reverse for the boiling point. They are saying that explain why the three compounds are called this. Okay, we're done with that. Okay, we're done with that also. Then they're saying the investigation 3, the vapor pressure is measured in millimeters of mercury at 25 degrees C. Okay. Use the information in investigation 2 and then match the correct vapor pressure of this. So you're going to look at which one has the higher boiling point, is going to have the lower vapor pressure, as I explained before I said this question. And then explain your answer fully. So in this case, you're going to say that we come here and then we look at it here. Which one has a higher boiling point? This one has a higher boiling point, so it's going to have the lowest vapor pressure, lowest. So A must be the lowest, then this one is next, it's going to be the next, and then this one is going to be the last. So A, it must have the lowest boiling point. Let's go to the lowest boiling point. Sorry, vapor pressure. So it's going to be A, you see? And then followed by B is supposed to be, then this one is going to be B, because it has the second last vapor pressure. And then this one has the highest vapor pressure because it has the lowest boiling point. So it's going to be C. Yes. So basically it's supposed to be like that. Explain your answer. The boiling point of A is higher than that of B. Therefore, the higher the boiling point, the lower the vapor pressure. Basically, we say that the boiling point of A is higher than that of B when you looked at it. And then we say that the higher the boiling point, the lower the vapor pressure. You understand? Yes. Or in the reverse. You can write it in the reverse way depending on, you can say that B, uh, A has, B has a higher boiling, a lower boiling point than A. Therefore, the lower the boiling point, the higher the vapor pressure. You see? So you can write in a reverse way or in a positive way. Still, we will give you a mark. But these principles, they apply depending on the what? On the subject. Yes, you might think that it is going to apply even in another subject. It might not be the same. Then we go to the next question. The next question, what are they saying about the next question? Next question, they're saying that the following diagram, the flow diagram below shows ethene can be used to prepare the various compounds A to F represented. Okay. Identify B. What is B? Identify the type of reaction represented by B. B is from here to here. So that's elimination method. Or what are you removing? You are removing the water there. Therefore, it is dehydration. So A is away. Then they're saying that B from here to here, from a alkane to an alcohol. So you are substituting. So it becomes substitution or hydrolysis. You can use hydrolysis. Why? Because water must be there in that reaction. Write down two reaction conditions for B. When talk about B, where is B? From this to this, what are the two? Because you are dehydrating, so whenever you talk about dehydration, you must have concentrated sulfuric acid and then some bit of heat. So heat is sometimes use concentrated sulfuric acid or concentrated phosphoric acid. It could be sulfuric acid like that or phosphoric acid, depends on what you wanted to write. Then they are saying that the chemical formula of the catalyst needed. What is the chemical formula? 3.4.2. No, man. They're saying that write down the reaction. Oh, two conditions you're done that. For reaction A, all right, write down the name of inorganic reactant. Inorganic reactant, in the moment you are forming alkene to alcohol, you have to use H2O. Water must be present. And then they're saying that catalyst, chemical formula of the catalyst. Chemical formula of the catalyst. Yes, it still is the same acids which you can use, because sometimes you call it acidified water. So you acidify the water there, and then yes. They are saying that reaction structure formula, write down the balanced chemical equation. Balanced chemical equation for the structure formula of reaction C. When you come back here, you look at reaction C. Where is reaction C? From here to here. So it means that here, you just have to write, here, just have to write from here to here. They say C. They said from here to here. So this one is acting without, because they said ethene to bromoethene, meaning that I'm gonna have a bromine there and a bromine there, and then hydrogen. So meaning that I'm gonna put did I say bromo, not dibromo? So it means that what I'm going to use, I'm gonna put a hydrogen here, and then I'm gonna hydrogen bromide. Yes, if it was dibromo, then it would have been bromine only. Yes, so basically, you put hydrogen, you put hydrogen, you put hydrogen, you put hydrogen. That's what they are talking about. We give you a mark there, we give you a mark there, we give you a mark there. And then they're saying that chemical formula of the catalyst. So we're done with that. Structure formula. Explain why no water is needed. Basically, you don't add water so that you avoid the formation of the alcohol or the hydroxyl group. That's why there is no water which is added in that reaction. The moment you add water there, then it's going to form alcohol. Reaction E represents the conversion of alcohol into inorganic compound X. Okay? Formation of alcohol into an inorganic compound X. Reaction E. So it means that this E, because you have alcohol, you have a carboxylic acid, so E it becomes an ester. So how many? 1, 2, 3. So it's 3 carbon atoms. Ne? Is it 3? No. It's 1 plus this. So it's 4, 5. So there are 5 carbon atoms. And then here is 1, 2. So it's going to be ethyl propanoate, because 5 pentanoate. If this compound is going to become ethyl pentanoate. Okay, let's go to the question and see what are they saying. The type of reaction, esterification, we know that. I talked about it even. The catalyst used sulfuric acid. I told you, whenever I talk about esterification, it's sulfuric acid. Structure formula of compound X, you see? Even I saw the IPAC name of compound X. Structure formula of compound X is the same thing here. Structure formula of compound X. Yeah, I said ethyl, because this is 1, 2 is ethyl, and then this 1, this is 3, so it's 4 plus 1, it becomes 5, pentanoate, ethyl pentanoate. So you write the structure formula, of which structure formula, they said structure formula. That's the alcohol. Remember, the alcohol gives us one oxygen, and then another oxygen comes. This one comes from there, and then they said the structure formula. Yes, so you put the 5 carbons, 1, 2, 3, 4, 5, and then you put the hydrogens throughout. So basically, that's what they wanted. Ethyl pentanoate. Then yes, I think I'm done with that. I think compound F takes place in presence of warm water. And then the concentrated sodium hydroxide, use the condensed structure formula, write down the balanced equation for the reaction. So in this case, what are they looking at? They're saying compound F. Compound F, where is compound F? They're saying compound F, where is compound F? Yeah, compound F. Oh, reaction F. So basically, what are they looking at? They are looking at for you to write the balanced equation. The balanced equation, how are you going to write it? From here to here, meaning that's just a reverse. So in this case, you just add sodium hydroxide. Add sodium hydroxide, and then the bromine is gonna replace. It's gonna replace. Sorry, it's gonna not to replace. It's gonna remove sodium bromide, and then water from here, and then 2 hydrogens are being lost. This is what I'm saying. Ethyl brom. It said bromo ethane. Then add the sodium hydroxide. Then you're gonna form this, which is ethane. Yes, plus what? Plus now, this is gonna react with the bromine from sodium bromide. But what about this hydrogen? This hydrogen is gonna react with another hydrogen here. so that now from here another hydrogen from here, so that it becomes 2 2, so that you form this. So plus H2O. You get a mark, you get a mark, you get a mark, you get a mark, something like that. So that's what you're supposed to get from that reaction. Then the next question. Question was 3.7. 3.7. Saying that large straight chains, alkane can be catalytically cracked in to produce short chains. We call it cracking. Yes. Alkanes and then branch alkanes, okay, which are more suitable for use in petrol. The reaction below indicates the catalytic cracking of octane. Octane is 8. So meaning that when you do 8, so what happens? You break it into smaller pieces. So write down the epoch name of Y. What is Y? Now I don't know, but this was 8 of them, but I have 2 of them. I've removed them. Then definitely this one is gonna be hexane. Why am I saying hexane? Because it was 8. 1, 2, 3, 4, 5, 6, 7, 8. So I removed the 2. So what I'm remaining with is gonna be hexane. Remember, all these are hydrocarbons, so it's gonna be hexane. So what is? I think I'm done with that. Briefly explain why short chain alkanes are branched and branched chain alkanes are more suitable for use in petrol than straight chain alkanes. Why? Why are they more suitable? They are more suitable because short chain alkanes they have they are more suitable because they have a lower boiling point. So the intermolecular forces of attractions are less. Therefore, they have a lower boiling point. Therefore, they are more flammable. So they can burn easily to produce energy. You understand? Yes, that's why they are used like that. Oh, we are going to the next question. So it means that those people who manage to get all those marks, you are able at least to see that the paper was not that difficult. Let's go to the next section where it involves calculations, and then we see. If you have a question, let me know. If you have a question, let me know. All right, let's go to this question. The following apparatus is used by the group of learners in investigation to find out how the surface area affects the rate of reaction. Yes, how the surface area affects the rate of reaction. They're saying between excess, this word is very important, excess solid of magnesium ribbon with the dilute nitric acid. Yes, meaning that sodium, this one is in excess. Magnesium ribbon is in excess. It can't be a limiting factor. So we get it from downward displacement of water, or what you call, yes, upward derivative. So one of the two methods is the same thing, or if they ask you the method. During the reaction, the gas formed is collected in the measuring cylinder. The balanced equation for the reaction is, here is the balanced equation, meaning that this was in excess, they said it. So you need to know that excess. All right, let's start. So they're saying that in experiment 1, they plotted, okay, below. What is the question? Beside the mass and volume of the experiment, give one other variable that must be kept constant. Did they talk about heat? No. So maybe temperature. Temperature must be what? Must be kept constant. Did they talk about the concentration? Concentration must be kept constant. Concentration must be kept constant. Then question 2, they're saying that write down the independent variable. Write down the independent variable. Write down the dependent variable. What depends? What depends? What depends? The rate of reaction. or the volume of the gas you have collected will depend on the concentrations, maybe depending on, yes. So basically the volume of the gas per unit time you have collected is dependent. So that's why it is on this. And then they're saying that use the graph to calculate the average rate. Use the graph to calculate the average rate of reaction, 2.2, between 2 and the average rate. Okay, now let's go. 2 minutes. So 1 minute is 60. 2 minutes is 120. So I have to look for 120. So 120 is around here, isn't it? Yes. Because each let me look at the original paper. I hope you have the paper there with you. No? Oh, so if you look at this, each small box, it was, let me see, it was 10. So meaning that 120 is its first box, second box is there. And then 2.5, 2.5, so it means that you have to add 120, 130, 140, 150. So it's 150. So meaning that you have to do here. Yes. So when I do it, it's around the final is around 48, and the initial is around 42. So I'm gonna say, don't forget that the rate is change in the volume or concentration of the product divided by the change in time. So rate is gonna be is equal to change in the volume over change in time, whereby the volume is equal to gonna be 48 minus 42 divided by, I started it from 120 to 150, and then when I divide, you end up having 0.2 centimeters per second. You understand? Centimeters cubed, né? Because this is measured in cubed. Centimeters cubed per second. Yeah. So that was supposed to be the answer. Then we go to the next question. What is the next question? Okay. They're saying that will the rate of reaction be at 250 greater or equal to or less than at 250? If you look at it, the graph is 250. Is approaching constant or equilibrium completion. Do you think it's gonna be greater than, equal to, or less than? However much the graph is still going, there is an increase, but the increase is not as that fast as this. So it's gonna be less than. The rate, they're talking about the rate. They're not asking you about the increase. They're asking you about the rate. So they will be, we call it increase on a decreasing rate. The increase is there, but not that as faster as it was before. So that is that's the meaning. So it's gonna be less than. Why? Because the steep or the gradient is less than at 120. The steep at 250, if you look at it here, the steep here is not as that great as at 120, you see. So the increase there, but not that much. Therefore, the answer is going to be less than. Then we go to the next question. What are they saying about the next question? The next question, they are saying that will the rate, okay, done. Predict how the gradient of the graph for the experiment 2 compared to experiment 1, right? Increase, decrease, or remain the same. Experiment 1. Yeah, look at the division, the state. This one is cut is small. Definitely, this one is one large piece. So the reaction, the graph is gonna be less than, or it's gonna be decreased. It's not that. If you look at even the slope, if they asked you to redraw, it would have been like that maybe. You understand? So the rate is too slow, so it's gonna be decreased. And then they're saying that calculate the mass of the magnesium that remained in the conical flask when what? When the reaction has stopped. Assume that the molar mass is 24 decimeter cubed. So the moment you have the mass, so what is the, in this case you have the volume and then you have the molar volume. Okay? Yes, you have the volume and then you have the molar volume. Therefore, now you can find the number of moles. Yes, you can find the number of moles since you have the volume and then you have the molar volume. So, how are you going to get the volume? They said it here. Yeah, they say that in the following year you find out the surface area of this diluted in nitric acid. And then they come here, they say that calculate the mass of magnesium. Yes. So the first thing you need to do is to calculate the mass of magnesium metal. Yes. That remains in the conical flask when the reaction has stopped. Assume that the molar volume of this is this. All right. Now you come here and then you look for the volume. So if you look at it here, the volume is 60. Let me just clean up here so that I use here. So first of all, you need to find out the number of moles. How are you going to find the number of moles? Number of moles is equal to volume over molar volume, of which molar volume is 24 decimeter cubed. And then the volume here is 60. But this is decimeter cubed, while this is cubic centimeter. So I have to convert 60 into decimeter cubed. So 60 divided by 1000, so it gives me 0.06. So I'm going to say that number of moles is equal to 0.06 divided by 24. So number of moles is going to be equal to, so you calculate 2.5 times 10 power negative 3. So those are the number of moles. So since I've got the number of moles, so number of moles, this is the number of moles of the gas produced. So now I can compare that the gas produced, which is hydrogen, number of moles of magnesium compared to the number of moles of hydrogen, yes, is molar ratio is 1 to 1. How do I get molar ratio 1 to 1? Is from the equation. Magnesium to hydrogen is 1 to 1. So if I have 0.25 moles of hydrogen, how many of magnesium I'm going to have? It's the same thing. So it means that number of moles, therefore number of moles of magnesium is going to be equal to 2.5 times 10 power negative 3. You understand? So, but they are looking at the mass. So how do I get the mass? Don't forget that number of moles is equal to mass over molar mass. So I have the number of moles, yes. I have the mass, Do I have the mass? No. Do I have the molar mass? Yes. I go to the periodic table. On the periodic table, it was found out that it is what? Periodic table, magnesium is 24. Yes, magnesium is 24. So it means that to find the mass is going to be mass, molar mass times number of moles. So it means that I'm going to multiply here by 24. So the number of mass is going to be equal to 0.066 grams. So those are the number of moles. So the mass magnesium used, isn't it? But the question is asking, what is the question asked? Assume that calculate the mass of magnesium that remained. You understand? That magnesium that remained, this is the mass of magnesium which was used. You understand? So they want to know how much magnesium remained. If you come here, we started with, because they said that it was in excess, we started with the 2. So it means that what I used, when you subtract it, so therefore I'm gonna say that the magnesium used is gonna be 2 minus 0.06 grams. So it gives me 1.94 grams of magnesium. So this is a 1.49 grams of magnesium was left. Class, are we together? Are we together? Yes, let me know, eh? Let me know if you have any question. Yeah, as I'm here to help you out. All right, let's go. I might go for a short break, but I'll let you know when that short break is coming, maybe for 5-10 minutes, né? Yeah, so that I can have something to drink, né? I come back when I'm more energetic. Yes, let's go to the next question. Let me finish this question, and then maybe I can go for a short break. Then they're saying that medication used to relieve headaches is available as a powder and or a tablet. Use the collision theory to explain why the powder are more faster than. Basically, when you have a powder one, it increases the rate of reaction. That's why you see here the one which was a pellet, not cut, the rate of reaction was slower. Check here, it was faster than this. Why? Because this one, the other components are not easy to find. The surface area is small. So in this case, powder have a large surface area than solids ones. Therefore, more effective collision per unit time. Whenever I talk about effective collision, guys, you must always talk about per unit time. So you hear what you can say that powder has a large surface area or increased surface area or site of contact, whatever, than solid tablets, and then this increases more effective collision per unit time. Yeah, that's how the question was supposed to be answered. Yes, let's go to the next question. Guys, I'm going to come back at exactly 10. Yes, I'm going to come back at exactly 10 so that I finish up the remaining. Someone is saying that, I'm not sure. The concentration we are given was 1 for nitric acid, not hydrogen. The ratio is this to this. Okay, before I go, guys, let me check his question. The concentration given was where okay, let me check what you are saying. Oh, you're saying that how the surface area dilute nitric acid concentration. Yes, The concentration given was for nitric acid. True. Yeah, but not hydrogen. I did not use this concentration. I did not use it. What I used is, because here they say that this is a gas, and then this graph is showing you gas. Don't forget that I said number of moles equal to volume over molar volume. You understand? And then when I was here, they said that volume of the gas produced, and the only gas here is the hydrogen. I used this graph too. In this my calculation, I did not use that concentration because yes, what you say that it is nitric acid. However, I did not try to do the calculations concerning passing through there to see if I can get the answer. But if you got the same answer, then automatically they will award you your marks. Ne? Yes. I think I'm clear there. Oh, my brother, you got it right. So, guys, I'm going to break off for some 10 minutes. Then I'm going to come back after 10 minutes. Meaning that that time I will be back. I'm back so that we can start from where we stopped. We're supposed to go to chemical equilibrium. Yeah, as I said that I will be back. So now I'm back again so that we can discuss chemical equilibrium, and then acids and bases, and then we go to all right, let's go to question for chemical equilibrium, and then we'll see what do they want in this question. What do they want in this question? So we finished this question. Let's go to finished. Yes. Let's go to this question for chemical equilibrium, and then we discuss it. Just a moment. What are they saying in this question? They say that hydrogen is prepared in a reaction by the reaction of methane and steam. So it means that here you are trying to heat water so that it forms steam. So that's the meaning. So they're saying that the first question, they're saying that okay, hydrogen plus steam, because it's in a gaseous form, plus carbon monoxide gives you this. And then enthalpy change is positive, which means that the reaction is endothermic. So the methane and steam are sealed in 2 decimeter cubed container to react and allow the to reach equilibrium at temperature T. So they have not specified which temperature. They just said temperature T. Use state Residence principle. So here they are talking about what you need to talk about. You need to talk about the closed system. You need to talk about new equilibrium, and then you talk about oppose the disturbance. Yes. So don't forget that it's also all or nothing law, meaning that either you get all the marks or you lose all the marks. So when equilibrium is in a closed system is disturbed, when equilibrium in a closed system is disturbed, the system will reinstate new equilibrium by favoring the reaction that will oppose the disturbance. That's it. When the equilibrium in a closed system is disturbed, when you disturb the equilibrium, okay, what happens? They're saying that the system will reinstate the new equilibrium by favoring the reaction that oppose the disturbance. That's what you're supposed to talk about when it comes to that. So then the next question, they're saying that use the reactions principle to explain how the changes in will affect the yield of hydrogen. Number one, adding methane. So when you add methane, it means that you're increasing the concentration, the number of particles which are reacting, meaning that you're going to have the equilibrium is disturbed, and then it's going to favor the forward reaction, and more products are going to be formed. So adding methane will increase the concentration of methane. The forward reaction is going to be favored. The yield of hydrogen is going to increase. The forward reaction is going to be favored, and the yield of ammonia, hydrogen is going to be increased. So basically, that's how you're supposed to write. And then what happens when you decrease the volume of the container? So you have to look at how many number of moles this side and the other side. Let's count. You have 1 mole here, 1 plus 1, and then you have 1 plus 3. Here you have 4, here you have 2. So when you decrease the volume, it means that you're favoring the reaction which result in fewer number of moles. Remember, when you decrease volume, you are increasing the pressure. So the reverse reaction is going to be favored, and then it means that the number of hydrogen formed is going to decrease. So increasing the pressure, they will favor the reaction that produce less number of moles, and then the reverse reaction is going to be favored. The yield of hydrogen is going to decrease. So that's how you're supposed to say. Increase in pressure favors the reaction that produce less number of moles, and then the reverse reaction is going to be favored, and then the yield of hydrogen is going to what? It's going to decrease. That's what you're supposed to talk about. What about the graph? I brought the same graph, similar graph, before you wrote your paper, and then let's look at it. And then I said that this was the simplest graph they have ever brought when I was explaining that, and it definitely is the same graph which came. They're saying that the sketch graph below shows the change in the number of moles of methane, the steam and the carbon monoxide as reaction proceed for the preparation of hydrogen gas in 2 decimeter cubed of the container. All right, write down the reason why there is no number of moles of each of gas between T1 and T2. Write down why there is no change in the number of moles of gas between T1 and T2. T1 and T2. It means that now the reaction has reached what? Equilibrium. The reaction is in the chemical reaction is in the dynamic equilibrium. That's meaning that the rate of forward reaction and the reverse reaction are equal. Yeah, that's why you see there is no change in the number of moles. This information in the graph calculates the equilibrium constant Kc for this reaction, of which first identified, they give you the volume. Yes, they gave you the volume. Volume is equal to 2 decimeter cubed. So since I have that, guys, if you have a question, let me know. As I'm back. Yes, they're saying that what are you supposed to say here? You can use the rice method, as I said yesterday. I added the other one to show the concentration, and then now should I use, how many are they? Let me just use a blank page so that you get it right. Rice method. Yes. So now, which compounds do we have? Components we have. We have to first identify here something. All of them are gases. So I have methane, react with steam, that is a reactant, to produce carbon monoxide and hydrogen. Carbon monoxide and then hydrogen gas, meaning that these are products, these are reactants. But what is the ratio of this? Methane is 1113, meaning that I have 1113. So the initial amount, obviously, based on this graph, you'll see that these two, the product is starting from 0. Therefore, I'm going to put 0 and 0. And then, what about these ones? We don't know. We don't know. We know. Hey, we know. Yes. This one started from 1.4, even this one 1.2. 1.4 is methane. Yeah, this one is 1.4 and 1.2. Yes. At equilibrium, definitely, what is being produced at equilibrium? In this case, carbon dioxide is what, 0.6, 0.6. Carbon monoxide 0.6. Is it carbon monoxide? Let me check. Yes, 0.6. But now, this one, if it is 0.6, so 0.6 times 3 is 1.8. So it means that 0.6 times 3, because these are 3 moles. Yeah? And then what about this? In terms of moles, graph for this one is going to be is 0.6, 0.6. Isn't it? Yeah. 0.6, 0.6. Yeah. And then now, when you subtract to get what remains at equilibrium, is going to be 0.6 minus 1.4, which gives me 0.8. Let me just do like this. 0.8, and then here when I subtract this from here, it'll be 0.6, and then this one is the same at equilibrium and 1.8. Now I need to find out the concentration, because we saw that the volume is this. So I'm gonna say 0.8 divided by 2, so it gives me 0.4. 0.6 divided by 2 gives me 0.3. 0.6 divided by 2, 0.3. 1.8 divided by 2 gives me 0.9. You see? Yes. Then from there, I use the Kc. Kc is equal to, we saw that products, which is carbon monoxide, to hydrogen. We saw that, sorry, there are 3 of them, number of moles, and then you have methane, and then you have steam. Yeah, you have steam. Yeah, from this expression, you can find now Kc is equal to carbon monoxide 0.4 times carbon monoxide is what? Let me check. Oh, carbon monoxide is 0.3. 0.3. 0.3 times 0.9 cubed over 0.4 times 0.3. So the Kc value becomes 0.8. 0.82. 0.8. 0.82. Yes. 0.82. Yeah, basically that's how you're supposed to calculate for this case. In this case, the case C was not that difficult to identify because the graph was showing you all everything which is required. And then that's marked to be one of the simplest cases I've ever seen. Yes. Anyway, if you get it, let's hope that you're gonna get it on the final because we'll bring still the case C for you to calculate. Let's go to the next question. What's happening? Okay. Okay, let's go to the next question and then we see. The next question, they're saying that decrease in the volume. Oh, yes, we're done with this. We finished this. So meaning that that's how you're supposed to get those 7. Guys, you must not lose those 7 marks. You must not lose those 7 marks. Yes. Then we go to the next question. Temperature T is decreased. How will this change affect Kc value for the above reaction, right? Increase, decrease, or remain the same. You come back and then see. Is this reaction endothermic or exothermic? We saw that it's endothermic because the enthalpy change is positive. When you decrease the temperature, obviously, the Kc value is gonna what? It's gonna decrease. You're gonna form less product. And then if you have less product, definitely it means that you have less. The value of Kc is gonna be what? It's gonna be small. Then we go to acids and bases. Acids and bases. If you have a question, let me know. Acids and bases. Let's go. They're saying that balanced equation below represents ionization of sulfuric acid. Step 1, yes. Then step 2, sulfuric acid gives you this resonium ion and the hydrogen sulfate, and then hydrogen sulfate, where sulfuric acid should get resonium ions and then sulfate ions. And then is sulfuric acid a strong or weak acid? Sulfuric acid is a strong acid. Why? Because it ionizes completely. It ionizes completely when dissolved in water. Yes, it ionizes completely in water. Yes. Then write down the formula of the conjugate acid-base pair in step 2. Step 2, conjugate acid-base pair, meaning that this gives the hydrogen ions to form this, and then this gives this to form this. So this goes with that, and then this goes with that. Yes. So in this case, they're asking you to write the conjugate acid base pair in step 2. So you can either write this and this or that and that. Still, we will give you a mark. They are saying that sulfuric acid is diprotic. What is the meaning of diprotic? Diprotic means that acid which can donate 2 hydrogen ions when dissolved in water. Yes. Write down the formula of amphotelic in the above reaction. In this case, what acted as the acid and acted as a base? In this case, this is an acid. Yes, because this and this and this. You understand? Now, this sulfuric acid, in this case, it was a base. Acid, base. So it acted as a base here. And then here, When it came here, it donated the hydrogen to this. Therefore, it's the same thing here. In this case, act as a what? Act as an acid. So basically, in this equation, hydrogen sulfate is the one which acts as amphoteric. However, even water can act as the amphoteric, but in this case, it didn't. Yes, it didn't. It didn't act that way. Then we go to the next question, saying that impure sample of potassium hydroxide pellets with a mass of this is added to this moles of sulfuric acid with a volume of this. It reacts according to the balanced chemical equation given below. Okay. Calculate. They're asking you to calculate the pH of calculate the pH of the sulfuric acid. So what are you going to calculate here when it comes to the pH? pH, don't forget that pH is equal to negative log of hydrogenium ion. pH is equal to negative log of hydrogenium ion concentration, negative log. But how am I going to get this hydrogen ion concentration? Because here they say that this is in the number of moles of this. It reacts according to the equation, saying that the impure sample of hydroxide potassium hydroxide pellets with a mass of this. Yes. With a mass of this is added to this sulfuric acid. You see? With a volume of this. So I have the number of moles and I have the what? I have the volume. So in this regard, I can find the concentration. Yes, let's find the concentration. Don't forget the number of moles is equal to, let me just go direct. Concentration is equal to number of moles over volume. So do I have the number of moles? Yes. Do I have the volume? Yes. The volume is, number of moles is 0.09, isn't it? Concentration, volume is 600 divided by 1,000, which gives me 0.6. So 0.6. So concentration in this case is gonna be concentration of sulfuric acid. It's gonna be when you calculate is 0.15 moles per decimeter cubed. So that's the concentration of sulfuric acid. But now if you look at the mole ratio of sulfuric acid to water, because you are looking for this hydrogen ions or how many hydrogen ions are produced. So in this case, you'll find out that it's 1 to 2 sulfuric acid to H2O or hydrogenium ion. So it's 1 to 2. So if in this case I have 0.15, so these ones for them to be 2 is gonna be 0.15 times 3 times 2 and times 3. So it gives me 0.3 moles per decimeter cube. So that's the concentration in that regard. So since I've got the concentration, so I'm going to apply my formula that negative pH is going to be equal to negative log of hydrogenium ion. Yes, concentration of which negative log of 0.3, and then the answer gives you 0.52, yes, as the pH. So that's how you're supposed to calculate that. Understand? Yes, that's how you're supposed to calculate that question, unless you have a serious question, but that's how you're supposed to calculate that pH. Then they're saying that the percentage purity of potassium hydroxide pellet used is 80. Calculate the number of moles of pure potassium hydroxide that reacted with the sulfuric acid. Now you need to find out, determine, they're saying that percentage purity of potassium hydroxide pellet, yes, used is 80% of the purity. Okay, calculate the number of moles of potassium hydroxide that reacted with the sulfuric acid. So it means that here I have to first identify the number of moles. The number of moles of yes, I have to first identify the number of moles which are found in 11. How am I going to find the number of moles? This is mass. Number of moles, this is mass over molar mass. So I find the number of moles. So, but this number of moles, not all of it was used. They said only 80%. So, it means that, let me clean up here. It means that I'm going to use that small expression to get the number of moles, and then after that I get the percentage purity in that regard. Yes. Okay, let's start. Number of moles is equal to number of moles is equal to mass over molar mass. So which number of moles, in this case, we saw that the number of moles is equal to the percentage, the mass which was given. The question is 11.2 over, you have to find the molar mass. The molar mass of potassium hydroxide. Potassium hydroxide is potassium hydroxide. This one is 16. This one is 40. This one the periodic table, so it's gonna be 56. Yeah, it's 39. 39. Yeah, it's 39. Not 40. It's supposed to be 39. Okay, check on the periodic table. Potassium. So I'm looking for the molar mass. Potassium is 39 plus oxygen, which is 16, plus hydrogen, which is 1, which gives me 56. So it means that number of moles is equal to this divided by 56. Number of moles is going to be equal to 0.26 moles. But don't forget that all these are the number of moles which were found where? These are number of moles which were found in what? In 11 grams of potassium hydroxide. So it means that now what am I supposed to do is to equate it, or to make an expression of 80%, because they said 80%. So it means that 80% is equal to 80 divided by 100, now times 0.26, so that I know exactly how much was used. So the number of moles in this case, they're going to be equal to, when you multiply, is going to be equal to 0.16 moles. So this is what they wanted. So you have to first convert this number of moles, this one, the mass, into number of moles, and then after that they say that only 80%, you understand, was used, meaning that what is the 80% of 0.26? It is 0.16. So yeah. Then they are saying that determine which reactant is in excess, hence the final solution is acidic or basic. To get how much is basic or is acidic, how much is not a limiting reagent. In other words, here you have to compare the number of moles. So you have to compare the number of moles of sulfuric acid to potassium hydroxide. We saw that the potassium hydroxide is 0.16. Yes. Yes. If this is 2, then this is going to be half of it, which is 0.08. You see? Now, you have to identify which one is in excess. Which one is in excess? Let's go back here. Oh, I rubbed it off. But sulfuric acid is in excess. When you subtract this from the initial amount of sulfuric acid we calculated, the number of moles of sulfuric acid, you see that sulfuric acid has more moles, meaning that sulfuric acid, the one which has more moles, you see that it's the one which is going to be in excess, meaning that the other one will be finished immediately or very fast before the second one has finished. So in this case, in this answer, compare with the calculation we did, you find out that sulfuric acid is in excess. So let's go to question number 8. This is, this question is just the cells, electrolytic cells and electrochemical cells. Yes. Question number 8. A galvanic cell is a setup used to measure, setup using manganese, and then unknown metal X. The EMF of the measured standard conditions is this. Okay, and then electron flow from, this is very important. Electrons flow from manganese to external circuit. Okay, sharp. You say that setup, manganese unknown, sharp, is the reaction that occur in this cell spontaneous? Write down only yes or no. It's spontaneous because the voltage is positive. Yes. So yes, it is spontaneous because the EMF is greater than 0. So I said it that if the EMF is greater than 0, then it's spontaneous. Which electrode XY is a cathode? A galvanic cell. They said it's a galvanic cell. Don't forget that in a galvanic cell, you have anode, and then cathode. Anode is negative in a galvanic cell. In an electrolytic cell is positive, and then this is positive. In an electrolytic cell is a negative. But oxidation, reduction is the same in both electrolytic and galvanic. So if it is oxidation, now we are saying that they say that the electron flow from manganese to X. Electron flow from manganese to X. So they're saying that which one is an anode. Remember that you have too much electrons here, meaning that, and oxidation, meaning that manganese, and then this is X. Yes, the electrons flow from here, and then they go there. You see? Yes. So meaning that manganese is the one which is the correct answer. Use calculation to identify X. So in this case, you have to use E cell, yes, is E naught cell is equal to E naught cathode minus E naught anode. You understand? So E cell, we know that it's 1 point, we know it 1.05. E, now we know that the cathode, we don't know it. We don't know, then we just put X and then minus the anode, which is manganese. You go to the reactivity series, you'll find manganese there as 0.13. So now in this case, you find the X. So X is equal to negative 0.13. Yes. Did I say that? Negative 1, negative 1. System is jamming. System is jamming. Okay, it's negative 1, let me just minus negative 1, 1, 8. Let me show you what I'm meaning. Then when you subtract, this and this becomes positive. When you put it this side, it becomes negative 3 volts. And then when you go to the, you find it as lead. So this is what I'm saying. Yes, you see, it's here, the value you have got. So it means that it's lead. Okay? Yes. And then when you found it, because there is oxidation in there, so that's what I was trying to say, that figure and that figure. So we ended up having yes, identify it as this. You see that we found out that 0.13 volts is the lead. So we have identified that metal X. The thing for this, write down the standard conditions. Standard condition, guys, are always the same. Temperature, which is 25 degrees C or 298 Kelvin, 1 atmosphere, and then 1 mole per decimeter cubed. Always, guys, always. Those are the standard conditions. State cell notation, in this case, cell notation. So in this case, we're going to see that basically we have manganese, because we said manganese is under oxidation. Therefore, manganese, which is a solid, gives manganese, is oxidized to ions. Yes, this is aqueous. Then salt bridge, lead 2 is reduced to ions, gives you lead ion, which is a solid, like that. So that is the cell notation that we are looking at. And then half equation, half reduction, half equation, meaning that what is being reduced. Remember that X is lead, which is being reduced. Therefore, it's going to be the same thing here. What you see here is Pb2 gives you Pbs. So now, because this is reduced, it means that it gains 2 electrons. So this is a solid, and then this is aqueous. Basically, that's how you're supposed to write that answer. Then the last question, the last question, they're saying that a diagram below represents the purification of copper ore to produce copper, and the cell also contains zinc, silver, and platinum impurities. The graph shows the initial relationship between mass of copper and deposited versus the time. Okay. Yeah. Question number 1. Write down the energy conversion in this. This is an electrolytic cell. Therefore, is electrical into chemical. Which electrode AB would copper be placed? With pure copper placed? AB, yes. They're asking you. We come back here and then we see. Check here. This one is the anode, because this is the electrolytic, which is positive, and this is the cathode. And then you see that this is reduction, or this is oxidation, and then this is reduction. So you go back and then find out what are they saying. They're saying at which electrode, A or B, would pure copper be deposited, meaning that it's going to be reduced. If you put pure copper here, pure copper, it's going to be oxidized. Copper 2 ions plus 2 electrons. These electrons, they're going to move this side. When they come this side, they're going to react with the copper. Understand? This one, they're going to react with the copper, and then you form copper 2 ions plus 2 electrons gives you copper solid, and then the mass is going to increase. So meaning that the answer is B, because they are saying pure copper, where is it going to be deposited? So it's going to be deposited on B. And then they are saying that write down the half equation that takes place at the anode. Half equation that takes place at the anode. Hello, sir. It comes to electrolysis. I have hard time answering questions about relative strength of either oxidizing agent or reducing agent. Can you please emphasize when reach that question? Yeah, I've already finished it. I think you need to watch one of my videos where I was trying to explain it very well. But I'll try, after finishing the last question, I'll try to maybe to emphasize it. Ne? Yeah. Tapero, ne? Yes, I'll try to just to give you a small technique how you can spot it out. Okay, they're saying that write down the half equation. Write down the half equation that takes place at the anode. So that oxidation, definitely I'm going to have copper solid plus 2 electrons. They are being oxidized to form, no, copper 2. Yes, it's copper, but just I'm putting electrons in the wrong way. Copper, it gives you copper 2 ions because it's oxidized from 0 to positive 2 plus 2 electrons. Why do you add 2 electrons here? So they cancel that if it goes back to normal. Yes, this is a solid, and then this is aqueous. So that's what you're supposed to write in there. And then I'm saying that will the gradient of the graph be affected as the reaction allowed to produce to proceed until completion? No, it will not. It will remain the same. Why? Because the copper will keep on being deposited. Yes. Refer to the relative strength of reducing agent. explain why zinc will, refer, I think this is the question you're asking. Refer to the relative strength of reducing agent. Why zinc will not be deposited at the cathode? Why zinc is not going to be deposited at the cathode? Let's go to the reactivity series and see which one is on top. Hey guys, let me tell you this. Né? Don't use the two this reactivity series, né? Because there is that and there is that. Choose one which you master. Né? Okay. I always tell my students to use this one because this is the normal one, the other one is the reverse. The one where you see lithium on top, use that one. Whenever you see lithium on top, use that one. Because the one which is on top, now the one which is on top is going to be more reactive than the one which is on bottom. But if you use this one, the one which is on bottom is going to be more reactive than one because the lithium is now down. So use that one which has lithium on top. Meaning that if the compound is more reactive, it cannot be replaced. It's the one which is going to replace. So now you are comparing zinc and then you are comparing copper. So you're going to have to look for zinc and you'll find out that zinc is on top and copper is on bottom. So zinc has to reduce copper. Copper can't reduce zinc. You see? Yes. So meaning that zinc is going to be oxidized and then copper is going to be reduced. Because to be deposited, it is supposed to be reduced. So copper cannot be oxidized and then the zinc is reduced. Never. Why? Because zinc is more reactive. Therefore, what it does is zinc is going to be oxidized to give zinc 2 ions plus 2 electrons. Because this one, these electrons are going to be obtained by copper. Yes, you see, by copper, copper 2 plus these 2 electrons, and then you form copper solid. You understand? So why? Because zinc is more reactive. You cannot go to someone who is rich and then when you are poor and then you give a rich. No, it's the rich who is supposed to give a poor one. You understand? Yes. So zinc is more rich, is more reactive. So it gives out electrons to copper, which is in need. It is in need. So when you look at zinc here, you find out that zinc is here. What about copper? You find copper down. Check. Copper 1 to copper 2 to copper 1 or copper 2 to copper. Check where it is. So it means that the one which is on top is more reactive than the one which is on bottom. So the one which is on top is oxidized. Therefore, is oxidized. Because it is oxidized, it causes the other one to become reduced because it gives these electrons to this other one. So this one is oxidized, this one is reduced. So because it causes this one to be reduced, therefore it becomes a reducing agent. So a reducing agent is oxidized. And then because this one has reduced, it has caused this one to oxidize by accepting the electrons from it. Therefore this one becomes an oxidizing agent because it is an agent of oxidation. It causes this to be oxidized by accepting the electrons which is coming from this. Therefore, this one is oxidized, this one is reduced. You understand? So oxidizing agent is this one is oxidized. You see, the one which is oxidized, it causes this one to be reduced. So in other words, this is a reducing agent because it causes this one to reduce. So a reducing agent is oxidized. You see, and then an oxidizing agent is what? Is reduced because it accepts is reduced and then it causes this one to be oxidized. I think I'm clear there. So when we go back here, we shall see that the question is asking you that. Which question was it? 9.5. Yes. So in this case, you see that zinc is a strong reducing agent than copper, meaning that the zinc will be oxidized, you understand, and then gives these electrons to copper so that it reduces what? Copper. That's why you're saying that zinc is a strong reducing agent for it is oxidized, you understand? Therefore, copper ion will be reduced to copper. That's what I was trying to explain here that zinc is a strong, zinc is a strong reducing agent. Its ions here, its electron will reduce the copper ion to copper. That's why zinc cannot be deposited in there. Yes. So you guys just take one table, the one which has lithium on top, so that at least you don't get messed up. Then they're saying that when current flows for 30 minutes, 15 grams of pure copper was deposited. Calculate the number of moles of copper. Copper, this one is simple. Number of moles is equal to mass over molar mass, of which 15 divide molar mass of copper. What is the molar mass of copper? Molar mass of copper based on the periodic table is 3. It's supposed to be 64, but based on this is 63.4 or 0.5. I think it's 0.5. Copper is supposed to be here. It's 0.5. Yes, yes, it's 0.5. 63.5. 3.5, and then the number of moles is going to be giving you 0.24 moles. Yeah, simple. And then you get your 3 marks. Determine the number of moles of electrons. But don't forget that when copper is oxidized, copper to ions plus 2 electrons. If you look at it, it's 1 mole, and then here is 2 moles, meaning that 1 mole of copper is going to give me 2 moles of electrons. Therefore, in this case, I'm going to say that number of moles of electrons in this case is going to be equal to 2 times 0.24. Why? Because 1 mole of copper gives 2 moles of what? Of electrons. Yes. And then yeah, basically that is it. And then you get the answer as 0.472. Boom. You get all the marks. Who got all the marks? Yes. So guys, that's how the paper was supposed to be. And I wish you guys have been on Thundereduc trying to do different questions with me. I know that you'll get distinctions. If you didn't get a distinction now, don't panic or what. Yes, distinctions are coming. Don't worry, you'll get the distinctions. Make sure that you keep practicing questions. When you practice questions, you'll get what you invest in. You understand? Yes. So unless you have any question, let me check, see if there's any question. If there is no any question, I wish you the best for your final exam. I appreciate that. Thank you very much. I hope, Tapero, you have got that explanation which I try to give up, or to give you the one I said that I'll try to explain it. Thank you very much. It has been M. Saidi as usual. See you in the next class as you're doing final revisions.
Welcome back to our class. Don't forget to subscribe if it is your first time to visit our channel.
Simple. Electrolyte. Let's look at now electrolyte in simple term, and then we understand it better. So once you understand it better, then you'll be able now to combine all of them, and then you go for any question concerning about this. The salt of the compounds need to be soluble. It means that they need to be able to dissolve in the solvent. For example, water. Yes, it must be able to dissolve. The suitable soluble salts of zinc and the copper are, for zinc, it's better to use zinc nitrate. When you're talking about the chemistry of nitrates, all nitrates are soluble. They are able to dissolve. And the copper nitrate, So these are the solutions. So on the side of the half cell of the zinc, you put zinc nitrate solution. And on the side of half cell of copper, you put copper nitrate solution. That's what it means. So in here, zinc nitrate solution, and then in here, you put copper nitrate solution. Now someone will ask you, but you talked about copper sulfate. Yes, but they are saying the suitable. You can use any other, but the suitable, the one which is much more better is that zinc is oxidized to zinc ion. You know that? And the concentration of zinc ion increases. Now look at this. How is the salt bridge very important? Let me just open your mind so that you know where we are going. Zinc is oxidized to zinc 2 ions. The concentration of zinc 2 ion increases, yes, building up a positive charge. So the concentration of zinc ions here, yes, yes, they increase because it dissolves here. The electrons will move away from the negative potential. Remember, this is a negative potential, and then it goes to where copper is here. They go. When they go, they come this side to copper. What happens? The electron will move away from the negative potential, yes, the terminal, making it impaired. It means that now we have too much positive here. Remember, this is supposed to be a negative terminal. And then now you have too much positive. What will happen? Then it's going to be impaired. We need something which is going to neutralize this. This is a negative terminal, but now the positive charges are building there. So what is supposed to happen? Yes, we need to keep it negative, because if you don't keep it negative, it's going to turn into a positive, and then the reaction is not going to take place. All right. So copper 2 ion. So what is happening to this? We're going to look at the solution for this. But copper 2 ion are reduced. When they are reduced, they form copper solid. Wonderful. Then you are saying that the concentration of copper 2 ion decreases. It means that now when it comes like this, these electrons, they react with copper 2 ion. Remember, I told you that now it starts to fade. Yes, because we have used all the copper 2 ions. So the concentration of copper 2 ion decreases. This leads to copper 2 becoming less positive. It becomes less positive because now the positive charges have been used up. It has formed a solid. And remember, this is a positive terminal. So if the problem comes in now, what is happening really? So we have to make sure that this one remains positive. The electrons are therefore not attracted. It means that now these electrons from this side of zinc will not come to the copper. Why? They are no longer attracted. Why? Because now the copper 2 ions have been used up. It's no longer that strong positive side. Then what happens? Attracted to the cathode as strongly, making it impaired. It means that it can't work anymore. So what happens? We have to look for a solution for impairment of the cell. So what should we do? Number one, we are saying that the migration of nitrate anions is a negatively charged particle. Yes? Negatively charged particles are called anions, and positively charged particles are called cations. So we are saying that the migration of nitrate anions in this salt bridge to the anode. Remember, we say that here, this one becomes it forms this, yes? And then it becomes more positive. It reduces the negative part of it. So what we need to neutralize this. So because it is positive, it is zinc 2 ions, yes? What is happening? The zinc 2 ions have accumulated, so we need a negative anion. Where is it going to come from? It's going to come from the salt bridge. Potassium ion, remember, it is made up of the salt bridge is made up of potassium nitrate, yes? In the salt bridge to the cathode. So it means that this one will go to the anode, while this one will go to the cathode. Yes, it is potassium nitrate in the salt bridge. So what happens? It means that the positive will go to the copper, and then the negative will go to the zinc. Let's go back here and we see. We say that this one accumulates. When it accumulates, it forms more positive. So we need to reduce it so that it goes back to a negative terminal. So we send it potassium, we have potassium nitrate. We send here the nitrate. So it neutralizes this. So it means that now this terminal remains negative. Now here, when this one comes in, when it comes in, it uses these copper 2 ions. When it uses the copper 2 ions, oh, what is now happening? It's gonna make it lose its positive ability. Yes. So what do we need? We need a positive charge to come here. Remember, it is potassium nitrate. The nitrate has come here and the potassium is positive. So the potassium will come this side and then makes this one to be positive. So it means that now the terminal will be able to attract more electrons, That's it. That's how you can explain. You're saying that this cancels this build up of undesirable charge, maintaining the cell's electric neurality. It means that it will be neutral. There will be no more this fluctuation in the polarity, and the negative will remain negative. That is the function of the salt bridge. That's why we say that it brings about what you call neutrality. All right. So we are saying that the cell, therefore, continues to form or to function properly. It is going to continue functioning properly without any problem. Electron current. Let's look at it now. Electrons are always moving from anode, from the negative terminal to a positive terminal, from zinc terminal to copper terminal through an external circuit to the cathode. So it moves from the anode, zinc, to the cathode, which is copper. Then you're saying that in copper zinc cell, electrons therefore flow from zinc to copper. I've tried to explain that. It means that it moves from a more reactive element, which is able to be oxidized, to a less reactive element, which is able to be reduced. Cell notation. How do we write now the notation? How do you write the notation? Always start with the anode, which is the negative on the left, and end with the cathode on the right. Cathode is the positive. Are we there? Anode, negative, cathode, positive. All right. Use this separator. Use a dash. Use a dash. Use this to separate anode or cathode. I'm gonna show you from its electrolytes. Represent the salt bridge. The salt bridge. When you use this two double slash, forward slash, because you have a back slash and a forward slash. Two forward slashes, yes, it means that you are representing a salt bridge. When you use one slash, it means that you are separating anode or you are separating the cathode. Components of the cathode and components of the anode. For example, zinc, which is a solid, slash, it means that it gives out zinc 2 ions. It means that it is oxidized, which is aqueous. Then I have a salt bridge, yes. Then the copper receives the electrons from zinc, remember? And then you have copper 2 ions. When it receives the electrons, then it is reduced to copper. Then I have to separate it, that this copper give me copper solid. That's how you're supposed to explain it. Let me repeat. Zinc gives me zinc 2 ions. And then the copper 2 ions gives me copper solid. That's the meaning. What happens in the half cell of the zinc? What happens in the half cell of the copper? Electrode, this is the electrode, yes. Slash, the electrode, the solid, dissolves into what? Into electrolyte. Electrolyte, it means a solution. Electrode means a solid. Dissolve into the solution by giving the ions. Yes. Salt bridge. Now, what is in the solution? The copper 2, yes, which is the electrolyte solution. It gives me, or it gives the electrode, which is a solid. You understand? That's how it's supposed to be interpreted. Or you can say, this is what needed, but these ones are trying to explain. Anode, which is a negative, salt bridge, cathode, which is a positive. That's it means. All right. here is what we are talking about diagrammatically. Zinc gives me zinc 2 ions. Yes, zinc gives me zinc 2 ions here. Yes, then I have copper 2 ions gives me copper, is this, and then you have in between here I have a salt bridge which connects them. That's the meaning. Unless you have a question, next time we're gonna start with the standard electrode potential. Standard electrode potential. Make sure that you come to class on time.
On a weekly basis, which are going to help you to get a distinction. This is the only channel which you can use and get a distinction, because whatever we talk about is related to examination, and they expect them in your exam. Let's start with the objectives, and then we see how we can smash them. So that we can get at least distinctions. They're saying consider the structure formula below. If you look at this structure formula, yes, if you try to expand it, you'll find out that it is CH3, C double bond there, and then CH3. So they're saying structure formula. Identify the name of the functional group in this formula. So if it is a carboxylic acid, it's supposed to have at least that. Yes. If a carboxylic acid or ester, so we don't have that. If it is still a carboxyl group, it's supposed to have the same functional group and the homologous series. So this is almost the same thing. So ketone and aldehyde or carbonyl groups, they are the same, but don't forget that in here we have the aldehyde and the ketones. So ketone, well, we expect the carbon atom to be in the middle of two alkyl groups. So it means that there must be another carbon atom this side, another carbon atom this side. Therefore, this becomes a ketone. It becomes a ketone. But because they are saying the functional group, yes, because ketone is a homologous series, because they are saying it is a functional group, then automatically the carbonyl groups, the carbonyl group, yes, it has both the ketone, and it has the aldehyde. So it means that the answer for this is going to be D. So you'll find out that many students will be putting C, of which C is not a functional group. C is the homologous series in that regard. Then they're saying that which one of the following is an empirical formula of 1,2-dichloro. So I expect 2 chlorides somewhere, and then dichloroethane. And then if this is ethane, so I expect it to have at least and then a chloride that side and a chloride that side. So if they're saying one chloride, the second chloride, one carbon atom number 1, carbon atom number 2. So if we count this, we will find out that you have, yes, 2 plus a chloride, 2, you see, 2 of them, 1, 2, yes. So I have C2, 1, 2, 4. So H4, yes, H4, and then 2 chlorides, which is going to give me that. If we have that answer, it becomes the correct answer, which is D. But because they're saying empirical formula. Yes. When they say empirical formula, it means that you are talking about the simplest way how you can express this. The simplest way how you can express this. So now, because we can express this, this becomes now the molecular, the molecular formula. Yes. So now it means that if this is 2, 4, 2. 2 can go into 4. So therefore, if I divide by 2, divided by 2, divided by 2, I'm going to have CH2Cl. So if I have this in the equation, then it becomes the most correct answer. Therefore, B is also another correct answer. But because they want the empirical formula, the simplest way how you can express it, therefore this one becomes wrong, and then I get this to be the correct answer. So it's also a confusing thing if you don't take care of it. Then they're saying that consider the structure formula of the organic compound below. This is an organic compound below. So once you are given this, first identify its homologous series. You find out that it is an alkene. It has 2 bonds between the 2 carbon atoms. So now, since I know that it is an alkene, it's going to end with that. Now I have to find out the longest chain. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So any of them is 5, and 5 is pent. But this pent, I need to know the position of the double bond is 1, 2. 1, 2, 3. So I'm going to take the 2 because 2 is a little bit shorter. 2. So now, if I say this is the, if now I say that this is the longest chain, yes, so it means that now this, and this, they become the side group. Because I use this direction when I'm counting 1, 2, therefore I'm gonna have the first one is gonna be 1, 2. The first branch is on 2, 3, 4. The second branch is on 4, and then another branch is on 4. But because all of them are the same type, then automatically is gonna have a tri. Tri, it has 1 carbon atom, which means meth, which is because they are side groups. Remember, whenever you talk about the side group, the 2 letters Y, L. So it becomes 2, 4, 4 trimethyl. And then the longest chain is pent, and the position of the double bond is on carbon atom number 2. So that is going to become pent 2 in. Don't forget that a figure and a figure, we separate them by a comma, and a figure and a letter, we separate them by a dash. That's why here it also figure a letter and a figure dash, a figure and a letter dash. So it means that that is going to be the answer. So now we come here and then we find out where is the answer. 2, 4, yes, trimethyl pent 2 in. So this one becomes the answer. So now when you go to another question, they are saying on question 4, they are saying that the following option, choose one that best explains. You see, it can explain, but they want the one which is best explains. Catalysts that are extremely extensively used in chemical reactions. Catalyst can be used to derive equilibrium in desirable direction. Catalyst can decrease the reverse reaction. Catalyst can decrease
the reverse reaction. Really? Then they are saying that catalysts have no effect on the reverse reaction. Catalysts cause forward and reverse reaction to proceed at a faster rate. So they're asking you a question that from the option, choose one that best explains why catalysts are extensively, like it is widely used in the chemical reaction. So if you look at this answer, you'll find out that catalyst used to derive equilibrium. Catalyst can be used to derive equilibrium in the desirable direction. Not really. Catalyst decrease the reverse reaction. Not only, catalyst has no effect on the reverse reaction. That's wrong. Catalyst cause the forward reaction, the forward and the reverse reaction to proceed at faster rate. Yeah, so it depends on which catalyst you have applied. There are some catalysts which favor the reverse reaction at a faster rate or the forward reaction at a faster rate, depending on the producer, what he or she wants. There is one answer which is the most correct answer. So if it is the most correct answer, then you take that. So don't rush to circle or to give the point out. They study the graph, and then when you study the graph, and then match, meaning that what is this x? What is that x going to be? Choose the options. Yeah, we know that these are reactants, and then these are products, and then this is the activation energy for the forward reaction, and then this is the activation energy for the reverse reaction, and then this is the energy, the change in energy or the enthalpy change. And then now, what about this? Because it is an activation energy, which is on top here. If I draw a line touching the y-axis, then what is this? This is a species. It is a complex. That's why you call it a complex, a species, which is in transition. So it's not yet products, and it's not yet reactants. Therefore, we call it an activated, not activation, because the activation is a condition. So we call it an activated complex, the complex which is activated, ready to convert into a product. So if you look at this, B will going to be the most correct answer. Then question 6, they're saying the equation below represents the chemical reaction at equilibrium in the closed container. Yes. If it is in the closed container, they're saying which one of the following changes will increase the yield of hydrogen iodide? Hydrogen iodide. But hydrogen iodide in the above reaction. So first ask yourself, because they're talking about the pressure, temperature. Whenever they talk about temperature, look at the enthalpy. Whenever they talk about pressure, look at the number of moles. So number of moles, so you have 1 here plus also 1 here is giving you 2. So 2 equals to 2. So it means that pressure will not affect, because you have 2 moles before and you have 2 moles after. So when the equilibrium is established, it means that when you increase the pressure, the reaction is going to remain the same, because it will favor the reaction, which is going to, for example, if you increase the temperature, which is going to be in fewer, which is going to have the fewer number of moles. But because the left and the right side, both of them, they have the same number of moles. Therefore, automatically, it means that pressure will not affect that reaction. So where there is pressure, we mean that those two are out. So our answer must be either A or B. So now when you go to temperature, what are you looking for? You look for enthalpy. So you look at this. This is the enthalpy change is less than 0. So it means that the enthalpy change is negative if it is less than 0. So it means that the enthalpy change is negative. And if the enthalpy change is negative, then automatically it means that is it endothermic or exothermic? So if it is exothermic, it means that the heat after the heat of the product is lower than the heat of the reactant. So that's why when you subtract, you get a negative answer. And then if it is endothermic, it has taken in heat, the heat of the product is more than the heat of the reactant, and then the heat is going to be higher. Yes, so that's why when you subtract final minus initial, you're going to have a positive answer. So in this case, because it is negative, therefore the reaction is the reaction is exothermic. So if the reaction is exothermic, then automatically it means that if you increase the temperature, the reaction is gonna decrease. If you increase the temperature, the reaction is gonna, if you decrease the temperature, the reaction is gonna increase, because it works better when the temperatures are low. So if you come here, say that which one of the following will increase the yield of hydrogen iodide. So if you look at here, increase the temperature, no, because this is not an endothermic reaction. So the only answer which is remaining is B, decrease in temperature. So the answer for that case is going to be D. Sorry, it's going to be B. 1.7, they're saying that which one of the following solution of concentration 0,1 has the highest pH. Now, when you look at the highest pH, look at the more high it is, the more alkaline it's gonna be, and the more lower it is, the more acidic it's gonna be. So it means that all compounds which are more of acidic, strong acids, are wiped out if the weak acids are there. So if you look at nitric acid, ammonium chloride, sodium carbonate, and then ethanoic acid, these are acids, but they are weak acids. This is a salt. This is a what? Is a salt. Both of them are salts, but this is going to be a weak salt. A weak salt. Why? Because it is coming from a weak base, which is ammonia. Yes, it is coming from a weak base, which is ammonia. And then this one is going to have, it means that it's going to have the highest alkalinity. Therefore, it means that our answer is going to be C, because the alkalinity is much more than the alkalinity of ammonium chloride, because it is coming from a weak cation. It's coming from a weak cation, while this one is coming from a strong cation, which is a group 1 element, which is sodium. Therefore, the answer is going to be C. Then they're saying that 1.8, they're saying that a solution of ethanoic acid, sometimes call it acetic acid, which is sometimes call it vinegar, is titrated against sodium chloride. Now this is a weak acid. and then this is titrated with the sodium hydroxide. This is a strong base. Yes, it's a weak acid and then a strong base. So what does it mean? So if weak acid, strong base, it is a weak acid, strong base, the resultant solution is going to be more of basic than acidic. Therefore, they're asking you that which one of the following indicator would be the best suitable for this titration. So because it's going to be more of basic than acidic, because of the strong base reacting with a weak acid, therefore the indicator which is going to be better is going to be phenolphthalein. So the answer is going to be A. Then 1.9, they are saying that which of the catalysts given which of the following catalyst, which of the following correctly gives the direction as well as the medium in which electrons move in the galvanic cell. First of all, what you need to know is electrons don't move through the salt bridge. Electrons move through the external wire. So it means that whatever we have, or whenever we have the salt bridge, so it becomes wrong. So this one goes out, and then also this goes out. So use this technique of elimination so that it makes you to have at least fewer options to pick from. The chances of you getting it right is increased if you wipe out those which are wrong. Okay. Then you have what you call the anode to the cathode and the cathode to the anode. So in this case, you need to know that remember in the saying equation of the electron direct gives direction medium. They are saying which cell is this? They are saying the galvanic cell, of which the galvanic cell anode is the negative and then the cathode is the positive. Anode is the negative and then cathode is the positive. So it means that electrons will move from the anode and then they go to the cathode, which is positive, so that there is that attraction. And then when they reach the cathode, that's why we say that cathode is where reduction is, and then anode is where oxidation is. So if this is negative, it means that it releases the electrons, and then the electrons move to this side. And then when they reach there, find a species, for example, copper-2, and then this copper-2 is going to gain the 2 electrons, yes, and then it is going to be reduced to copper. That's why he said that reduction is taking place there. So they come from the anode, and then they move to the cathode, see, and then now reduction will take place from there. That's why we shall say that from anode to cathode, but via external wire. Hence, B becomes the most correct answer in this regard. Then lastly is which one of the following have reaction at the cathode during electrolysis of sodium, electrolysis of solution of concentrated sodium chloride. So during the electrolysis of concentrated sodium chloride, you have different ions there, but the ions which are there are some which are preferred than the others. Yes. Yes, you have the positive, which is sodium, and then you have the negative, which is chloride. Then you have the OH, then you have the hydrogen. So basically, what is being produced at so this one is gonna be preferred than this. So it means that this is going to be the most correct answer, which is D. Then this marks us the beginning of the second question, which is organic chemistry. So before you start, you need to know which groups, which homologous series, which functional group are these compounds. So if you look at this, we shall find out that this is an alcohol. Because of that, this is an ester. Because of that, this is a carboxylic acid. Because of that, and then this is, because this one is here, yes, this is an alcohol because of that, and then this is alkene because of that, and then this is also another alcohol because of that, and then this is a haloalkane. Yes, because of that, or mainly because of that. So, question from the table above, consider compound B. Write down number 1, the homologous series to which compound B belong. The homologous series B, with B, we have seen it that this is an ester. So B is going to be an ester. Yes, it is an ester. And then IUPAC name of B, they're saying IUPAC name of B. See IUPAC name of B. Where is it? Okay, now we need to find out which one is, first of all, we know that this is an ester. And ester, how do they end? They end with the word "owed." Yes, but you need to know which one came from the alcohol, which one came from the carboxylic acid. So the one which has the carbon double bond is the one which came from the carboxylic acid. So we can take this as the main chain. So it's gonna be 1, 2, 3, because there are 3. So it's gonna become prop. But because prop is 3, we have to go up to propan. So it becomes propanoate. Now, what about this? This would have called that a side group. Therefore, it's gonna become, let's say that that is going to become, we say that it is 1, which means meth, because it's regarded as a side group. So we're gonna say methyl. Then we say that this is propanoate. Therefore, it becomes methylpropanoate. And then they are saying that alcohol and acid are heated in the presence of concentrated sulfuric acid. It means that they are looking at the alcohol and the acid, organic acid, in presence of a mineral acid, which is the concentrated sulfuric acid, to form compound B. So now we said, what is compound B? Yes, we have seen compound B is methylpropanoate. the role of concentrated sulfuric acid. Write down the role of concentrated sulfuric acid in this equation. So this is the sulfuric acid. We use it as a catalyst. Please don't say it is a dehydrating agent. Please don't say that, because we won't give you a mark. It is acting as a catalyst, or it speeds up the reaction. Those are the only two things we can give you marks. Name the alcohol and the organic acid used to prepare. Names of the alcohol and organic acid used to prepare compound B. So if you look at this, we say that this one comes from the alcohol. So it means that the alcohol is going to be meth. Alcohol is going to be meth, which is 1. Meth. So because alcohol we go up to there, meth, and then you put OL, which is methanol. Why are we not putting on the position? Because it's only 1 carbon atom. Alcohol of 1 carbon atom and 2 carbon atoms, we don't put position. Only we start putting positions when it is the 3 carbon atoms. Then we say that this one is propanoate. Therefore, it means that the carboxylic acid, it must start with that name, which is the So the other one is methanol, and then propanoic acid, and then sulfuric acid as a catalyst. Then they're saying, name the type of reaction which is taking place. Which kind of reaction which is taking place there? The reaction is esterification. Sometimes we can call it condensation. Is condensation. Yes, why condensation? Because it results in the loss of water molecules or small molecules, which is an example of water. So at the end of the reaction, you see that when this one is formed, you also produce a small molecule called water. Then they are saying that from the table above, consider compound C. Consider compound C. Write down the name of the functional group of C. So let's go back and find out which one is C. C is a carboxylic acid as the homologous series, as this is a ester as the homologous series. So these are functional isomers. Therefore, these are what we call carboxyl groups. Yes, so it's a carboxyl group. And then they're saying to which homologous series does compound C belong? We have seen it that is a carboxylic acid. Homologous series, it is a carboxylic acid. It is a carboxylic acid. Functional group is a carboxyl group, but the homologous series is a what? Is a carboxylic acid. Then they are saying that differentiate between the functional isomer and a homologous series. When you talk about a functional isomer, functional group, not functional isomer, and then a homologous series. Functional group is it must be group of atoms. Yes, this group of atoms, it can be one atom, it can be group of atoms. For example, if you talk about OH, or you talk about for ester, carboxylic acid, you see, these are group of atoms. What about that bromine, chloride? Just one atom. That's why he said that a functional group is a bond or atom or a group of atom. When we talk about bonds, we can talk about double bond, triple bond. Yes, it can be a bond or an atom, a group of atom that determines the physical and the chemical properties of an organic compound. Yes. And then a homologous series, it can be described as the compounds with the same general formula. Compounds with the same general formula, but these the members, or in which one member will differ from the next by CH2. Yeah, they have the same general formula, but the members will only differ by CH2. Yes. And then they are saying that write down the homologous series to which they're saying that A, B, A, D, F. Write down the homologous series to which they belong. Homologous series for A, D, F. A, D. A is alcohol. D is alcohol. F. So it means that the homologous series, it is alcohol. And what is the functional group? So the homologous series is it is alcohol. So the answer here is going to be alcohol. And then write down the homologous series. Yes. So we have seen that they belong to alcohol. Compound A and D are isomers. As what type of isomer, yes, will they be classified? Compound A and D. Saying compound A and D. The isomer 1, 2, 3. 1, 2, 3. You see that the alcohol is here. So it means that, let me show you here. One compound, it's like this. CH. Okay. Let me just make them structure formula. See? So it's like that. Don't forget that each is, there is a hydrogen there. Hydrogen, 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 hydrogen. Yes. While the other one is because these are the same alcohol, same number of carbon atom, same functional group, but what is changing is the position of this functional group. Therefore, it becomes position isomer. So this answer is going to be positional isomer. Write down the structural formula of compound D. Compound D. Yeah, compound D, that's exactly what I've drawn here. But even this oxygen must show a bond. Then they are saying that that's the drawing. Then the IPAC name of G. G, where is G? G, so it's 1, 2, 3, 4, 5, 6. So it means that it's gonna be 6 is hexane. Hexane, yes, hexane, but I have that, and that. So because this is the functional group, yes, so I'm gonna count from this side.
Welcome back to our class. Don't forget to subscribe if it is your first time to visit our channel.
Volatile cells. Last time we talked about electrolytic cells. We say that electrolytic cells, for them, they require external battery. So if it requires external battery, it means that they are not spontaneous. They cannot continue on their own. So they have to be with an external battery which can supply energy to them. And we say that an electrolytic cell, it changes electrical energy into chemical energy. And then the voltaic cell or the galvanic cell, yes, this one, it's the reverse to electrolytic cell. A galvanic cell, it changes the chemical energy into electrical energy. It means that it produces electricity. All right, let's start. So we are saying that a galvanic cell or a voltaic cell is a cell in which chemical energy is converted into electrical energy. It means that use chemicals to produce electricity spontaneously. It means that without any external source. It means that these chemicals are converted into electricity. A cathode is positive. Remember, in electrolytic cell, cathode is negative. And then anode is negative. Remember, in electrolytic, anode is positive. So remember that electrolytic cell, it is the reverse of the galvanic cell. Reduction takes place at the cathode. This one remains the same as even in electrolytic cell. And then oxidation occurs in anode. Still is the same thing with the electrolytic cell. Strong oxidizing agent is put on the cathode. When you say oxidizing agent, guys, don't remember, when you say oxidizing agent, how about it? What is happened to it? It means that if it is an oxidizing agent, for it, it is reduced. So it means that it's less reactive. It can accept the electrons. Yes. It can accept the electrons. If you are broke, it means that you can accept everything. Yes, so you oxidize others. You make others to be broke. All right. So we are saying strong oxidizing agent. It means that they can accept the what? The electrons. For them, they are reduced. So they are you put them on the cathode, the positive. Because cathode is positive, so they are able to receive electrons from what? From a strong reducing agent, which is put on the anode. Anode is negative. Then it means that the strong reducing agent, for it, if it is a strong reducing agent, then it means that it is oxidized. It is able to release the electrons. It increases in the oxidation state. When you lose electrons, you become more positive. You become more positive. Yes. When you give credits to others, you become more rich because you know that anytime that money is going to come back to you. All right. So we are saying that we put it on the anode. So you have to understand this, because if you don't understand this criteria, then you won't be able to understand the concept of voltaic cells. So I will say that this is a red cat. This is a red cat. This is a red cat. So don't forget that. I'll tell you what it means. All right. So we are saying red cat. What does it mean? Reduction at the cathode. Reduction at the cathode. Consider, now we are going to have an example. We are going to have different examples. Consider copper zinc cell. If you look at them, you'll find out that one is more reactive, one is less reactive. If you look at the reactivity series, this one is less reactive, this one is more reactive. A strip of zinc metal is placed in the zinc ion solution. A strip of copper is placed in a separate beaker in aqueous copper 2 solution. So you have copper, you have zinc metal in zinc solution, and then you have copper metal in copper 2 solution. All right, here is an example. You have zinc, so there is a reaction which takes place here, and there is a reaction which takes place here. Yes, we say that zinc is more reactive. it is oxidized. It can release the electron easily. Therefore, it causes this one to be reduced. So this one becomes a strong reducing agent. Yes, strong reducing agent is supposed to be at the anode. Then copper is less reactive. We're going to look at the reactivity ceiling. And then copper is less reactive. Yes, if it is less reactive compared to zinc, then it means that it's ready to receive from zinc. So copper is ready to receive. To receive what? Electrons. You see them? See them, yes. You see them. Yeah, electrons. So it means that zinc is going to cause this to be reduced. Therefore, zinc becomes a strong reducing agent. It's supposed to be at the anode. And then copper is going to receive the electrons from zinc, therefore it's going to be reduced. Therefore, we will say that copper has caused the zinc to be oxidized. Therefore, we shall say that copper is a strong oxidizing agent. Why? Because it has made zinc to be oxidized. That's the meaning. So this is the half cell for zinc and half cell for copper. These two bakers are connected by a salt bridge. Salt bridge is very important in giving these two cells ions. We're going to look at them and you will understand them better. All right. Should we continue? Yes. So we are saying that they have reaction that occur in each half cell. This is what happens. We say that zinc is more reactive. Yes, it is a strong reducing agent. So it means that for it is oxidized. You start from zinc, the charge is 0, and then here the charge is 2, positive 2. Yes, so it means that this zinc gives out zinc ion plus 2 electrons. This equation must be balanced. Yes, you see, why do we put a 2 here? Because this is positive 2. So if it is positive 2, yes, this positive cancels with the negative, and then the equation becomes neutral. Remember, matter is neither created nor destroyed, but can be changed from one form to another. Yes, so your equation must obey that law. And then copper is going to receive these electrons. Yes, it is copper solution. Yes, it's going to receive the electrons. Yes, these electrons from zinc, and then it forms copper. There is something which is supposed to be noted here. If zinc dissolves to give zinc ion plus electrons, it means that this zinc electrode reduces in size. It means that the anode always reduces in size. Why? Because it dissolves to give out the electrons. It is supposed to be reducing in size. Then copper receives these electrons. Yes? And then what happens? What is happening? The ions here, the electrons from the zinc combining with this copper, yes, to form copper to ions to form copper solid. It means that copper, the copper will increase in size. You see, it will increase in size. Why? Because it forms a solid. Yes, if it forms a solid, then the cathode is always increasing in size. There's something we need also to understand better. Because now the copper ions are being used from the solution and then form a solid, yes, it means that now the solution will start to fade out. Yes, to be fading. Why? Because the copper ions which make the solution to be blue, they are being used up. Therefore, now the solution becomes pale. It fades until it becomes clear. Once it becomes clear, then it means all the copper ions have been used. So you need to know those small concepts so that when they bring the question, you are able to answer them nicely and clearly. So, all right, let's compare. Let's compare the two half cells. Yes. Number one, zinc half cell, then copper half cell. The one we have talked about, oxidation reaction at the anode, which is always negative electrode. We know that anode is always a negative electrode. Yes. So oxidation occurs there. It means that zinc will ionize. Yes, when it ionizes, then it increases in the charge. Then obviously reduction will occur at the cathode, and it's always a positive electrode. This one is supposed to be a reducing agent because it causes this copper to be reduced. Yes? And then itself it is oxidized. When it releases electrons, you see, it releases electron, comes from 0 to 2. So it has been oxidized, increase in the state. While this one, it has accepted, therefore it's a strong oxidizing agent. It has caused this one to be oxidized. And for it, it is reduced from positive 2 to 0. You see, it has been reduced. And it has caused this one to be oxidized. It is a strong oxidizing agent because it has caused this one to be oxidized, and itself it is reduced from 2 to 0. That's the meaning. Then when you go to zinc, okay, the equation, this is the equation, what is happening, we saw it nicely, and also this is what is happening, we saw it nicely. Yes, so you read from right to left, we're going to look at it when we go to the reactivity series, and then here read from left to right, you're going to look at it when you go to the reactivity series. All right, so when you're writing the cell notations, we're going to look at it, and then you're going to get it better. All right. We are saying that zinc is a strong, zinc is the stronger reducing agent, while copper 2 is a stronger oxidizing agent. I've explained this. How is this is a strong, strong oxidizing agent? Because it causes zinc to be what? To be oxidized. Then it becomes an agent for oxidizing. But itself is what? Is reduced. And then zinc is a strong reducing agent. Yeah, it is an agent for reducing. So it causes copper to be reduced. But itself is done what? Is oxidized. Then we are saying that the anode always decreases in mass if the reducing agent is solid. I've tried to explain it, that if you look at zinc, because zinc is dissolving into the solution, then the mass must be reducing as long as it is, this electrode is a solid. So it means that it keeps on reducing in size. It is corroded. Yeah, it starts to disappear. All right, and then they're saying the cathode always increase as long as it is a solid, always increase in mass if the reduced product is a solid. Yes, so we saw that since copper is a solid, if you look at it here in the equation, copper is a solid, even you can look at it here, yes, is a solid, then it means that the terminal must be increasing in size, always, as long as it is a solid. Since now you know the concept, now it means that we can apply these concepts in different versions. All right, net cell reaction. It means that we're going to combine the half equations, and then we see what we're going to form. Make sure the half equations balanced. Balance them, including the electrons. I tried to show you on the equation that the electron must be balanced. Add the two half reaction together, eliminating the electrons from both sides. So that now when you add them, then you eliminate the electrons, and then it cancels out, then you form a full equation. Let's look at it. Here is oxidation, which is taking place on this side. Yes, on this side of the half cell. Zinc metal, yes, or solid, dissolves to give zinc ion plus 2 electrons. The 2 electrons, they start to move. These electrons, they will come to this side. So what happens? This one will receive. We'll receive these ones here. When they come here, and then they combine with this copper. So copper 2 ions plus 2 electrons, which came from zinc, and then you form copper solid. So this one forms a solid. It is deposited here. While this one starts to dissolve, which is this, dissolves and then becomes small. Becomes small, becomes big. Husband and wife, one must be becoming smaller, one must be becoming bigger. All right, let's continue. I don't know what is happening in your family. If your father is becoming small or your mother is becoming small, then one must be oxidizing agent, another one must be a reducing agent. All right. Maybe you are the one, you kids, who are making them to be oxidized. Or to be oxidized, yeah, or to be reduced, whatsoever, I don't know. All right. Net cell reaction. So now how do we form? You have reaction which is taking place here, reaction which is taking place here. So arrange them like this and then start cancelling what is. So I check what is before the arrow compared to what is after the arrow. Zinc solid, this side before the arrow. Do I have it? I don't have a zinc solid, I leave it. I go to copper ions this side, yes? Do I have copper ions this side? No, I don't have it. I have 2 electrons. Yes, I have 2 electrons here. Do I have 2 electrons here? Yes, I cancel them out. So those ones, they go. I come this side. I have zinc 2 ions. Do I have zinc 2 ions? No, I leave them. I have copper 2 solid. Copper solid. Do I have copper solid this side? No, so I leave them. So now I combine zinc plus copper 2, zinc plus copper 2. This is a solid, this is aqueous. Always, whenever you have a charge, it is aqueous. You should just have to know that. Then the arrow, yes, and then I have zinc 2 aqueous plus copper solid. These ones, they cancel it. That's how you can write the full equation. Simple. Know what is the anode, what is the cathode, find the equation there. One must be reduced, one must be oxidized. Find the equation, write the equation down, then combine them. Simple. No stress. Then, salt bridge. Part of an electrochemical cell. It's usually a tube. It's usually a tube. It can be containing electrolyte, providing electrical contact between the 2 solutions. So we are saying that it's a part of electrochemical cell. Yes, usually it's a tube. It means that the chemicals are being put into the tube. Containing an electrical contact. It must be containing an electrolyte. It must be containing an electrolyte. It means that it can, the substances you have put there, it must be able to conduct electricity and it should be able to release the ions. Actually, if they can conduct electricity, then it means that it can release the ions and electrons. Providing an electrical contact, it means that it is there is a contact. It's not physical contact. It means electrical contact. Then it means that ions must be exchanged there. It's like an exchange. Functions of salt bridge. Number 1, it completes the circuit. Simple. Anode and the cathode are being connected. That salt bridge must be there so that the circuit is complete. Number 2, it keeps the 2 electrolytes in the 2 half cell separate so that they don't mix. They must not mix. However, it ensures electrical neutrality. So these 2 must be neutralized. If they are not neutralized, then it means that the cells will be impaired. The cells will not work. They will not work anymore. So what they do, they bring about charge, it brings about ion exchange. It brings about an exchange. So by doing that, it ensures that an electrical neutrality is obtained in that cell so that the ions are neutralized so that the cell can continue working or functioning normally. All right. Number 3 is allows movement of ions between the 2 electrolytes from the cathode cell and then the anode cell. The 2 must be able to communicate with one another, even if there is a distance, so the salt bridge connect them. Note, electrolyte in the salt bridge must contain ions which are weak. They must be weak reducing agents and must be weak oxidizing agents. The reason why they must be like this, so that they don't take part in being oxidized and being reduced. Because if they take a part in being oxidized and being reduced, then it means that they are going to be used up. So then the reaction will stop. So they must be strong, so very weak reducing agents and must be very weak oxidizing agents so that they are suppressed by the other ones. This will ensure that ions are not oxidized nor reduced, but act as a spectator ions. So it's just like to neutralize, to bring about neutrality. It's just like that. Nothing else. It's just to connect. So these are the functions of the salt bridge. 1, 2, 3. Let's continue. Very simple. Electrolyte. Let's look at now electrolyte in simple term, and then we understand it better. So once you understand it better, then you'll be able now to combine all of them, and then you go for any question concerning.
Particles in a reaction mixture are in a state of perpetual random motion and therefore collides with one another. So they collide with one another as they are moving. They collide with one another. So it also says that only effective collisions between reactant particles lead to chemical reaction and the formation of new products. Without an effective collision, it means that the products will not take place. Now, here comes a question. When does the effective collision takes place? In this regard, you require the amount of energy must be equal or more than the activation energy. And then number 2, the orientation or the direction in which they collide. If the orientation is correct, then it means that they're going to form new products. We are saying that you need to know number 1, an effective collision between reactant particles take place if the colliding particles have enough kinetic energy. Yes, they have enough kinetic energy to form an activated complex. So when they have enough energy, it means that they can overcome the activation energy. Then they are going to form an activated complex. It's not a reactant, it's not a product, but is in the transition of changing from reactants to products. So it is unstable compound which is formed. It is unstable compound which is formed, and then the reactants are being converted into products. So as long as these reactant particles, they have enough kinetic energy, if this energy of the colliding particle is equal or more than the activation energy, then the reaction will take place. Not only that, also we are saying that particles are correctly oriented when they collide. So this, although they have enough energy, but if particles are not collided in correct orientation, then it means that these products will not be formed. If carbon monoxide and oxygen, they react with enough with less energy, then the reaction will not take place. But if the reaction has enough energy, carbon monoxide has enough energy with oxygen, then they can be converted into product as long as the orientation is correct. So if you look at this carbon monoxide and this one, here the orientation is wrong and then the reaction didn't take place. Here the orientation is correct and also have enough energy, then automatically the products are going to be what? Are going to be formed. And then if you look at also another example, you'll find out that this is trying to show you that the orientation you are looking for is this. So if these ones, they react with, they collide with this, collision 1, collide with this with enough energy, then the products are going to be formed. But if you look at this, collision in number 2, the orientation is not correct. However much this molecule has energy, but the orientation is not correct. So the products are not going to be formed. And then if you look at this, if still the orientation, the direction in which they approach each other is not correct, so products are not going to be formed. Even here, the orientation or direction is not correct. As long as all these 3 alternatives, the reaction is not going to take place. The orientation must be correct. The particles must have enough energy or more than equal or more than the activation energy. Then the products are going to be formed. So this is trying to explain the correct orientation and the enough amount of energy so that products can be formed. So if you look at some of the factors which affect the rate of chemical reaction,
today we are going to be looking at the final revision. So meaning that we're going to be discussing about some questions, and then I give you a highlight of what is expected to be in your exam you're gonna write. If you have any challenge or any question, let me know so that I can help you out. Let me start with some questions I've prepared you so that we can at least have a clear view of what you expect to find in the paper. I'm going to be dealing with all the sections so that everyone, or if you have any challenge on a specific part, then you are helped out. M. Saidi, don't forget to subscribe, like, and also share for others so that they can also benefit. Let's start without wasting time. We have different questions here, and the first question is about organic. Don't forget that this paper, most of the marks are going to come from organic, meaning that we expect you to be passing this paper. And then the other parts you'll find, if you do organic, it's a guarantee that you have passed. I'm talking about the minimum, the mark which doesn't take you to the university, less than 50. So when you have now you add these other sections, then you project your marks to a distinction. So let's focus for a distinction, not just a mere passing. All right, let's start with these questions. They're saying that letter A to D in the table below represents 4 organic compounds. So you have different organic compounds here. So the first question is going to be about this naming, identifying the type of functional group, homologous series, such things. So let's look at it. Letter represents a keton. Which letter is representing a keton? Don't forget that a keton, it has oxygen and 2 alkyl groups, meaning that this can be a carbon and this is a carbon and a carbon. You understand? Doesn't matter how long it is, but this functional group must be in the middle. So in this case, if you look at this, it's no. Check here. This is see the way it is there. You see that that's the functional group, and then it resembles this. So the answer becomes B. So when they ask you about the keton, I think you can differentiate it from the aldehyde and alcohols. Then we got the structure formula of the functional compound of group of compound C. When you look at compound C, they're saying the structure formula. Here is the key point. Don't just write. They're saying the structure formula. So what is the functional group of compound C? What is compound C? So compound C, it is what? The functional group of compound C. If you look at compound C, it is what? It is an aldehyde. So how do we write the functional group of the aldehyde? Sorry. So it's going to be C. Yes, it has an alkyl group with oxygen and then a hydrogen. So these are just the simple questions of which anyone can answer them. So I'm not going to waste too much time. I want to take more time when it comes to the chemical equilibrium, acids and bases, those questions which require more and more calculations. Then we go to the general formula of the homologous series. So look at this general formula. They are looking for the general formula of homologous series of A. Where is A? It is an alkyne. So alkynes, don't forget that you have CnH2n plus 2. that is alkane. CnH2n. When you leave it like that, then it becomes alkene. Then CnH2n minus 2, then it becomes an alkyne. So you start with the 2, then you don't talk about the 2, then you minus the 2. So basically, that's how you can remember that structure. So in this case, what are you going to say? You're going to say that, guys, if you have a question, let me know. Please don't keep quiet. If there is a question, I'll try to answer that question out. All right, let's go to, we are saying that, so it means that this becomes the answer for our question, this question which we are talking about, because it is an alkyne. So we're done with that. IPAC name of A. If you look at A, what are you going to label on A? Where is A? So look at this. You have, now let's label it. Sometimes naming it becomes a problem if you don't understand the criteria you're supposed to write. Basically, where is the problem coming from is to identify the functional groups. To identify not the functional group, the side groups. The side groups becomes a very big problem. So you have 1, 2. So this one is on number 2. Number 1, this is 2. The functional group is on carbon atom number 2. 1, 2, 3, 4. The functional group is on carbon atom number 4 if you use this direction. I think now we can find out. All right, now let's count. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. I think. So it means that this one has the longest chain comes like this. You see? 1, 2, 3, 4, 5. It means that now this one is on 5. 1, 2, 3, 4, 5, 6, 7. 1, 2. So I'm gonna go with the shortest one. So meaning that if I go with this as the longest chain, so it means that this and this are going to be the side groups. So now let's label it, or let's try to name it, and then we find out. So guys, you should not have a challenge with this. So now let's count. 1, 2, 3, 4, 5, 6, 7. 7 is helped, né? But is the functional group is on carbon atom number what? 1, 2 is on carbon atom number 2 dash 2, and then you say because it is an alkyne, so I'm gonna add Y and E, so it is heptene. So however much if you lose this, what is before here, but you have mentioned this correctly, at least we shall give you a mark. Try and do what you think, where you can get marks, because when you are answering this, we don't answer this all of it, like all of it, then you get all the marks once. You get all the marks once. No, we give you marks depending on what you have answered. So you must not panic because you have lost the longest chain. No. So okay, let's continue now. So if this is heptene, then let's look at now the side groups. So because you have used this direction, guys, don't change the direction. No, you continue with that direction you have used. So now you're gonna be 1, 2, 3, 4. This one is on carbon atom number 4, but it is a what? Which side group is this? It's 1, 2. So it is acyl, because the side group is eth. So I add YL to show that it's a side group. But it's on which carbon atom? 1, 2, 3, 4. So it's on carbon atom number 4. So it's going to become 4-ethyl. Then I continue saying that 1, 2, 3, 4, 5. This one is on carbon atom number 5. So it's going to be 5. How many carbon atom is 1? So it's going to be meth. Because it is a side group, I'm going to add YL. So it becomes methyl. So now I've got to know the naming of the side group, the naming of another side group, and the main chain. Now I have to combine all of them. How do I combine them? How do I combine them? I have to look at this, and I look for which one is first in the alphabetical order. I don't change the numbers. I only start writing with the one which starts in the alphabetical order. So now if I have this E and M, I will find out that is E which is first. Therefore, I'm going to say 4 dash ethyl, yes, dash 5 now, dash methyl, yes, you see, now hept-2-ene. That's how we label, or how we name this. How do we name it using the IPAC naming system? So I think I'm clear there. Unless you have a question concerning about it, let me know if you have any question concerning about that. Now let's go to the next question, and then we see. The next question is saying that IPAC name of B. What is the IPAC name of B? B is a keton. So since it is a keton, it is simple to write. It must end with on. So it is 1, 2, 3, 4. So it's gonna be 4 is but. You understand? So but 10, and then what is the functional group? Where is it found? Is carbon atom number 1, 2. So it's gonna be but 2 on. Listen carefully. There is something small which makes students fail when it comes to this. Listen carefully, and let me give it to you. What makes students fail? Okay. When it comes to alkene, yes, alkene, alkene, and alkynes, yes, you say but, prop, then you put whatever you want to put. Ne? But when it comes to alcohols and other homologous series, you don't stop here. For example, this is but-2, but-2, maybe yin, whatever. Ne? But now when it comes to alcohol, you say butane. You add this until here, then you say 2 or something like that. It is supposed to go up to this point. But if you're talking about alkene, alkene, and alkynes, you only stop on but. And when you're talking about the side group, you only stop on but. Like you don't go to butane. You understand? So please, also that one makes students to fail. Let's go to question 4.5. Question 4.5. So I think we are done. So it's gonna be but-2 on. And then compound D is a gas used in cigarette lighters. You understand? Compound D. Then they're saying that which homologous series does compound D belong? So compound D. Let's look at compound D. Where is compound D? Is butane. So to which homologous series does it belong? It belongs to, the moment you say butane, N, it is an alkane because it is derived from there. It's an alkane. So the homologous series is alkane. So they are saying that write down the structure formula and IPAC name. The structure formula and the IPAC name of what? The IPAC name of structure isomer of compound D. Structure isomer of compound D. What does it mean? Okay, they're saying that write down the structure formula and IPAC name of compound D. Someone is asking. All right. They're saying that, to which homologous, okay, IPAC name, write, the compound D is, okay, we are done with that. Write down the structure formula and IPAC name of structure isomer of compound D. So what are you going to write? Where is compound D? Compound D is butane. You understand? But they want the structure, write down the structure formula. They want the structure formula and the IPAC name of that compound D. So what are you going to write here? So compound E is butane. Let's look at butane. It's 1, 2, 3, 4. So it's a butane. So butane is like this. Okay, it's like that. So I'm going to bring about the what? I'm going to bring about the isomer. So what I'm going to bring about, I'm going to bring this and I put it there. So it's going to become 1, 2, 3, 3 because it's 1, 2, 3, and then I can put it down or up. It's the same thing. Make sure that everything is put 4 hydrogens. It must be hydrogen. Don't leave them hanging. It must be, all of them must be hydrogen, hydrogen, hydrogen. Cool. Yeah. So now it has become an isomer of this. So now I have to label it. So what am I going to label? It's 1, 2. So this one is on carbon atom number 2. So it's going to be 2 methyl, because this is a side group. Methyl, methyl, and then 1, 2, 3 propane. That's it. That's what they want. So they will give a mark here, and they'll give a mark here depending on what they have put the marks where exactly. Then let's go to the next question. They're saying that is isomer, you have mentioned above, positional, chain position, or functional. So what if you look at it, what has changed here? Is it a functional group? No, we don't have functional isomers in alkanes. Yes. So what you have changed here is the chain. You have changed the chain, the structure of the chain. Therefore, it's going to become chain isomer. It's going to become chain isomer. So the answer here takes place. How do we call that type of reaction that takes place there? Because we have substituted hydrogen with bromine, then it's going to become substitution reaction. But which type of substitution? Is going to be halogenation. Which type of halogen? The actual halogen which is being substituted there is bromination. Actually, you have added bromine in there. So basically, substitution is a big one. Halogenation is a little bit bigger or moderately. And then bromination is the actual. If it is chlorine, then it's going to become chlorination. If it is iodine, it's going to become iodation. So it depends on what you have substituted. But if you don't remember all that, just say halogenation, because still they will give you a mark in that regard. Before I go to the next question of this, so that's the first question, is about naming. Make sure that when you go to the paper, you are able to answer a question concerning about that. You understand? The next question which I can talk about here, where students might lose marks, is when they bring a question whereby they ask you for the reaction. I think I will speak about it when it comes to the reaction, whereby they react with bromine, and then this the red color of bromine is what turns colorless. You understand? In actual sense, is decoloralized. Ne? It turns what? Colorless. Yes, as a result of passing through a specific compound. So when the bromine color turns into colorless, as a result of that reaction, it means that that compound had a double bond between carbon atoms, or it had a triple bond between carbon atoms. So alkanes, they will not decolorize. They will not change this bromine water, the red color, into colorless. Never. What will do that is either a triple bond or a double bond. A triple bond can be converted into a double bond, and then at the end of the day, you will have bromine attached on each. You understand? So you need to know that if they bring it in an experiment, you must know that the one which decolonizes must have a double bond, or it must have a triple bond. Okay, let's go to the next question without wasting time. The next question, they're saying that consider the organic molecule or organic compound represented in that diagram. They're saying that A to C below, what happens to A to C? They have given you different molecules. You understand? Yes. So in this case, you have to just a moment, guys. Okay. They're saying that name the homologous series to which C belong. To which C belong. Where is C? C is here. So it's the same example as the other one. It is to which homologous series does C belong? It belongs to the ketones. Check how it is. So it is a keton. Yes. And then they're saying that what is the IPAC name of A? You see, now it's the same question which they brought there. Now it's almost the same thing. So it seems that you won't be able to fail anything related to naming. So what are you supposed to do? First find the identify. Let's just show you how you name it. The same way I named the other one. 1, 2, 3, 4, 5, 6. No. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So you see, now the longest chain is 8. So is it a single bond? Single bond is out. So it means that this is going to be a side group. Is it only that? We also have this and this. I think. So they are going to be side groups or the functional groups. Ne? So if I count from this side, 1, 2, 3, 4. This one, the first one is going to be on carbon atom number 4. The second one is going to be on carbon atom number 5. What about this? 1, 2, 3. The first one is going to be on carbon atom number 3. The second one is going to be on carbon atom number 4. So I'm going to go with the short one. So now it means that I'm going to have 1, 2, what am I going to say? I'm going to say 3, comma, a figure, and the figure we separate with the dash. 3, comma 5, dash, di, chloro, then I add this, dash, 4, dash, methyl, 3, comma 5 dichloro, 4 methyl octane. So that's how we basically supposed to name these organic molecules. Guys, I think it's not that. Do you find any challenge? Someone is asking me that, do you have the memo for Gauteng September paper 2? They are writing tomorrow. Why should you ask for the memo? I'll give you the memo tomorrow. When immediately after you are done. Then I'll go through the paper. Yes. Even if I give you the memo, does it mean that you're gonna get a memo on finals? So it means that you're just ruining your life. So guys, let's concentrate on this. Let's go through this, and then tomorrow when you come out of the paper, you come back and tell me a story. Yes, let's go through them, and then tomorrow when I'm going through the paper you're gonna write, tomorrow maybe around the 2 o'clock or depending on the electricity, or 4 o'clock. Yes, I'll go through your paper, and then you see how you have. Even if you have not passed, still to help you to prepare for the finals. Yes, so don't stress. Let's continue, guys. Let's focus for the future so that we get distinctions. All right. And alcohol and the methanoic acid are heated in presence of concentrated sulfuric acid. The moment you bring about alcohol, and you bring about carboxylic acid, because when you say oic, that's a carboxylic acid. Sorry. The moment you talk about that, you are talking about esterification. It must come into your mind that you are talking about esterification. Okay. So what is esterification? Formation of esters. So it means that you form esters in using alcohol and ethanoic acid in the presence of heat and the concentrated sulfuric acid. Yes. So what is the role of concentrated sulfuric acid in this reaction? Guys, whenever they ask you, the role of concentrated sulfuric acid is acting as a catalyst. Catalyst. You must know that. Is acting as a what? A catalyst. Then I'm saying that write down the name and the formula of the inorganic product formed. Definitely, it's going to be water. Because the moment you have alcohol plus the carboxylic acid, you form in the presence of the sulfuric acid, and you heat, you're gonna form an ester plus H2O, which is water. So it means that water is the inorganic molecule they're asking you to write about. And then when they ask you to write the structure formula, even water must be in form of a structure formula. In most cases, people don't write this water when they're asking you to write the structure formula, and you end up losing marks just like that. Okay, let's go to the next question. Name the, okay, we have seen that the inorganic molecule here is going to be water. So they're saying that ester contains 6.7 hydrogen, and then 4 of carbon, 53 of oxygen, and then the molar mass of ester is 60 grams per mole. Use the calculation to determine its empirical formula, and then later you talk about the molecular formula. How do we do this? It's a simple thing to do and to get. So what you do need to do is to find out the elements which are given in this reaction, and then you are able to get. Okay, the first one is hydrogen, carbon, and oxygen. Carbon, hydrogen, and oxygen. And then you need to know the mass of each they have given you. Carbon, they say that the percentage they have given it in terms of, this is 53.3, and then this is 40, and then this is 6 is what? 6.7, 6.67. Is it carbon? It's hydrogen, It's hydrogen. It's hydrogen. This is hydrogen. Okay, just a moment. It's 6.67, and then carbon is 40, and then the other one is 50. Carbon is 40, and then this is 53.77. Okay. 53. Am I growing up? 53.33. Yes, 53.333. Okay, now that's the mass, the percentage mass. And then what about the molar mass? Molar mass. The molar mass of this is 12. The molar mass of this is 1. The molar mass of this is 16. Then now after that, let's divide and then find out what is it. When you divide, it's gonna be 40 divided by this, 40 divided by 12, and then 6.67 divided by 1, and then 16. No. 53 divided 0.333 divided by 16. So here the answer you get, I don't know. You have to calculate and find out. This is 3.33, and then because this is 1, it's gonna be 6.67, so it's obvious. And then if you divide here, what are you going to get? 3.33. You see? So basically the ratio is gonna be is 1 to 2 to 1. Yeah, if I divide by 3.33 divided by 3.33 divided by 3.33 divided by 3.33 33. So I'm gonna get this more ratio. So now what does it mean? It means that carbon is 1, hydrogen is 2, and oxygen is 1. So that is the empirical formula. But the molecular formula, they say that when you equate this, is going to be 60. Therefore, I'm going to say that carbon, I'm going to put an N here, so that I know. Carbon is 12 plus hydrogen, which is 1 times 2, because there are 2, plus oxygen, which is 16. So what is the answer here? When you add all of them, you're going to get 30. 30, but 30 times n. So it's going to be 30n, which is equal to 60. So divided by 30, divided by 30. So I'm going to get n is equal to 2. So is that the answer? I doubt. Is that the answer? I doubt. So they're saying the empirical formula. We are done with that. The molecular formula, then therefore the molecular formula is going to be C. We say the C. In this case, remember I have n each here. N here because I put it outside here. So it's going to be C is going to be 2. Hydrogen is going to be 2 times 2 is 4. And then oxygen is going to be 2. So basically, that is the molecular formula they are looking for in that regard. Class, are we together? Let me know. Even I'm writing. I've written already though. Haven't. Or paper 2 is already. I thought everyone is done. No. Someone is saying I thought no, it's not done. We're going to have more classes on this physical science because there are so many people who are basically struggling. Parktown boys, we have written already. Just I wanted to know how well I did. Oh, it means that you wrote a different paper. Yeah, because there are some schools where they write different papers. Ne? Yes, they write what? Different papers. Yes, depending on the school. But thank you very much, Butumelo. Yes, where are you from? Gauteng Metric are writing tomorrow. Yes, Butumelo. Yes, it's Gauteng. They are writing tomorrow. Tomorrow they are writing. But finals, I'll be here, guys, for you. Full swing. Make sure that you prepare questions. I'm here to help you guys. Ne? Tell your brothers and sisters, grade 11, 10. I'm also projecting there next year from 10. Yes. So, all right. Let's continue, guys, to the next question. I think we are done with the first set of organic chemistry. Let's go to the next question. The next question. What is it saying? All right, guys. Ne? Yeah, guys, if you check this physical science, the problem is coming from is that students don't give chemistry time, yet chemistry is the simplest. Don't talk about physics versus chemistry. Physics is much more harder than chemistry. Chemistry is nothing. You just don't have love for it. But since you are here, it means that you have love for it. Ne? I love you guys. Ne? Let's go to the next question. Ne? Life is good if you make it good. Yeah. If you don't like chemistry, how will chemistry like you? Obviously, if you don't like me, I'll also say I don't care, man. All right, but if you like me, I also like you too. So that's chemistry. That's what chemistry is saying. If you don't like it, definitely it will say that I don't like you too. All right, let's leave that and then we continue the next question. I'm saying that the vapor pressure, so this is another question concerning about organic chemistry. So you're done with the nomenclature. I hope you guys are going to get all the marks there. Ne? Yeah. The vapor pressure versus the temperature of the pressure graph below was obtained for 4 straight chains. 4 straight, this is a key point. And branched, so they are talking about it. P, Q, R, and S. From P to Q, P to S, each compound differ from the previous carbon by this. It means that it belongs to the same homologous series. That's what it means, because that's how homologous series, the same homologous series, the members, that's how they keep on changing. They are being changed by just this. The vapor pressure are mentioned in millimeters of mercury. This means millimeters of mercury. 78 millimeters of mercury is equal to 1 atmosphere. Yes. Okay, they're saying the atmospheric pressure is 760 millimeters of mercury. All right, let's continue. Give the reason why alkanes are said to be saturated. Whenever I talk about saturation, it means that they have single bond between carbon atoms. Don't say that they have single bond. Where are the single bonds? They have only single bond. That word only must be put in bold, underlined, and in italics. That's the meaning of how important that only is in that definition. They only have single bond between carbon atoms. They only have single bonds between carbon atoms. Yeah. In other words, they don't have any multiple bond. Multiple starts from 3. They don't have any multiple or double bond. So because if you can say multiple, but multiple starts from 3, what about triple bond? What about a double bond? Still, it is not saturated. So it's better to say that only have single bond between carbon atoms. Anyway, let's go to the next question. Vapor pressure. What is vapor pressure? When you talk about vapor pressure, is pressure exerted by the vapor in equilibrium with its liquid. When you stop there, we're going to cross it. Don't forget that these questions are or you get it or you get nothing. Is or not you or nothing. No, it follows that. Either you get all the marks or you lose it. So now people always say that pressure exerted by the vapor in equilibrium with its liquid. The answer becomes wrong. It can only be correct if you add in a closed system. In a closed system. Yes. Yeah, they are saying that now. Use the information in the graph below above to answer the following questions. What is the effect of increase in temperature on vapor? Obviously, when you hit something, it boils more. The pressure increases. The vapor pressure increases. Don't forget that we say that. Look at it. When you increase the temperature, what about the vapor? At 0, the vapor was here. At 40, check, the vapors are increasing. At 80, what about the vapor? The vapor keeps on increasing. So increasing temperature increases the vapor pressure. In other words, don't say that increasing vapor increases the temperature. No. It's not like that. The temperature does not depend on the vapor. The vapor depends on the temperature. So increasing the temperature increases the vapor pressure. If they ask you to describe something, and then if you give the reason, it means that you are giving more kinetic energy these molecules so that the bonds are breaking and then they can escape now. You understand? And then as they escape, they bound with the walls, and then the vapor increases. Anyway, one is going to ask you that. All right, let's go. They're saying that what is the effect? We are done with that. Increase, decrease. Oh, just choose. The answer is increase. Which compound has the boiling point of approximately 68? This is always. Give a reason for your answer. Okay, let me first clean up here so that we don't mess up. All right. 68 temperature. What are they saying now, man? Which compound has the boiling point? Approximately 68. So you have P, Q, R, and S. So here they are saying that boiling, so it's around here. You see, it boils here. You see, because this is the vapor, this is the atmospheric pressure, it must be equal so that something can boil. They say it here, 760 millimeters of mercury. So it means that whatever is here, it is boiling now. So now, if you look at it, here is the, if this is 60, maybe this is this, somewhere here. That's why they say approximately 68. Give a reason for answer. Yes. What are you going to say? it is the temperature where the vapor pressure of Q equals the atmospheric pressure. Yes, which is actually 760 degrees. So in other words, if you look at the graph, that's where the two intercept. This one intercepts with this. So therefore, that's the boiling point of that. So sometimes when you ask you questions, they're a bit tricky, and then you have to at least to look at what is being given so that you are able to answer those questions. All right, let's continue to the next question. Let's go to the next question. All right. They're saying that which compound has the longest chain length? Which compound has the longest chain length? If you look at the longest chain length, will mean that it has the highest boiling point. Yes. Why? Because the higher the number of carbon atoms, it means that the intermolecular forces of attraction will increase, and then the boiling point is going to increase. Actually, it's S. Why? Even you don't know what is the boiling point based on this experiment. It means that its boiling point will be there far. If we project, it will be around 100 and maybe 50, somewhere. Yeah. So they're saying that which compound has the longest chain? Explain your answer. So basically, what you can say that at a given temperature, at any given temperature, basically S has the lowest vapor pressure. If you look at it, né? It has the lowest vapor pressure. No, there is the lowest vapor pressure. Yes, because if you have check. If you check here at this temperature, at any given temperature, check. Let's consider this. Let's consider this. At this, maybe 90. The vapor pressure here is, check where it is. What about this one? What about this one? It will be very far. What about this? It will be very far. If I compare this, you see that, and then this one, it will be a little bit higher. And then this one will be higher. You see that this one has the lowest vapor pressure, meaning that the higher the vapor pressure, the lower the boiling point. And the lower the vapor pressure, the higher the boiling point. So basically, that's why we say that this one has the highest boiling point. And then it means that the intermolecular forces of attraction between they are more, or they are strong, and then it requires more heat to break this. Hence, it has a higher boiling point. Compound P has 5 carbon atoms. Let's look at compound P. 5 carbon atoms. Draw the structure formula of compound P. Write down the APAC name. Compound P has draw the structure formula. Wait, because they said something here on top, and they said that they are straight and branched chain. You see? But what do they want? They don't want compound P. They want the isomer. So what I'm going to do, 5 carbon atoms. Yes. How many isomers can it form? 5 carbon atoms. How many isomers can it form? It's 1, 2, 3, 4, 5. Okay. 5. Isn't it? So the molecule is like that. But they're saying isomer. So I can bring this here. It becomes an isomer. Or I can bring it's now it's gonna be 1, 2, 3, 4. And then I put another one there. So the rest are hydrogen. You see? That's the first isomer. I can still bring this here. And then it becomes 1, 2, 3. I put there and I put there. I change it into, is a primary, into a secondary, or into a tertiary. You see? I put, guys, you must always put hydrogens here. Yes. Done. So it can either be this or it can be this. Depends on what I want. Let's go to the next question. IPAC name. So you choose whatever you want. So it's gonna be 1, 2, 3, 4. So it's 4. So it's gonna be butane. Ne? But it has a side group which is methyl 1, 2. So it's gonna be 2 methyl butane. Oh, this one is gonna be 1, 2, 3. 1, 2, 3. 1, 2, 3. So it's gonna be propane. But it has two side groups, which is methyl. So it's gonna be 2 methyl 2 dimethyl propane. Simple. Let's go to the next question. This one is also about the boiling point, vapor pressure, but it requires you to explain the intermolecular forces of attraction. Yes, at least you need to explain the intermolecular forces of attraction. So what is boiling point? We have seen it, that basically vapor pressure, a boiling point. What is exactly, we say that make sure that you talk about the vapor pressure equal to atmospheric pressure, and it must be in a closed system, and this vapor must be in the dynamic equilibrium with its liquid. So basically that's how you can get the mark. Then you're saying that curve P, that's bad manners. What is bad manners? You just got the question without reading the statement. You always get 0. Relationship between boiling point, and the number of carbon atoms of straight chain alkanes and carboxylic acid, alcohol. Oh, carboxylic acid, alcohol. Okay, sharp. They're saying that now. Graph P, write down conclusion that can be drawn from the above results. P, where is P? For graph P, write down the conclusion that can be drawn from above results. Basically, as the number of carbon atoms, let me check number of carbon atoms. As the number of carbon atom increase, the boiling point also increases. Don't say boiling point increases, leading to increase in the number of carbon. As the number of carbon, because this is independent, this is dependent. As the number of carbon atom increases, the boiling point also increases. Identify PQR that represents each of the following. Alkane. Remember that alkane has only London forces. Alcohol has London force and and hydrogen bonds. Ne? Yes. And then carboxylic acid has dipo hydrogen bonds and London forces. You understand? So it means that now it's able to have a higher boiling point. So definitely this is gonna be carboxylic acid, then this is gonna be alcohols, and then this is gonna be alkanes. Yes, because of the boiling points are low. They're saying that represent each of the following. Alkane, we have seen it. Alkane is gonna be P, and then carboxylic acid is gonna be C. Explain the answer you have mentioned above. Yes, because alkanes, they only have London forces, which require less amount of heat to break the intermolecular forces of attraction. Hence, their boiling point is low. While carboxylic acid has London force, dipo force, and hydrogen bonds, which require large amount of heat to break those intermolecular forces of attraction. Hence, their boiling point is a little bit what? Is a little bit higher. Yes, I think I'm clear there. Let's go to the next question. Now we are done with the physical properties. Now this one I'm just going to do one question regarding to the reactions of this organic molecule. Then after that we can go to other questions until we reach the is there any question? Let me check and see. There is no question being asked. If there is no question, let's go to the next point. Guys, if you have a question, let me know. Ne? Mutumero, do you have any question? Mutumero, are you here? I don't know how you call it. Boy Tumelo. Okay. All right. Just a moment. Technology. All right. They're saying that the diagram below shows how alcohol, yes, P, can be used to prepare other organic compounds. A to E represents different organic molecules or reactions. X, Y, and Z are organic compounds. Okay, sharp. Let's go. Then they are saying that A, what are they saying? Okay, here you have an alcohol, which is a secondary alcohol, because the carbon atom with OH has two other alkyl groups. Okay, sharp. This one, when is alkane. What about this? When I add this is alkene. When I add the hydrogen, then definitely it's going to become alkane. And then even the condition, you can see it. You're adding hydrogen, and then compound X, bromine. So this is substitution because I'm adding this. Then if I'm taking it back, it's gonna be still hydration. Is still substitution. But when I go to this, then because I'm gonna remove the hydrogen, the bromide, so it's gonna be dehalogenation. So it's gonna be elimination. So okay, now let's go to the question. Is P primary, secondary, or tertiary? Is a secondary alcohol. Okay? Why? Because the carbon atom, this carbon atom with the OH group, yes, has two alkyl groups, or it has two carbon atoms attached to it. They're saying that write down the type of elimination that takes place at A. So where is A? Is A. So from here, from here to here. So I have, so meaning that alkene, meaning that I introduce a double bond. So it means that the water is going to be removed. Therefore, it becomes dehydration. And then they're saying that, so we're done with that. Additional reaction that is represented by B. Where is B? From here to this. So it means that I'm adding this alcohol. So I'm adding from double bond to an alcohol, meaning that I'm adding water there. OH. Let me just say OH. So it means that I'm hydrating. So meaning that the answer here is gonna be hydration. Then I go to elimination that is represented by D. So because this compound was, I want the compound to be like this. So only to form like this, yet it had a halogen on it, and it's one halogen. You see, it is one halogen. So I'm gonna remove the hydrogen and the halogen. So it's gonna be D because I'm removing. So I'm gonna say D. What am I removing? I'm removing a hydrogen. So it's gonna be dehydro. Yes, and I'm removing a halogen. So it's gonna become dehydrohalogenation. So I'm removing the hydrogen and the halogen, hence the name dehydrohalogenation. Then we go to the next. Sodium hydroxide is used as one of the reactants. Sodium hydroxide. Yes. Okay. So sodium hydroxide is used as one of the reactants. Where? Okay, write down. Where? Oh, here in this reaction C. Let's look at reaction C. Let's clean up this so that we see exactly what they are saying, so that we don't get confused. C. Yeah. Sodium is used as the sharp. In this case, it means that it's sodium hydroxide. Sodium hydroxide. What type of reaction that takes place there? When sodium hydroxide is used. So from here to here, you understand? It's basically you are substituting a halogen with the OH, meaning that you can say it's a substitution reaction, but because we are using this, then it can also be hydrolysis, or you can say substitution. Yes. And then they are saying that write down state 2 reaction condition for this reaction. So what are you going to say in this case? This is sodium hydroxide. But how about sodium hydroxide? It can either be concentrated sodium hydroxide or dilute sodium hydroxide. Because it is a hydrolysis, therefore it's going to become dilute. So the sodium must be dilute sodium hydroxide. So, or you can say dilute strong base, because sodium hydroxide is a strong base. Yes, so dilute sodium hydroxide or strong base. And then we can have, sometimes we heat or moderate temperature, mild heat, or warming up, mild heat. Yes. Or sometimes you can say addition of water. Yes. To change from a halogen into an alkyl, you require the sodium hydroxide or dilute strong base, and then mild heat, and then plus you can say just add some water there so that the reaction can take place. Then we got the next question. They're saying that write down the IPAC name of X. Where is X now? X, yeah. How do I know that X has this number of carbon atoms? It's because of the number of carbon atoms we started with. So it means that I'm going to be able to know how many are they. It's 1, 2, 3, 4. So definitely it's going to be replaced here with a bromine. So it's going to be 1, 2, 3, 4. So it's going to be butane. Ne? But it's gonna carbon atom number at 1, 2, 1, 2, 3. So it's gonna be 2 bromo, 2 bromo butane. Basically, that's what you are going to write. 2 bromo butane. Question: write down the formula of inorganic reactant needed for D. Where is D now? Where is D? It's here. From here to alkene. From haloalkane to alkene. Basically, here we add either sodium hydroxide or potassium hydroxide, so that now the sodium hydroxide can remove the bromide. Yes. So that's what you can write. That's the inorganic compound we are talking about. Use the structural formula. That's where the problem comes from when students are asked to write the structural formula. Use the structural formula. Write down the balanced equation for E. Where is E? Yes, from this to this. Don't forget this is hydrogen. So you'll find out people adding that like that is wrong. It becomes wrong. Let's look at it. What you are supposed to write. So basically it's gonna be, remember, all of them are going to be 4 carbon atoms. So it's going to be 1, 2, 3, 4. Even the one which I'm going to form is going to be 4. Isn't it? Yes, I'm going to add the hydrogen plus hydrogen. Remember, even hydrogen must be in that formula. You see? Yeah. So basically, what am I going to add? It had a double bond. Let me check and see. Yeah, it will use mechanical fluid and then sharp. So it's going to have a double bond. So the double bond is going to be there. The rest are hydrogens. You put them hydrogen. You put hydrogens the way they are supposed to be. Because I'm adding hydrogen, so it's a simple thing. Yes. This one must also be like this. So you put hydrogens throughout, so that you get a mark there, you get a mark there, and you also get a mark there. I think it's 3 marks, ne? Let me check. Yeah, it's 3 marks. So basically, that's how you can get those 3 marks. Then we go to the next question. Write down the APAC name of Z. So Z, where is Z now? Oh, the product. So what are you going to write here? The product here is simple. 1, 2, 3, 4. So it becomes butane. Simple. Butane. Let's go to the next question, which is now more calculations. So now section A, or the organic questions related to organic, they are done. It means that you are able to answer all those questions concerning about that. You understand? Question A is what? Is done. So let's continue to the next question. Tomorrow is saying, yeah, I'm here. All right. You know, but tomorrow you are my daughter, né? So when you are not here, yeah. When I say you are my daughter, and Elana from Parktown says they didn't write the same paper. They didn't write the same paper. There are some schools which write separate papers. They write separate papers. Yeah, they are given. Different schools can write different paper depending on how do they perform. Yes, only finals is the same. Yeah, only finals. Yeah, that one there is no doubt. There is no debate about it. Yeah, there is no debate about it. Yeah, I think I'm clear there. All right, let's go to the next question, guys. If you have any question, let me know. If you don't have a question, let's go to the next question so that we smash it, so that we go to the chemical equilibrium, acids and bases, and then we finalize with the electrochemical cells and electrolytic cells. All right. It's saying that the reaction of zinc and the excess hydrochloric acid is used to investigate the factors that affect the reaction rate. Guys, this word excess is very, very important in this question. Very important. Why? Because this cannot be a limiting factor. Whenever you say excess, it means that it cannot be a limiting factor. So you have to put focus on it. There is a question which is going to be related to it. Yes. So guys, make sure that at least you focus and then look at why did they say that excess. They're saying that balance equation is there. Zinc plus hydrochloric acid give you zinc chloride plus hydrogen. The reaction condition used and the results obtained for the for each experiment are summarized in the table below. And then there's same mass. This word same mass of zinc is used in all experiments. The zinc is completely converted in all reactions. Then the reaction time is the time taken. They're saying reaction time. They're not saying the rate. Time taken for the reaction to be complete or completed. All right. And then they're saying that experiment number 1. Yes. Experiment number 1 and experiment 5 are compared. 1 and the 5 and the 5. So they compare. So they selected those two. Okay. Let's see what they're saying so that we can know what they're saying. Write down the independent variable. Write down the independent variable for experiment 1 and the 5, because they're saying experiment 1 and 5. Guys, let me say this clearly to everyone, whether you are here or you watch this later. Question concerning about rates of reaction are one of the simplest questions to answer, but they are one of the most difficult questions students have failed because it is an application question. So please take note whenever you are answering these rates of reaction questions. Please don't rush. Sometimes we hide something and tends the learner to. There is a simple research I did. It was from 2008 until it was 2018. Yes. The most failed question was that. Yes. So under my research, I found out that. So I need to now to check and see what is happening in these years where I didn't do the research. So please don't be a victim for this. Ne? Yes, let's continue and then so that at least we answer those questions. So they're saying that question one, okay, this and this is the same, this and this is the same, you see. So they cannot affect, it's powder. So what is affecting? Is temperature. Let me see the temperature. Yes, the temperature is affecting. So what is independent there is the temperature in this regard. What? No, this question this is not supposed to be zinc. It's not supposed to be hydrochloric. State of division for hydrochloric powder. There is no hydrochloric acid is a powder. It's supposed to be zinc chloride. I think the people where am I putting it to? Yeah, it's supposed to be zinc chloride. Yes. So that's the answer. The answer is 10 in that regard. Yes. The answer is what? Is 10. Do I say 10? The answer is not 10. The answer is temperature. They're saying define the rate of reaction. Change in the concentration of reactant or product per unit time. When you say is the rate of change in the concentration of product or reactant per unit time, the answer is wrong. Can I repeat? When you say is the rate of change in the concentration of product and reactants or reactants per unit time, the answer is wrong. Because you are saying rate, which means time. So you are repeating the same question. So when you use rate, you don't use per unit time. You understand? But why do you use rate when they ask you to say rate? What is rate of reaction? Why are you using the same word they have asked you to define? So it's better to say that it's the change in the concentration of product per unit time, or is a change in the concentration of reactant per unit time, or is there is a change in the concentration of product or reactant per unit time. Yes, so I think I'm clear there. Please don't be a victim for that. We go to the next question. They're saying that write down the value of x. Where is x now, man? X is here. Oh, is there any other? How am I going to get this? Okay, let's compare this and this. They are the same. No? And this. Okay, let me underline it. This and this is the same. This and this. Don't forget that temperature. This is hydrochloric acid, but they said it here. They said it that hydrochloric acid is already in excess, meaning that increasing this volume it will not do any change. So definitely this is 14. You see, it's an application question. You have to see how you manipulate that question. Yes, because you see how excess is used now. They are saying excess. They said excess. So increasing any volume of that doesn't change anything because they didn't say they have increased the concentration. Yes, the concentration is the same. So increase in the doesn't change anything. Yes, yes. Then we go to the next question, which is Maxwell distribution curve. Yes, for particles. Experiment 1, 3, and 5 are shown. Okay, A, B, and C that represents experiment. So they want you to identify A, B, or C that represents experiment 3. So how are you going to identify this? Okay, let's come back here. They said experiment 1, experiment 3, and experiment 5. So they're saying that which one? Let me see this. What time is 25? Experiment 3. No, time is 7. Time is 5. And time is 4. Okay. Now, they're saying that experiment, give the reason. Which one is experiment 3? Which one is experiment 3? So if the question comes like that, let's look at the temperature. Which one is experiment 3? 3. Look at the temperature. Temperature, no. I don't think so. Let's look at 1, the volume of the concentration of this. Yeah, this one has a higher concentration. And this one has a higher temperature. But temperature, okay, if I say temperature, you'll see that is going to fall more on this side. So definitely C is going to be for temperature, which has the highest temperature. And then the one which is on more particles, so it's going to be the one which has the highest concentration. So basically 3 is going to be B, because it has the highest concentration, more particles are trying to what? To react, has the highest number of moles. In other words, you see that its moles are a lot. And then 5 is for the temperature, so it's going to be C. Why are you saying that? Because it has the highest temperature. More particles will have more sufficient energy. It will have more sufficient energy. You understand? Yes. So that now the reaction can what? More will form products. Why? Because the energy those particles they're having, they are more than activation energy. So more particles will become products. So that's why you see that here. Do you see how these questions are a little bit tricky? And because they're not straight out, so people, they tend to lose it. Experiment 6 is now conducted using a catalyst. Experiment 6 is now conducted using a what? A catalyst. So what happens about the catalyst when it's applied? The rate of reaction is going to increase. So the same reaction condition as experiment 1, meaning that same reaction condition. So they're asking you, how will heat, what is the function of the catalyst in this experiment? To speed up the rate of chemical reaction. That's it. To increase the rate of chemical reaction. That's it. How will the heat of reaction in experiment 6 is going to be the same? Because the catalyst does not change anything. It only alters the speed at which the reaction is taking place. Therefore, the answer is going to be equal to, yes. Calculate the average reaction with respect to zinc in number 2. So what are you going to say here? The average reaction. So now you have to know, because zinc, you find the number of moles, yes, of which is mass over molar mass. I have the mass. Therefore, number of moles is going to be equal to 1.5 divided by zinc. Zinc is 65 from the periodic table. So the number of moles is going to be equal to, you find is maybe 0.023. Use your calculators, then this is moles. Did they say the number of moles? No, they are looking for the speed at which it is taking place. So this experiment is that? Experiment number 2. So experiment number 2, the final time is 14. So meaning that is going to be change. So it's going to be change rate, don't forget, is equal to change in the product or reactant concentration over change in time, over change in what? In time. So it's going to be 0.023 minus 0, yes, final minus initial, then divided by 14, that's the final, 14 minutes minus 0. So after that, you divide this by this. So the answer you get is around 1.65 times 10 power negative 3. But now these are moles per minute, because this is measured in minutes. Unless you had converted it into seconds, measured in the minutes. Unless you converted it into seconds, then that's when you can talk about that. Okay. Is there any question you would like to ask or to know about before I go to the next question? So that's rates of reaction. Sometimes we ask you a question concerning about rates of reaction, and we ask you that what are some of the factors which affect the rate of reaction? So you have to know how to deal with that. You know? The factors which affect the rate of reaction, you have to know all of them, and which one affects the gases only is pressure. Pressure occurs in what? In gases. So please make sure that you know at least that. When we go to the next question, yeah, it's about still the Maxwell distribution curve. This one, the reason why I like it is because whenever they bring it, students tend to fail. They tend to fail. Let's go to the next. Started a Maxwell distribution curve for this reaction. Your PQR, all right. The shaded area, those are the particles which have sufficient energy to form products. And then the unshaded area, those are the particles which don't have sufficient energy. Their energy is not equal or more than activation energy. You understand? Yes. So when you do the temperature, you will see that most of them, they will go, more will be there. And then when you do the concentration, it will increase a little bit up because you have increased the number of what? The number of particles. Yes. So you need to know when the temperature is applied, when the concentration is applied. You need to know how to redraw that graph. So P and Q are labels for axis. Okay. What quantity is represented by Q? By P. So you have said it. P is the kinetic energy. It shows the kinetic KE, kinetic energy. And then Q shows the number of particles or number of molecules. We don't know whether they have sufficient energy or we are just talking about the number of molecules as we go up, the number of molecules in this reaction. You understand? Yes. R represents the minimum energy required for the reaction to take place. Write down the term under this. We call it, how do you call that energy? The energy is called the activation energy. You understand? Then they're saying that write down the term. Okay, we are done with that. How will the shaded area of the graph be affected when the catalyst is added? Choose, increase, decrease, or remain the same. How is this shaded area? When you apply a catalyst, you are lowering the minimum energy required for the reaction. You are giving it an alternative pathway, which is a bit quicker. Yes? Yeah. So it's like they ask you, you are going to, for example, to Europe. You can use a plane or you can use a boat and then use the ocean, sea. So, but sea is going to take you longer and energy. So when I bring you a ticket for the plane, is an alternative way to reach there. Simple and easy. So when you apply the catalyst, you are making an alternative way how you can reach there. And many are going to do that. Check when you're using Istimera, the train. The train. You're using the train to go wherever you want to go, or you are using the taxi to go wherever you want to go. How many people in the train? And how many people are in the taxi? You see that people in the train, there will be a lot going because it's a little bit cheaper. So that's what catalysts do. They give alternative. Therefore, you will see that more individuals here, they will be having a lot. You will be having a lot of them. Yes. When the catalyst is what? Is applied. So basically here is going to be increased. Why? What I can say, Catalysts provide alternative pathway or lowers the activation energy. You understand? More particles will have sufficient energy, and then you're going to have more effective collision per unit time. That's what the per unit time. If you don't write it, you lose it. More effective collision per unit time. You understand? And then this increases the collision. Then this increases the rate of what? Reaction. So basically, that's how you can explain using the collision theory. Yes. Before I go to chemical equilibrium, let me check. Yeah, I still have a bit of power. Electricity went a long time. I hope it will make me survive. So before I go to chemical equilibrium, because now you are going to chemical equilibrium, so that we can also tackle it. We can also tackle it, and then we see what we can do. And they're saying that I'm from District 11, Gauteng. I'm asking because I see some from Gauteng school saying they. Guys, stop that habit of some from. Anyway, they wrote you have not. Let's focus, guys. Let's focus. Everyone has a destiny. So our destiny is tomorrow, and we have to crush it. We have to crush it. Yeah. All right. Don't stress about those people who have written of which you will never write the same paper. Yes. Yeah. You will never write the what? The same paper. Okay, guys. Before I go to chemical equilibrium, let me just talk about this simple graph. I think you know it. You know it very well. When I have a graph like that, what does it mean? It means that this is it. You start from a low energy to a high energy. Therefore, it is an endothermic reaction. When I have this graph, you start from a high energy to a low energy. Therefore, that's exothermic. You have released energy to the surrounding. How do we call this? A and B. These are products. These are reactants. C plus D. These are products. But this is for reverse reaction. This is what? Reactant. This is product. How do you call this energy? This is the activation energy. This is the activation energy for the forward reaction. But from here to here is activation energy for the reverse reaction. So you have to know all this. Yes. And then change here. It's basically the enthalpy change. Did I say yes? The energy products have, and then here the energy reactants have, and then when I have this difference is the enthalpy change. So you guys, and then you have here the top here, the species which are always here, we call them activated complex. Is a complex which is in the transition. It's not a reactant and it's not a product, but it's in the transition to form products. So when they ask you what's the activated complex, is a species which is in the transition of forming products from the reactants, meaning that they are not yet products and they are not yet what? They are not reactants. So guys, let's continue to the next question, and then we see what we can do to, yes, chemical equilibrium. Yeah, chemical equilibrium. Guys, any question? No question. All right, let's go to chemical equilibrium. You're saying carbon dioxide reacts with the carbon in a closed system. Carbon dioxide reacts with the carbon in a closed system to produce carbon monoxide, according to the following balanced equation. So this is what you have. What does the double arrow indicate in this above equation? What does this double arrow indicate? The double arrow indicates that the reaction is reversible. It's a reversible reaction. You understand? Yes. Is the reaction an exothermic or endothermic reaction. Basically, this reaction is an endothermic reaction. Why? Because the enthalpy change is greater than 0. It's an endothermic reaction. It takes in heat. This is what I said here, that if the enthalpy change, you start from here and then you end up, it is endothermic reaction. Start up and down, it is exothermic reaction because it releases heat. Guys, when you take a deep breath, how do you feel? You feel good, man. You feel relieved. You know how you are relieved? You took energy out. Even you feel that you are releasing the energy, exothermic. You were hyper, now you go down. You feel cool. That is how exothermic reactions are. They start from up, they go to the low. But if someone makes you angry, what happens? You feel it. You feel the heat inside you. Yes? Why? You are collecting the heat. You are absorbing. You feel like yes, that's the meaning. That's when you're going to fight. That reaction is called endothermic reaction. You are taking in heat, and that reaction, when you are cooling down, then is an exothermic reaction. Yes. Anyway, and then when someone comes, okay, let me read it. Let's go to the question. Yeah, so it is an endothermic reaction. Reason why? Because the enthalpy change is greater than 0, or the enthalpy change is positive. What does double R? Okay, we done that. Initially, a known amount of carbon dioxide is exposed to hot carbon. Okay, initially, this is very important. Container at equilibrium, and then the reaction at this is this. Okay, the Kc is 14, and then they're saying that equilibrium found that this is the number of. So you see what I'm highlighting. This is what is given. You need to know that before you go for any calculation. So they're saying that how will the equilibrium concentration of the product compare to that of reactant? Choose from equilibrium concentration of product compared to that of the reactant. Definitely, because the Kc is greater than 1. Yes, therefore the product is going to be more. Look, if I have Kc and then I have product is 2 and then the reactant is 1, what is the Kc I'm gonna get? I'm gonna get 2. What about if I have the Kc, the product is 1 and then the reactant is 2? I'm gonna have 0.5. So if the products are more than the reactant, the Kc is gonna be above 1. And if the products are less than the reactant, the Kc is gonna be less than 1. So in this case, the Kc is 14. Therefore, I'm gonna say that the products are more than the reactant. I think I'm clear there. Then I got to the next question, which is calculate the initial mole of this. So how am I going to calculate the initial mole? All right, this is what you're going to do. Let's use our rice method. It depends on what you have been using. Let me draw it here so that you see exactly as I'm calculating, you see exactly what you are supposed to use. So if I say I'm going to use my rice method, rice, I like to add another E at the end so that I know the concentration. Rice, so in this case, they say that what is the reaction? They're saying that carbon dioxide reacts with the carbon, giving me this, but this is a solid, so I scoop it out. Therefore, it's gonna be carbon dioxide. It's gonna be carbon dioxide. It's gonna give me carbon monoxide. You understand? So carbon dioxide is reactant and carbon monoxide is the product. Mole ratio it's 1, and then here it is what is 2. What is the initial mass? What is the initial? We don't know. Let me call it initial. This means ratio. This means what you started with, the initial. So in this case, we don't know because that's what they are asking us to calculate. They say that calculate the initial amount of moles of carbon dioxide. So let me call it X, or I can call it Y or Z, whatever. Yes. And then here, products, they always start with a 0 unless they say it that maybe they added at this, they added. You understand? So what is at equilibrium? At equilibrium, we don't know. And then here, so what is used, we don't know. C means what concentration and what is being used. And then E, what is at equilibrium. You understand? So how am I going to get this? I don't have anything here. I don't have anything here. But they gave us here a clue here that they say that 16 grams, 168 grams of carbon monoxide is present when at equilibrium. So these moles are present here. But these are grams, so I have to convert it into moles. So I'm going to say that number of moles is equal to mass over molar mass, of which mass here is 168 divided by the molar mass of carbon monoxide. Carbon monoxide is 12 plus 16. 12 plus 6 is 8, is 28. Ne? Yeah. It gives me 28. Ne? Yeah. 28. So when I find the number of moles here, the number of moles is going to be 6 moles. You see? So it means that what I produced is 6 moles. What was at equilibrium is 6 moles because these are product. But now, since this is what is there, ne? So I need to know how much is there because this is what is used. Ne? So it means if I have 6 is 2, 1 is going to be what? Is going to be 3. So now it means that I can find what remained at equilibrium. Therefore, I'm going to say x, this minus this, I get this. X minus 3, so that I get what is remaining here. So at equilibrium, the concentration at equilibrium is going to be 6 divided by the volume. The volume was given here is 2 divided by 2, so it gives me 3. And then here is going to be x minus 3 divided by 2. You see? That's how you keep on calculating. So you make it a table, eh? Yes. So now it means that the Kc, which is equal to 14, they said it here, is 14 is here, is equal to, the concentration of carbon monoxide, but the concentration of carbon monoxide is 2, is 2, so exponential 2, and then carbon dioxide is 1. So of which this one is gonna be 3 squared divided by x minus 3 divided by 2. You understand? After that, now you guys are mathematicians, you can calculate it. Ne? Okay, 14 is equal to, I reciprocate this. Ne? I reciprocate it and then it becomes 3 squared is 9. Ne? 9 times 2, I bring this one up, divided by x minus 3. You can use any method, yes, of which this is 9. Eh? This is 9. So of which is going to be, I bring this one this side, so it's going to be 14x, then 3 times 14, 3 times 14 minus 14 times 3 gives me 9 times 2, which is 18. You see? So you calculate and find out what is it. So this, I bring it this side. You see? I bring this side, and then I get what is x. The x I get is actually what is here. So it's approximately 2. Is it 2? No, it's approximately 4.28. 4.28. 4.28. So that is the number of moles. Yes. What is here? So that's how you guys are supposed to keep on calculating. We bring these questions in 3 phases. We can bring this question when we have hidden the concentration. The problem is here. We have hidden the concentration of the reactant, or we have hidden the concentration. We don't know the Kc, or always the problem is here. So what you need to do is initial minus what is remaining. In most cases, you get it from this side. You get what is remaining at equilibrium. So you divide, then after that you can replace it in the, or you can substitute it in the what? In the expression, so that you get the actual answer. It's saying 3 not x. Sir, where does x come from? Okay, Rumelo is asking me, where does x come from? Okay, let me show you. I said x here. Yes, I said x here because they say that we don't know the initial amount. Check, they're saying calculate the initial amount of carbon dioxide. Carbon dioxide is here. It can't be 3. If it was 3, then it would have been, you see. So I said x. I just gave it unknown. It can be x, it can be p, it can be z, it can be o, it can be n. I just used x so that I can introduce this x, the initial, and then the 3, because I started with the, I produced the 6 carbon monoxide. The mole ratio is 2 to 1. Therefore, if the 6 is 2, and then 1 is going to be 3. You understand? So that now when I subtract this 3 from this, I remain with what I remain with at equilibrium. That's why I said x minus 3, which is used. I will know now, once I get this, I will know what remained at equilibrium. You understand? I hope, Boitmero, you understand where I got the x from. Sir, do you mind to do more Casey questions? Amber, I don't mind any. I'm not minding anything here. As long as it is helping you guys to, let's do more questions about Casey. Yeah, because I know that Casey it becomes a problem to my students and other people's students. But the moment you are here, you become my student. So I'll do more questions now. Let me go to the next question. But I just pray that 37%. The system is having 37%. I hope by that time electricity will be back. But let me do another question about Casey so that at least you don't lose it. If it helps me to go for more questions, well and good. If you see me going offline, yeah, okay. Here is another question for Casey. I put more than enough for Casey because I know that Casey, all the versions they might bring. Yes. Question below represents the hypothetical reaction that reaches equilibrium in a closed system or container. After 2 minutes, this is the question. This is the key point. At room temperature, X, Y, and Z represent the number of moles. X, Y, and Z represent the number of moles. Yes, X, Y, and Z. They don't represent the concentration, they represent the number of moles. The graph below shows the number of moles of reactant and the product versus the duration. So define the dynamic equilibrium. When you talk about dynamic equilibrium, we're talking about the stage in a chemical reaction whereby the rate of forward reaction and the reverse reaction are equal. You understand? The reverse reaction and the forward reaction is the stage. It's a stage where in a chemical reaction whereby the reverse reaction and the forward reaction are equal. So I think I'm done with the dynamic equilibrium. Use the information on the graph, write down the value of X, Y, and Z. So if you look at this value of X, where is X? Oh, X is A. Oh, A. And then Y is B. And then Z is Z. Z is C. Okay. X. Okay. So here, this one is 4. So B is equal to 4 at equilibrium. Ne? And then A is 8. Isn't it? Yeah. And then C is 12. C is equal to 12. So if I divide by 4 here, by 4, I'm going to get 1, I'm going to get 2, I'm going to get 3. So it means that A is X. A is X. Let me rub off here. A is X. Ne? So X is going to be, A is X, is going to be 2. Y is B. Yes, so B here shows it's 1, and Z is C, which is 3. I think I'm clear there. So it just a small interpretation which is needed there. Calculate the case C value for the hypothetical reaction at room temperature if the volume of the closed system is. So we have the closed system. You understand? So it means that we're going to use the same method of, let me now write here so that you see it clearly. Ne? Yeah. So Rice method. I wrote the other side last time because just to show you how it works, but now let me use this. Rice. I say that the last E is just for concentration. So what do I have? I have A, B, and C. All of them are aqueous, so it means that they're going to apply. I have A, B, C. But what is the product? A and B are reactants, so meaning that these are reactants, definitely. So number of moles, A, we say that A is 2, B is 1. A is 2. Sorry. A is 2, B is 1, C is 3. So I know now the mole ratio now. You understand? What did I start with? I need to know what I started with. I started with what here? What did I start with? I started with 0. Obviously, it's the product. Yes, I started with 0. Check here. You see it? And then B, I started with 8. And then this one, I started with 16. Is it? I started with 16. Yes, I started with 16 here, which is A, and B, I started with 8. You see? Let me just show you properly. You see? Yeah, so it's simple there. So it means that, I'm forgetting now. B is 8, A is 16. B is, I started with 8, and then here, I started with 16. Yeah? Yes. Okay, now, I know that now. It's simple. Now, what is the balance? Go to the question. At equilibrium, A is 8, B is 4, C is 12. A is 8, B is what? B is 4, and then C is 12. You see, it's just flowing. They can give you a question like this, simple like that, and then, but this one just to interpret the graph. And then now, what is remaining at equilibrium? Definitely this is the product, so it's going to be the same. Here I'm going to subtract 8 minus 4, which gives me 4, and then here I'm going to say 16 minus 8, which gives me 8. So it's the same thing here. It's the same thing here. You see, it's the same thing here. X3. Then you see. Then you subtract this from this. You see, that's the meaning. You see, Butumero. You see what I was meaning here. It's the same thing, but this question is just open. It's an open question whereby it's easy to get the values. So now I go to find out the concentration at equilibrium. Concentration, I have to divide by the volume, of which the volume, they say that the volume is 2. The volume is 2. Where is the volume? The volume. Oh, is the volume 2? Is container? Yes. Yes, I'm looking for the volume now. They say volume is 2. They say that, yeah, volume is here. It's 3. It's not 2. So meaning that 12 divided by 3. So I get 4 there. And then here, 4. Yes, divided by 3. So I get the answer there. You get the answer there. And then 8 divided by 3. So you get the answer there. I don't have a calculator to do that. You can calculate out. Let me check and see. So whatever you get here, now you put it in the Kc value, Kc expression, whereby in this case it's gonna be C is the product, and it has 3. concentration of C, which is 3, over concentration of A, and over concentration of B. But A is 2. So it means that I have to square A. So now you substitute what you got here in this, and then you find the Kc value. I think I'm clear there. That question is also cool, né? Then Amber, I think I'm clear there. Should I give you more question? All right. Should I give you more question on the? Okay, let's do the last question on chemical equilibrium, so that at least, guys, your happiness is my happiness. When I see you passing, it's my happiness, né? Yeah, because I will know that at least I've changed someone's marks. Maybe by 1, even if it's 1, it's fine. It's fine. The day you get 79.3, 0.4, whereby you are not only 1 mark, it's just 0.01. You know that for a distinction 0.01, and we can't give you that 0.01. Sorry, the system can't. Let's go to the next question, which is 18. Question 18. Saying that 3 grams, guys, whenever they give you the mass, such mass, before you do anything, convert it into number of moles. You converting it is a mark because you're going to use it. So you just come here and say number of moles is equal to mass over molar mass. I don't even know what is there down. So what I need is, so number of moles is 36 divided by of steam. Steam is H2O. You understand? So H2O is 1 times 2, then plus oxygen, which is 18. Oxygen is 16, making it 18. Divided by 18. So I get the answer here. At least I know the number of moles in there. You see? So you get it even before you do what? Yes, before you do any calculation. You understand? Yes. So when you divide there, maybe it's going to be around 2 moles. Yes, at least you'll get a mark there. Anyway, let's continue. Certain amount of carbon were placed in a 2 cylinder. This is important. Sealed container allowed to react. At equilibrium, it was found out that the amount of carbon changed to this. The amount of carbon, yes, changed to 2.225. You understand? Yes. So carbon and this, remember, we're not going to use carbon, but they have the same mole ratio with the carbon dioxide. Therefore, I can use that as a starting point for me to calculate. You understand? So I'm gonna come here and I say, that carbon. Let me use my rice method. Yeah. I hope you will get it. RICE, whereby I have the elements here, whereby they say that, what did they say? Is the steam, hydrogen, and carbon dioxide. Because this is a gas, I don't take this because it's a solid. Please don't include the solids there. Okay? So I'm going to have steam, water, plus hydrogen. Yes. So it's going to give me carbon dioxide. Is it hydrogen? Is going to, no, man. Hydrogen is also a product. Ne? Yes. So it means that, what am I going to do here? I'm going to say, this is carbon dioxide. So carbon dioxide starts with the 0, is a product. I'm wrong. Sorry, ne? This is mole ratio. Let's look at the mole ratio. The mole ratio here is 1, 2, 2. So it's 1, 2, even this one is 2. So what I started with the product 0, 0. I started with the product 0, 0. But I calculated the number of moles of this, because they say that it's an amount of carbon dioxide placed in this container. This it means that this is the initial. Well, the initial mole is 2. So we get a mark for that. So I put a 2 there. Is it clear? But they say that at equilibrium, what happened? They found out this. Meaning that this is the amount of I'm going to find for carbon dioxide because it is 1, 1. The mole ratio is 1, 1. So I'm going to say 0.225. That is what is being used. And at equilibrium, I'm going to find the same thing, 0.225, because it's a product. What you will find at equilibrium is what is produced for the case of product. You understand? But now, this one is 1 mole. What about this? It's going to be 2 moles. You understand? It's going to be what? 2 moles. So what I used here is going to be, what I used here, by the way, even this is a product, so it's going to be the same thing. Yes, it's going to be the same thing. It's going to be the same thing because this and this are products, except this one, this side is a reactant. Now, since I know that, then I'm going to find the mole ratio here is 2. If this is 2, no man, sorry guys. Just a simple thing here. Yeah, I'm a human. Yeah, because this is 1, yes, 1 more, then this one is going to be 2. So it means that you have to multiply. So when you multiply by 2 here, it's going to be 0.45. Yeah? And then even because it's 2 moles, here is 1 mole. So I'm using this. Yeah? So 25, yes. Now, if this is 0.45, why are 0.45 here and here? Because these are products. So what is produced is what is equilibrium. But this is a reactant. What is used minus what you started from, you get what is remaining. So in this case, since the mole ratio is the same, so it's going to be the same figure, 4, 5. But now what is remaining is going to be this one minus 2. So 2 minus 0.45. You understand? So it gives me what's the answer here is going to be 0.775. So this is the figure we are looking at. So now after that you find the concentration at equilibrium, 0.775 divided by 2, because the volume, they say that the volume is what? The volume is 2. So divided by 2. So I go to this 0.45 divided by 2, 0.225 divided by 2. So the answer I get, I put it in the expression for Kc. Kc is equal to carbon dioxide. Is it carbon dioxide? Is it carbon dioxide? Yes, carbon dioxide. And then hydrogen, but hydrogen is squared because it's 2, divided by H2O in aqueous, in gaseous form, which is 2 there. So now you substitute this, and then you find the Kc value. And the Kc value, you'll find it's there, indicated there on the paper, that I put it there so that you know. So when you calculate, you must get that actual answer. So yeah, that is the answer you're supposed to get. Yeah, I think question concerning about chemical equilibrium, we have tried to exhaust them. Okay. He's saying that, but sir, we have 2 reactants and 2 products. Yes, Butumero, we have 2 reactants and 2 products. But the reason why I'm saying 1 reactant is because carbon is in a solid state. When we are in chemical equilibrium, we don't talk about liquids and solids. So this one, check this state, it's a solid. So we remove it out. So we don't consider carbon. If it was in a liquid, if you see the reason why they put this one into a gaseous form is because they wanted to use it in the equilibrium. If it was in a liquid state, we would have scooped it out also. Then it means that we would have used hydrogen and carbon only. You understand? Yes. So in this case, it's like that because we wanted to remove carbon because carbon is in a solid state. That's why I have two products there. Okay, thank you, since you have seen it. All right, let's go to the next question, and then maybe we can see, because I see the battery is killing me here, and I still have I think 16 minutes. I hope in those 16 minutes actually we'll be back, and then we can talk about it. Okay, they are saying that in this question they are saying that give reason why the rate of forward reaction, the graph below shows the forward reaction and reverse reaction with the time. Give a reason why the rate of forward reaction decrease between 0 and 1, 0 and 1, T1. Why is it decreasing? Because you are using up the reactant. Yeah, I usually give such examples. For example, let me say, because let me see, people have commented. Yes, Amber, for example, for tomato, for example, if you have 1 million rand, and then that 1 million rand, you use it, and then you remain with the 10,000. Do you think that you're going to spend it the same way you are using it, you are spending when you are still having 1 million rand? No, because you have used it is now decreasing. The speed at which this money is moving out of your account is going to be low. It's the same thing here. Yes. So it's like that because why? It's because there is a decreased concentration of the reactants. You understand? Yes. Then they're saying that temperature T2, what change made at equilibrium at temperature T3 here? Both changed at the same pace. So it means that there was an application of a catalyst. You understand? Yes. Is the forward reaction exothermic or endothermic? Is the forward reaction exothermic or endothermic? So what are you going to say here? Is it exothermic or it is endothermic? Don't forget it was steam. If it is steam, it requires heat. So definitely it is endothermic. When you added it, you increase the temperature. Check. If you increase the temperature here, what is happening? Yeah? The temperature made it to become, the temperature will favor the forward reaction. That's why you see that the product became more product, and then the reactants started to decrease. So you see that the forward reaction was endothermic. Why? Because increase in the temperature will favor the endothermic reaction. You understand? Increase in the temperature will favor the endothermic reaction. So let's go to the next question. Oh, the next question is about acids and bases. Yeah, the next question is going to acids and bases. So guys, before I continue, yes, I'm going to give you a short break. But in this short break, I'm just going to, because now I see that the battery is dying. I'm gonna come back at 6 o'clock. I'm gonna come back. Why? Because of the electricity issue. But let me just give you a little bit of what? Of electrolytic cells. Yes, electrolytic what? Electrolytic cells.
Welcome back to our class. Don't forget to subscribe if it is your first time to visit our channel.
Volatile cells. Last time we talked about electrolytic cells. We say that electrolytic cells, for them, they require external battery. So if it requires external battery, it means that they are not spontaneous. They cannot continue on their own. So they have to be with an external battery which can supply energy to them. And we say that an electrolytic cell, it changes electrical energy into chemical energy. And then the voltaic cell or the galvanic cell, yes, this one, it's the reverse to electrolytic cell. A galvanic cell, it changes the chemical energy into electrical energy. It means that it produces electricity. All right, let's start. So we are saying that a galvanic cell or a voltaic cell is a cell in which chemical energy is converted into electrical energy. It means that use chemicals to produce electricity spontaneously. It means that without any external source. It means that these chemicals are converted into electricity. A cathode is positive. Remember, in electrolytic cell, cathode is negative. And then anode is negative. Remember, in electrolytic, anode is positive. So remember that electrolytic cell, it is the reverse of the galvanic cell. Reduction takes place at the cathode. This one remains the same as even in electrolytic cell. And then oxidation occurs in anode. Still is the same thing with the electrolytic cell. Strong oxidizing agent is put on the cathode. When you say oxidizing agent, guys, don't remember, when you say oxidizing agent, how about it? What is happened to it? It means that if it is an oxidizing agent, for it, it is reduced. Receive electrons from what? From a strong reducing agent, which is put on the anode. Anode is negative. Then it means that the strong reducing agent, for it, if it is a strong reducing agent, then it means that it is oxidized. It is able to release the electrons. It increases in the oxidation state. When you lose electrons, you become more positive. You become more positive. Yes. When you give credits to others, you become more rich because you know that anytime that money is going to come back to you. All right. So we are saying that we put it on the anode. So you have to understand this, because if you don't understand this criteria, then you won't be able to understand the concept of voltaic cells. So I will say that this is a red card. This is a red card. This is a red card. So don't forget that. I'll tell you what it means. All right. So we are saying red card. What does it mean? Reduction at the cathode. Reduction at the cathode. Consider, now we are going to have an example. We are going to have different examples. Consider copper zinc cell. If you look at them, you'll find out that one is more reactive, one is less reactive. If you look at the reactivity series, this one is less reactive, this one is more reactive. A strip of zinc metal is placed in the zinc ion solution. A strip of copper is placed in a separate beaker in aqueous copper 2 solution. So you have copper, you have zinc metal in zinc solution, and then you have copper metal in copper 2 solution. All right, here is an example. You have zinc, so there is a reaction which takes place here, and there is a reaction which takes place here. Yes, we say that zinc is more reactive. It is oxidized. It can release the electron easily. Therefore, it causes this one to be reduced. So this one becomes a strong reducing agent. Yes, strong reducing agent is supposed to be at the anode. Then copper is less reactive. We're going to look at the reactivity series. And then copper is less reactive. Yes, if it is less reactive compared to zinc, then it means that it's ready to receive from zinc. So copper is ready to receive. To receive what? Electrons. You see them? See them, yes. You see them. Yeah, electrons. So it means that zinc is going to cause this to be reduced. Therefore, zinc becomes a strong reducing agent. It's supposed to be at the anode. And then copper is going to receive the electrons from zinc, therefore is going to be reduced. Therefore, we will say that copper has caused the zinc to be oxidized. Therefore, we shall say that copper is a strong oxidizing agent. Why? Because it has made zinc to be oxidized. That's the meaning. So this is the half cell for zinc and half cell for copper. These two bakers are connected by a salt bridge. Salt bridge is very important in giving these two cells ions. We're going to look at them and you will understand them better. All right. Should we continue? Yes. So we are saying that the half reaction that occur in each half cell. This is what happens. We say that zinc is more reactive. Yes, it is a strong reducing agent. So it means that for it is oxidized. You start from zinc, the charge is 0, and then here the charge is 2, positive 2. Yes, so it means that this zinc gives out zinc ion plus 2 electrons. This equation must be balanced. Yes, you see, why do we put a 2 here? Because this is positive 2. So if it is positive 2, yes, this positive cancels with the negative, and then the equation becomes neutral. Remember, matter is neither created nor destroyed, but can be changed from one form to another. Yes, so your equation must obey that law. And then copper is going to receive these electrons. Yes, it is copper solution. Yes, it's going to receive the electrons. Yes, these electrons from zinc, and then it forms copper. There is something which is supposed to be noted here. If zinc dissolves to give zinc ion plus electrons, it means that this zinc electrode reduces in size. It means that the anode always reduces in size. Why? Because it dissolves to give out the electrons. It is supposed to be reducing in size. Then copper receives these electrons. Yes? And then what happens? What is happening? The ions here, the electrons from the zinc combining with this copper, yes, to form copper to ions to form copper solid. It means that copper, the copper will increase in size. You see, it will increase in size. Why? Because it forms a solid. Yes, and the cathode is always increasing in size. There's something we need also to understand better. Because now the copper ions are being used from the solution and then form a solid. Why? Because the copper ions then start cancelling what is. So I check what is before the arrow compared to what is after the arrow. Zinc solid, this side before the arrow. Do I have it? I don't have a zinc solid. I leave it. I go to copper ions this side. Yes. Do I have copper ions this side? No, I don't have it. I have 2 electrons. Yes, I have 2 electrons here. Do I have 2 electrons here? Yes, I cancel them out. So those ones, they go. I come this, the ions. Actually, if they can conduct electricity, then it means that it can release the ions and electrons. Providing an electrical contact, it means that it is there is a contact. It's not physical contact. It means electrical contact. Then it means that ions must be exchanged there. It's like an exchange. Functions of salt bridge. Number 1, it completes the circuit. Simple. Anode and the cathode are being connected. That salt bridge must be there so that the circuit is complete. Number 2, it keeps the 2 electrolytes in the 2 half cell separate so that they don't mix. They must not mix. However, it ensures electrical neutrality. So these 2 must be neutralized. If they are not neutralized, then it means that the cells will be impaired. the cells will not work. They will not work anymore. So what they do, they bring about charge, it brings about ion exchange. It brings about an exchange. So by doing that, it ensures that an electrical neutrality is obtained in that cell, so that the ions are neutralized, so that the cell can continue working or functioning normally. All right. Number 3, this allows movement of ions between the two electrolytes. From the cathode cell and then the anode cell, the two must be able to communicate with one another, even if there is a distance, so the salt bridge connects them. Note, electrolyte in the salt bridge must contain ions, which are weak. They must be weak reducing agents and must be weak oxidizing agents. The reason why they must be like this, so that they don't take part in being oxidized and being reduced. Because if they take a part in being oxidized and being reduced, then it means that they are going to be used up. So then the reaction will stop. So they must be strong, so very weak reducing agents and must be very weak oxidizing agents, so that they are suppressed by the other ones. This will ensure that ions are not oxidized nor reduced, but act as a spectator ions. So it's just like to neutralize, to bring about neutrality. It's just like that. Nothing else. It's just to connect. So these are the functions of the salt bridge. 1, 2, 3. Let's continue. Very simple. Electrolyte. Let's look at now electrolyte in simple term, and then we understand it better. So once you understand it better, then you'll be able now to combine all of them, and then you go for any question concerning.
Welcome back to our class. Don't forget to subscribe if it is your first time to visit our channel.
So today we are looking at the standard electrode potential. The reactivity series is a list of substances which are arranged in order of their ability to act as reducing agents or oxidizing agents. So now we are going to look at which one is a strong reducing agent, which one is a weak reducing agent. And then if you know that, then you know how to interpret the reactivity series, then you will be able to know which one is going to be on the cathode, which one is going to be on the anode. So we are saying that a table of standard reduction potential can be used to, number 1, we're going to look at that table and interpret it better. Number 1, identifying the oxidizing and reducing agents. So we are able to know that this is a strong reducing agent, this is a strong oxidizing agent. Number 2, writing a balanced redox reaction equation. You can be able to write this, predict whether the reaction is a redox, yes, is taking place spontaneously or not. So you can predict whether this redox reaction is spontaneous or it's not spontaneous. It can continue without an external battery. It can continue without an external source, power source, or it can't continue without an external power source. That's the meaning of spontaneous. And then you're saying that you can calculate the EMF, electromotive force, that is EMF, of this cell. So basically, this is the formula you are going to be using. This is the formula you're going to be using. Electrode potential of the cell is equal to electrode potential of the cathode. Remember, the anode is the negative terminal. So the positive terminal minus the negative terminal. So we need to know which one is supposed to be at the cathode and which one is supposed to be at. Now, look at this. If you are comparing two of them, for example, calcium and the copper, yes? Calcium is at a top level, while copper at a lower level. The one which is at a top level is supposed to be the anode. You must know that. It's supposed to be the anode. And then the one which is at lower level, is supposed to be the cathode. So that's why you see that as you go up, the reducing agent increases the strength. So as you go up, it becomes more strong. It becomes more reactive. It becomes more easily release the electrons. It can easily release the what? The electrons. Or electrons can be easily released. So it becomes a strong reducing agent. A strong reducing agent is supposed to be at the anode. Yes? And then a weak reducing agent is supposed to be at the cathode. Why? Because this one is positive, this one is negative. So this one gives electrons to this. So now we are going to compare copper, yes, copper with hydrogen. So I will come here and say hydrogen is here, yes. Copper, you have copper 2 to copper 1. It's not yet fully reduced. The one which is fully reduced is this one. So I have hydrogen and the copper. So which one is going to be at the cathode? Which one is going to be at the anode? We say that the one which is on top is supposed to be the anode. The one which is down is supposed to be the what? The cathode. So now I will say that hydrogen is going to be at the anode. So it's going to become the negative electrode, the negative electrode. And then copper is going to be at the cathode, the positive electrode. What about when I compare hydrogen and zinc? We have seen here that now here hydrogen is at the anode and the copper is at the cathode. What about hydrogen and zinc? You have zinc here and then you have hydrogen here. So it means that zinc is more reactive than hydrogen. Therefore, zinc is going to be at the anode while hydrogen is going to be at the cathode. You see? So the one which is more reactive must be at the anode. The one which is less reactive must be at the cathode. The one which is on top, even if you don't read this, it's fine. The one which is on top is more reactive, is easy in releasing electrons. You must have that concept. The one which is on top is easy to release electrons. So this one, it easily releases electrons. You understand? So it becomes the anode. And then the one which is below hydrogen, it becomes the cathode. It means that it's easy in accepting the what? Electrons. So let's go back to determining the standard electrode potential of copper half cell. Here you have the copper half cell. You have hydrogen this side, you have copper this side. We don't know which one is the cathode, we don't know which one is the anode. Now, how do I identify that this is the cathode, this is the anode? This is what you are supposed to do. Hydrogen and the copper. Hydrogen is more reactive than copper. So what does it mean? Hydrogen must be at the anode. Copper must be at the cathode. I go back. I have to find out. So we say that hydrogen is more reactive than copper. So this one becomes my cathode. Why? Because hydrogen is more reactive than copper. And then the one which is more reactive, the one which is above the reactivity series is supposed to be the anode. The one which is below the reactivity series is supposed to be the cathode. This is a negative terminal. This is a positive terminal. Negative terminal give out electrons. Positive terminal receive the electrons. You see? Now I'm going to go to identify which one is a positive, which one is a cathode, which is an anode. Now I have to know which reaction is happening on each. If this is negative terminal, yes, and it gives out electron, so I have to show a reaction here where the electrons are forming. It means that when hydrogen comes, yes, it's gonna react here to form hydrogen ions plus electrons. Yes, these electrons will move to the cathode, where copper is going to receive these electrons, so copper 2 ions, plus these 2 electrons to form copper solid. You see here, hydrogen comes in, yes, it forms hydrogen, hydrogen gas, it's supposed to have a gas here, and then hydrogen ions. So it dissolves here, it reacts here at the platinum, and then it forms hydrogen ions, which is aqueous, plus 2 electrons. These 2 electrons, they move. When they move, they come to copper. Here you have copper to copper solution. So I will start with this. Yes. So I will say that I have with the anode. Yes, when you write the serial notation, I have hydrogen. Yes, the hydrogen. This hydrogen goes to platinum. So I have hydrogen gas, comma, it goes to platinum because I don't, this platinum shows that this is just an electrode. But if, okay, I'll explain it. It is showing just an electrode. So this hydrogen, the hydrogen gas, comes to platinum. Yes. When it comes to platinum, it reacts, you see, it reacts to form hydrogen ions. So it reacts to form hydrogen ions. Are you seeing? Which is aqueous. Then I've completed this one. But in between here, we have a salt bridge. Remember I said that the salt bridge is indicated by a double forward slash. So forward slash, then I go to copper. So when these electrons come, they will find the solution here of copper. Yes. So this copper to ions, yes, which is aqueous. Yes, it will give me copper solid, which is this. So basically, that's how you're supposed to write it. In this cell notation, we don't balance the equation. You don't put the 2. No, you just have to write what is really happening. But in the net cell reaction, we balance. It's supposed to be balanced. That's why you have here only hydrogen ion, and yet here you have 2 hydrogen ions. Let's look at another example. So we have said that this is zinc. The reaction is talking about zinc, measuring electrode potential of zinc to iron, zinc to iron in the system. All right, what happens? So now I have to know, this side I have hydrogen, this side I have what? I have zinc. Now I don't know which one is the, don't cram, I don't know which one is a cathode, which one is anode. So we have to go back to the reactivity series, and then we see zinc versus hydrogen. Zinc is here, yes, versus hydrogen. Hydrogen is here, yes. So it means that zinc is more reactive than hydrogen. So it means that zinc is going to be the anode, while hydrogen is going to be the cathode. Let's go back. So now, if you are saying that now, we have understood that zinc is the anode, is the negative, it's more reactive anode. Which one is on top? Anode. And then the one which is at below becomes the cathode. So this one becomes negative. So this one becomes positive. This one becomes negative. So this is anode, this is cathode. This is anode, this is cathode. It means that this one gives electrons to this. So let's interpret. It shows that zinc is going to react, yes, to form zinc ions. Then these 2 electrons are going to move, yes, to go to hydrogen electrode. You see? Now, what happens? The hydrogen ions, which are in the solution here, yes, are going to accept the 2 electrons from the zinc to form hydrogen gas. That's how it's supposed to be. We find oxidation. This one is oxidized from zinc, which is 0, to zinc to iron. It's oxidized. So it releases electrons. Electrons will travel to this. Now, this one is what? Is now negative. It shows that now it can continue on its own. Yes. This, yes, it means that it's a strong, this one, it shows that is a strong reducing agent. If it is negative, it shows that is a strong reducing agent. If it is positive, it shows that it's a weak reducing agent. So basically, that's it. So how do we write this full cell equation or net cell reaction? So you have, you're supposed to start with the anode, then you end with the cathode. In this case, this is the anode, and then this is the cathode. So let's see. Zinc, yes, which is zinc, this one, for the arrow, plus 2 electrons, plus 2 hydrogen ions, which is this. Electrons have cancelled, giving me hydrogen after the arrow, plus zinc 2, which is after the arrow. That's how you're supposed to write. Cell notation. Remember, you start with the anode. So zinc, which is a solid, yes, is oxidized, yes, is oxidized, or it dissolves. This electrode dissolves to give zinc 2 ions. So zinc, which is a solid, is oxidized to zinc 2 ions, yes. So now I don't have anything in this side. Then I'm separating this by a short bridge, slash, yes. When it goes here, these electrons, they will find the ions here, or hydrogen.
Today we are going to be looking at the melting point, the boiling point, the vapor pressure of these organic compounds. So this program is being brought to you by Thunder Movies. You are with Saidi, who is going to be taking you in this class. Let's look at some of the terms which we need to define. Number one is the melting point. Melting point means the temperature at which the solid and liquid state of a substance are in equilibrium. What does it mean? It means that the rate at which the solid turns into a liquid and the rate at which the liquid turns into a solid must be equal, which we call equilibrium. Then we have what we call the boiling point. Boiling point means that the pressure at which the vapor of a substance is equal to the atmospheric pressure. The vapor produced, the pressure it exerts must be equal to the pressure exerted by the atmosphere. And then we have vapor pressure. Vapor pressure means the pressure exerted by the vapor in equilibrium with the liquid or solid in a closed system. So it means that the vapor must be with its liquid or the vapor must be with its solid. They must be in equilibrium. So the amount which is being converted, the rate at which these two are being changing from maybe vapor to liquid, liquid to vapor, and then solid to vapor, and then vapor to solid, they must be in equal rate. That's why we call it equilibrium in a closed system. So if you look at this, you'll find out that you have first system, second system, third system. You have the pentane here, you have pentanol, and then you have pentanone. Here you find out that here, because of the kind of functional group which is here, a lot of atoms are being produced. So the atoms, these atoms, because there are many, they exert more pressure than this one, which produce fewer atoms, and this one pressure compared to this one because of the number of atoms. So these atoms, they exert a force on this. So, and then the rate at which this one goes up and then this one goes down. So the pressure exerted when that situation exists is what you call the vapor pressure. Vapor pressure. So let's look at the factors which are the factors that affect the boiling point, the melting point, and the vapor pressure. The first one is strength of the intermolecular forces. This one can be determined by the functional group. So here you will find out that you have a different function group, but you have examples. For example, you have the alkanes, the haloalkanes, or and then the alcohols. So it means that you find out that this one is a little bit weaker compared to this, and this one is a little bit weaker compared to this because of the properties each of this compound has. You find out that this one has London forces or temporary London forces, temporary dipole forces, permanent dipole forces, and then this one has weak hydrogen bonds. So the weak hydrogen bonds are stronger than the permanent dipole forces, and the permanent dipole forces are stronger than the weak, the temporary dipole forces. So you'll find out that this kind of functional group, the functional group it has, the type of functional group will affect the boiling point, melting point, and the vapor pressure. Number two is the number of the functional group. How many are they? If you look at this, you'll find out that here I have one functional group, two functional groups, three functional groups of the same kind. So if it has one, it means that the boiling point is going to be low. If it has two, the boiling point is going to be a little bit higher than the one which has one. And then if it has three, you'll find out that the boiling point is going to be higher compared to these two. So the number of functional group, as long as other factors are kept constant. So the length, another one is the chain length or the mass. As long as the molecules are of the same, they have the same functional group, all of them they are straight, other factors are kept constant, then it means that each atom you add, the carbon atom, it increases the mass, and the higher the mass, the higher or the stronger the intermolecular forces of attraction. It means that this one will have a higher intermolecular forces of attraction compared to this one will have more compared to this. If it has a higher intermolecular forces of attraction, it means that its boiling point and melting point is going to be high, and the vapor pressure is going to be down, because they work in opposite way. We'll see that in detail. And then lastly is the branched chain. This one will depend whether it is straight chain or it's branched. Why? The straight chain has a higher boiling point and melting point and a low vapor pressure compared to branched and compared to the one which is more branched. Why? Because this one exposes a high contact surface, higher than here. So we have more intermolecular forces of attraction because of the high contact surface. It's easy to arrange these ones than arranging these ones, and then it's easy to arrange these ones than arranging these ones. So the particles are too far, so they require less heat to break them, or require less energy to break them, so that they can turn into substance which is boiling, or it can turn into substance which is melting. And then it means that if the boiling point and the melting points are low, then the vapor pressure will be high. Let's look at these ones in details. The strength of the intermolecular forces, that is the type of the functional group. We see that the melting point and boiling point increases, but the vapor pressure will reduce. So the intermolecular forces, as it increases, the boiling point and melting point will increase. So if you look at this, because we're looking at the type of the functional group, each functional group has its own intermolecular forces of attraction it exerts. So if you look at this, these are just simple molecules which only have the induced or the temporary dipole forces. This one, they have the permanent ones because they have the oxygen or they have the halogens, which are a little bit more electronegative. So they pull the bonding pair of electron towards themselves. So they create what called a permanent dipole. So they create different charges on the molecule. And then these ones, because they have the hydrogen attached to oxygen, then it forms what called the weak hydrogen bonds. Weak hydrogen bonds are more stronger than the permanent dipole forces, and then the permanent dipole forces are more stronger than the induced ones. So as you go towards this side, then it means that the intermolecular forces of attraction is becoming more stronger. So increase the intermolecular forces of attraction, it increases the boiling point and the melting point, and lowers the vapor pressure. So we have seen that London forces or induced forces are less powerful than dipole forces, which are permanent, and then are less stronger than the hydrogen bonds. Then here is an example. You have the same number of carbon atoms. What is changing is the functional group, because the functional group is changing, and as you continue, you have more weak hydrogen bonds. It changes from simple intermolecular force of attraction to more stronger. So it means that the melting point is going to increase, and also the boiling point is also going to increase. It may not matter the mass, as long as it is not of the same kind. Functional group will have a more say than the mass it has, because if you look at this, the mass is 30, and then this one, the mass, if you look at this, the mass is 64.5, and then this one is 48, but the 48 has a higher boiling point than the 6 because of the difference in the functional group. So this functional group is more stronger than this, so it creates the boiling point to be increasing, and then this one is also increasing while the vapor pressure is reducing. And then let's go to number 2. Number 2 is saying the number of the functional group, the number of the functional group of the same kind, of the same type. So here we have the same 1 2 3 1 2 3. So all of them, it has 3 carbon atoms, but what is changing is the number of functional group. The functional group is the same, it's alcohol alcohol alcohol, but here 2 3. If you look at the mass is in these molecules will be increasing a bit because of the number of atoms which are being added of the same functional group. So that creates more intermolecular forces, and also it creates more weak hydrogen bonds, or more hydrogen bonds. The hydrogen bond becomes more in here than this, and more in here than this. That's why you see here the boiling point is low, here is a little bit higher, and then this one is very high, and then because of increase in one functional group, so it almost doubles the boiling point, and then the vapor pressure also reduces. And then here, because we have tripled the functional group from the beginning, so it almost triples the boiling point, and then the vapor pressure has to reduce drastically. So that's why you're saying that the melting point and boiling point increases with increase of the same functional group, and the vapor pressure obviously you have to decrease, because we say that these two, they work in opposite way. Then number 3 is the relationship between the melting point, boiling point, and the vapor pressure of this is for a chain. So we are going to say that if you have the same kind of chain, is straight chain, but what is changing is the number of carbon atoms. Here if you have 1 2 3 4, here you have 5, here you have 6. So what is happening? What is happening is the mass is increasing because you are adding more carbon atoms. Number 2, the temperature, the melting point and boiling point, they are increasing because the mass is increasing. Therefore, increasing mass of the molecules is the melting and the boiling point, and then the vapor pressure of those molecules must reduce because of the weak intermolecular forces of attraction, which are increasing as the molecule increases the mass or the number of carbon atoms. Then we are seeing here the size of contact area increases across which the intermolecular forces work. So as you increase, you are increasing the surface area, so that the contact area is increased. If the contact area is increased, it means that you are creating more intermolecular forces of attraction, which require more energy to break those intermolecular forces of attraction, so that it can turn into a boiling substance or a melting substance. Hence the melting and boiling point increase while the vapor pressure has to decrease. Here you have a small chart or table trying to explain methane, ethane, propane, butane. So if you look at this, you find out that the melting point is increasing as you increase the number of carbon atoms. Number of carbon atoms are increasing. The boiling point is also increasing as you increase, but the vapor pressure is reducing until you reach a solid, because the solid, find out that it may not have, in this case, may not have vapor. Why? Because it is not, they don't sublime. So if they don't sublime, obviously you won't have pressure, vapor pressure for that kind. But if it sublimes like iodine, then automatically it will have vapor. So it will also have what you call the vapor pressure. So increase in the number of carbon atom increases the boiling point and melting point, or reduces the vapor pressure. Then the relationship between the melting point and boiling point, boiling point, and vapor pressure with the branched chain. So if you look at this one is a straight chain, and while this one is a branched chain. So this one has a larger contact area with the stronger forces of attraction. So it means that the area at which it exposes with one atom with the other is much greater, while here you only find out that the space is too small. The force of attraction will be weak. So that's why here you'll find out that it has a higher boiling point and melting point, while this one has a low boiling and melting point. But vapor pressure here is high and vapor pressure here is low. So here is an example. You find out that it's a straight chain, branch chain, more branched chain. If you look at it, you'll find out that they have the same mass. It means that the number of atoms are the same, but what is different is the arrangement of these atoms. Here, straight, branched, more branched. You find out that the boiling point is 36, 26, and then it's 9. So the more it's branched, the less the boiling point and the less the melting point. Why? Because of the contact area. The contact area of one molecule with another is too small compared to this, and then this one is a little bit higher. Therefore, this one requires more heat or more energy to break the intermolecular forces of attraction compared to this. Hence, the boiling point of this is higher than the boiling point of that. So thus we're saying that the more branches, the size of contact area over which the intermolecular forces work decrease. So the more it's branched, the size is decreasing, and then decreasing the strength of London forces or induced dipole forces. The boiling point decreases the more branches occur, and then the vapor pressure will increase as the boiling point and melting point increases. So the more branch you have, the higher the vapor pressure and the lower the melting and the boiling point. So basically that's it. And then let's look at some questions. You have a question. You have different molecules. What is different in these molecules? This one, they have the same number of carbon atom, but the arrangement of carbons are different. So when they give you a question, all the three factors must be kept constant. Only one must change. So you have to identify which factor is changing, and then be able to answer questions regarding to or based on that. Which compound A or C has the lowest boiling point? Give a reason for your answer. The one which has the lowest boiling point, it means that it must be more branched because it requires less heat to break the intermolecular forces of attraction. The contact area is small. So if you look at this one, it's more branched compared to this, and then this one is straight. So it requires, this one has a big contact force, a big contact area. So more intermolecular forces of attraction, more boiling point and more melting point, while it has low. So the answer is going to be lowest boiling point is going to be C. And then they're saying give the reason because of it's more branched, therefore the intermolecular forces of attraction is are weak, so it requires less heat or energy to break the forces between the molecules. Then which of A, B or C has the lowest vapor pressure at the same temperature? The lowest vapor pressure. The higher the vapor pressure, the lower the boiling point, and then the lower the melting point. So if the melting point is high, the vapor pressure must be low. So we have to look for the one which has the highest boiling point, and then if it is straight, has more melting and boiling points, and if it's branched, has less boiling and melting point. So in this case, it will have a higher boiling point and melting point, and then low vapor pressure. Remember those three, the two of them, they work together, and then the other one, they work in opposite way. So the answer is going to be A, because it is what it is straight, so it has more intermolecular forces of attraction which require more energy to break it, so that it can release it can make the atoms free, so that it can create the pressure. Is the boiling point of compound A higher than that of pentanol? Is A? Where is A? Pentanol forms in intermolecular. It doesn't have weak hydrogen bonds because it doesn't have oxygen to hydrogen. Therefore, it means that it has permanent dipole forces, and then this one has weak hydrogen bonds. Therefore, it means that this one is going to have a higher boiling point compared to this. And then another question is you have to study it. You have P, Q, R and S, all this, and then they're saying that the vapor pressure are measured in millimeters of mercury. Atmospheric pressure is 700 millimeters of mercury. So you have these different graphs with the vapor pressure here and then the boiling point here. what do they want from this? They're saying, give a reason why alkanes are said to be saturated. Saturated compounds are compounds with a single bond throughout between the carbon atoms. And then unsaturated are compounds which have double bond somewhere between the carbon atoms. So in this case, because alkanes have single bond throughout, therefore it is a saturated compound. And then define vapor pressure. We have defined it. Use the information in the graph above to answer the question. And they are saying what is the effect of increasing temperature on vapor pressure? So we saw that increasing the temperature reduces the vapor pressure. Yes, the higher the vapor pressure, the lower the temperature. The higher the temperature, the lower the vapor pressure. So increasing temperature, will it increase the vapor pressure? If you increase the temperature, will the vapor pressure increase? In this case, it means that you are heating at 100 degrees C, so you increase it to 200 degrees C. So that principle I've talked about does not apply in this case. So if you're heating at 100 and then you increase to 200, what will happen to the vapor pressure? So it means that you are making the bonds to be broken between the molecules, and then the atoms are being freed in the space, and then creates more vapor pressure. So it means that it will increase. So increasing the temperature of a substance will increase the vapor pressure. So it means that when you're doing an experiment, the temperature must be kept constant. Which compound has the boiling point of approximately 60 degrees C, and give a reason for your answer. So if you look at this is the temperature at which the substances boil. So you look at this one, it boils around 100, this one is around 80, and then you find out that you have this one which boils around 80, 68, around there, or 70. So it will be Q. They are saying give a reason for your answer. Yes, because its vapor pressure will equalize that of the atmosphere by this point. So it boils around that temperature. Which compound has the longest chain length? Explain your answer. The longer the chain, the higher the boiling point, and the higher the melting point, and the lower the vapor pressure. If the chain is long, the vapor pressure must be low, and the boiling point and melting point must be high. So I'll come here and then check which one has the highest boiling point by looking at the temperature, and then which one has the lowest vapor pressure, which one has the highest boiling point, which one has the longest. Yes, so it means that it must have the highest boiling point. So if you come here, you'll find out that yes, you have this temperature is 100, and then what happens? 100, but the vapor is very low. So the higher the vapor pressure, the lower the boiling point. But this one, and then the higher the boiling point, the lower the vapor pressure. So we saw that this one, the longest chain, it must have a high boiling point and a low vapor pressure. So this one has 100, and then the vapor pressure is around 350. This one has 100, the vapor pressure is a little bit higher, and then this one, the vapor is high but the temperature is low. So it means that this one is going to qualify. Because why? Because the vapor pressure is low and the temperature is high. Therefore I will go to this. So the answer is going to be yes. Thank you very much for watching. Don't forget to subscribe for the new clips. We are going to be looking at fertilizers. Go and subscribe and hit the bell, the small bell there, so that you can get notification when new videos have been uploaded. Thank you very much.
Welcome back to our class. Today we are going to be looking at physical sciences, paper 2, final exam 2023 MJ. All right, there are so many students who have just said that this paper was difficult, but we need to find out how difficult it was. Unfortunately, I may not have enough time to finish this because I'm not that well. But I'll try to push until I see that I've covered. But let me see if I can cover the first 5 questions. Then after that, I'll do another live when we are discussing this the last 4 questions. This is 2023 Physical Science Paper 2. That is what you call chemistry. Download the paper on Thundereduc or from Thundereduc. Let's go straight to the first question. The first question is talking about multiple questions, of which in most cases, multiple questions, they are supposed to be answered properly. Why am I saying that? Is because multiple questions are questions which you cannot leave when they're unanswered. So make sure that before you do anything, you have to get all the marks for multiple questions. Emo girl, I see you. Molly, I see you. Share the video so that people don't miss out. All right, let's go. For which one of the following molecular formulae are chain isomer? When you talk about a chain isomer, don't forget that we have 3 different types of isomers. So now, when you talk about chain isomer, we are looking at something which can change in the arrangement of the skeleton. For example, that compound must have more than 3 carbon atoms, because if it is 2, for example, 1, 2, there is no way how you're going to change it. If there are 3, 1, 2, 3, if you say that, okay, this one, we bring it here, and you form 1, 2, 3, still this is the same thing. Yes. So it must have more than, to form a chain isomer, you must have more than 3 carbon atoms, meaning that more than, starting from 4. So this one has 3, off, right answer. So this one becomes 2 marks there. Why am I saying that? Because if there are 4, 1, 2, 3, 4, that is the first isomer. So I can change it and I say 1, 2, 3, and then I put a carbon atom here. So it has changed the arrangement of carbon atoms on the straight chain. Hence, it becomes chain isomer. Question 1.2. I think I'm clear there. Question 1.2. Which one of the following compounds has the lowest vapor pressure? Look at this word, lowest vapor pressure. What does it mean? It means that when you talk about lowest vapor pressure, it means that highest boiling point. Don't forget that boiling point is inversely proportional to vapor pressure. So meaning that this boiling point, if it is too high, the vapor pressure is going to be low. So it means that we are supposed to look at these compounds, which one has the highest boiling point, so that I can get the lowest vapor pressure. But which factors cause these species to be having the lowest vapor pressure or the highest boiling point? You have to look at the forces of the intermolecular forces of attraction, London force, dipole, and then hydrogen bond. So you have to look at those ones. So, I can't find the 2023 paper on the website. Okay, we will send you a link concerning about that. Ne? Yes. All right. So we are saying that if you look at this, it means that 1, 2, 3, 4 carbon atoms. 4 carbon atoms these are 3 carbon atoms, these are 3 carbon atoms, these are 2 carbon atoms, but they have a unique character. This, however much these are 4, they only have London force because there is no hydrogen, there is no oxygen anywhere. So the oxygen is going to make it to have a higher boiling point or higher intermolecular forces of attraction. So it means that this is going to have London force from this side and the hydrogen bond from that side. This one is going to have hydrogen bond from that side. It's going to have dipole, hydrogen, dipole, and the London force from that side. This one is going to have dipole, and London force. So it means that this one has a high number of intermolecular forces of attraction. Hence, it's going to have the highest boiling point. If it has the highest boiling point, it means that it's going to form low vapor pressure. Hence, the answer becomes D. So you get 2 marks there. 1.3. Is saying that just a moment. 1.3 is saying that the type of organic compound formed when haloalkane is heated in presence of concentrated solution of the base of base is an, what is it? Now, as long as there is no acid or there is no water in it, then the type of if it is haloalkane, the type of reaction which is going to take place is going to be elimination. What are you eliminating? You are eliminating this halogen. So the moment you eliminate halogen, you form a double bond. Hence, this one is going to be the most correct answer. So you get your 2 marks there. Then we are saying that excess hydrochloric acid, yes, look at this word, the word excess. It means that this is not going to be a limiting factor. The word excess is enough to take you off. But they're saying concentrated excess hydrochloric acid of concentration 0.1 molar or moles per decimeter cubed react with 2 grams of magnesium under different conditions. Which one of the following combinations of conditions will produce the largest volume? So they are not talking about the fastest rate. They're talking about the largest volume. However, they're including this in the first minute, meaning that the fastest reaction. So because of that saying that in this specific period of time, the first one, then automatically they are looking at the fastest reaction. So you look at the factors which factor affect the rate of reaction. In this case, we have temperature, and then we have how much the compound is divided. So granules are bigger than the powder. If they are powdered, it means that the chemical can reach on them more than here. An example, when you are eating, you break down the food so that the enzymes can reach that food more than when you have not chewed them. So if you chew the food, you are breaking it into smaller particles so that the reaction for you to become full is faster. Anyway, let's go. So they are saying that now anything which has powder is going to be faster. So this and this. So this is out. So always use elimination method to answer questions concerning about this. Elimination methods are the best. So now I know that this and this can't be the answer. So now I will look for which one has the highest temperature. So this is out. I get the correct answer. So C becomes the most correct answer. Let's go to 1.5. The diagram for chemical reaction is shown below. Okay, we are seeing the diagram. What are they saying? Which one of the following combination is correct for forward reaction? So now you have to understand here the concept that they are looking for forward reaction. If it is a forward reaction, and then this is the forward reaction, the one which goes there. They are not saying reverse reaction. So then we look at this. They're saying change in enthalpy change. Enthalpy change is final heat, yes, minus initial heat. All right, final is here, is X, and then this is initial. So it means that X minus Y. So anything which doesn't have X minus Y is out. Let's go. They are saying X minus Y, X minus Y, Y minus X, out. Y minus X, out. You see? So you're saying X minus Y. So now they're saying that, okay, so it means that either it is this or is this. Let's go to activation energy. Activation energy, when you go back here, activation energy is the energy from the beginning of the reactant to the highest part of the graph. So it means that here I'm gonna have from there to there. So that is going to be our activation energy. So if that is our activation energy, so it means that our activation energy is going to be, just a moment, technology. Technology is back now. Yes. They're saying that activation energy, they are saying that is from, is gonna be Z minus Y. Yes, so that's going to be activation energy, Z minus Y. So we come here, we look for Z minus Y. So if we don't see Z minus Y, is out. So this is out, this is Z minus Y, this is out. But don't forget, this one is already out, and this one was already correct, but now it's out because of this. So it means that now the correct answer is this. I only have now one because now this one was already out. So I only have C as the correct answer. Let's confirm and see if this is correct. They're saying that the potential energy the activated complex is having is this, from 0 to this, because they're saying potential energy at this point. So it means that answer is Z. So the most correct answer becomes C. I know that when the paper is not, you're not the one writing the paper looks to be easier. And if sometimes if someone is discussing it, you say, this paper was easy. But when you sit on that paper, you feel it hot. So don't just watch videos and think that the papers are always easy. Try to practice them. You will see that they're not easy, and you will need to practice as many questions as possible. Let's go to the next question. Consider the following reaction that reaches equilibrium in the beaker. You know, students are always having problems with reading these. Okay. The chromate is reacting with the hydrogen ion to form dichromate plus water. Few drops of concentrated sodium hydroxide are now added to the beaker. Which one of the following combinations correctly identifies the disturbance on the system, and the system responds to disturbance? Okay, here we come here and we look at this. What are we looking at? what do you add? You added the sodium hydroxide. When sodium hydroxide is ionized, it's going to form sodium ion plus hydroxyl ion. Yes. All right. So when you add the sodium ions or hydroxyl ions, yes, this is going to react with that to form H2O. Yes. When this reacts with that, automatically, what is going to happen is you are taking away this from the system. So automatically the system is supposed to react in such a way that it brings back what you have taken out. When you come and take my money, I have to fight and I see that my money is back. So I have to go to that direction of bringing back the situation to normal. In life science, we call it negative feedback mechanism. Here, we call it reinstates so that equilibrium is established. You understand? Yes. So if you're doing life science, we call it negative feedback mechanism. So the equilibrium is what we call homeostasis in terms of the system of the human. So in terms of the system of chemicals, we call it equilibrium. So I'm just bringing that if you're doing life science so that you understand better. Yes, you understand what? Better. All right. So it means that the reaction is going to be reversed. And the amount of this is going to reduce because it's going to react with this to form this. So we come here. Reversible reaction. This is out. This is out because we said reversible reaction is going to be favored. But the hydrogen ions is going to reduce. Let's see, this one decreases. Since out, then this one becomes the most correct answer. So the answer is going to be B, and you get your 2 marks. Let's go to question 1.7. According to Lorry-Brest theory, the conjugate base is formed when? Is formed when? Conjugate base is formed when? Okay, the proton is added to the acid. A proton can't be added to the acid because it's already acid. Don't forget that acid is a proton donor based on him, but based on this person is a proton donor, so it can't be added. So that is out. Then they're saying that electron is added to the acid. Electron is added to the acid. No. Don't forget that an acid is a substance which can release, which give out electrons, and that is based on Arrhenius. So out, because they are saying based on this. And then they're saying is added, so out. Proton is removed. Proton donor is removed, meaning that it donates. So the answer could be this. Electron is removed. This is not based on Lorry. This is based on Arrhenius. So the correct answer becomes that. Hence, yeah, I think the paper was not that bad in terms of the objectives, because we don't know yet what's going to happen afterwards on the other questions. Consider the statement below regarding to the alkaline substance. Alkaline substance, yes, react with the alkaline. Don't forget that the pH is above 7. So react with the acid to form definitely base. This base, when react with the an acid, you form a neutral solution. Yes. However, the solution can be a little bit of yes. The end point could be a little bit up, down, depending on which is a strong base or strong acid or weak base, whatever. All right. We will explain that when you go to acids and bases. So we are saying that it turns litmus paper blue, alkaline, cool. Forms salt when it reacts with an acid. Yes, you have that principle that base plus acid, you form salt plus water. Yes. So meaning that it forms a salt when it reacts with the acid. Cool. So it is also correct. So we consider the solution of sodium chloride brine. Concentrated solution. Wait, they're saying concentrated solution. So if they're talking about a concentrated solution, is different from molten molten sodium chloride. If they are talking about solution, it means that it has some water there. It means that the water molecules are going to be a little bit high compared to, yes, okay, let's go. Undergoes electrolysis. Which one of the following combination correctly shows the product formed at each electrode? Don't forget that this is the electrolysis electrochemical cell, meaning that this one becomes negative while this one becomes positive. So the positively charged ions, they will go to this, and the negatively charged ions will go here. So let's see. Sodium, yes, but will not be discharged. Why? Because you have sodium there and you have the hydrogen there. So sodium won't be discharged, this will be discharged. Cool. So this one goes out. This side, okay, so this one is out. Hydrogen, yes, hydrogen is discharged, yes, is correct. But let's look at this side. This is the anode. Sorry, anode, which is a positive. Positive, you will have, yes, you will have the chloride, and you will have that. So, but now this one is going to be released easier than this. Yes. So it means that this one is out. So now even this one is out. Oh my God. All right. Let's see. Chlorine will be released. We have said that this one will go to the positive. So this is out. What's the correct answer? We have got it. Say that chloride is gonna be there, and then it's gonna release the electron and then combine with another one, then form chlorine gas. And then here the water will split. When the water splits, what happens? You're gonna form hydrogen ion plus OH. Yes, here. And then this one is gonna be discharged as hydrogen gas. So meaning that this reaction is gonna take place here. And then the most correct answer becomes D. Yeah, that is the first question. How many marks? 20 marks. Mahala. 20 marks? Mahala. Sir, are you going to do business paper 1? The business teacher will do it. Yes, because I'm purely science teacher. Yes, but the business gift Masana. Yes, the teacher for business is gonna do it. Yes, is gonna do it immediately after, hopefully in most cases a day after you have written, or immediately after you have written. Yeah, so but he's gonna do the business paper. Anyway, let's go. Study the table below and answer the question that follows. Yes, you have this structure. This structure is showing you, okay, 1, 2, 3, 4. Okay, this is a hydrocarbon. Let's go to the questions and define the term unsaturated. Unsaturated, it means that you don't have a double bond. No. Yes, you don't have a double bond between carbon atoms, between two carbon atoms. You don't have a triple bond. That it means that it is saturated. Yes, it means that it is saturated. So if it is saturated, it means that I have 1, 2, 3, for example. That is saturated. But if it's unsaturated, you have 1. I have a double bond somewhere, or I have a triple bond somewhere. So what is, define the term saturated hydrocarbon? Is a hydrocarbon a compound which is made up of hydrogen and carbon only, with double or triple bond between the carbon atom, or is a compound which has a double or a triple bond between two carbon atoms. Simple. We go to write down letters that represent they're saying that letters that represent unsaturated compound. If you come here, you look at unsaturated compound, desaturated compound, unsaturated. This one is saturated because all single bond throughout, single bond throughout, single bond throughout. This one is also single bond. What about this one now? This, and this. There is a double bond here. Look at this. So if we say 1, yes, 2, 3, 4, 5. 1, 2, 3, 4. They compressed it here. But now if you look at this one is saying CH and then CH2. I'm magnifying it so that you can see. This carbon has only one hydrogen, and this one has 2 carbon. It's supposed to have 3 if it has a single bond throughout. So it means that it's going to be 1, 2. So basically it's going to be C, 1 carbon, and a double bond. Yes, another hydrogen and another hydrogen, and then here you form this species. You see? So it means that that is the species you're gonna form, of which is gonna be 1, 2, 3, 4. Correct. 1, 2, 3, 4. Correct. You see, there is a double bond there. So D becomes the structure which you're supposed to talk about here. IPAC name of compound A. What is compound A now? Compound A here is 1. So now you have to find the longest chain. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay. If I make this the longest chain, this one. Yeah. If I make that one the longest chain, what's going to happen? So it means that this and this are going to be side chains. So let's count 1, 2, 3, 4, 5, 6. So it's going to be hexane. But now I have hexane is the first branch is on carbon atom number 1. The second branch is on carbon atom number 1, 2, 3. Is on carbon atom number 2. First branch is on carbon atom number 2 because 1, 2. Yes, this branch on carbon atom number 2. 1, 2, 3, 4. Carbon atom number 4. If I count from this side, 1, 2, 3, no. So I have to go with the 2. So it's gonna be 2. It's a methyl, and also this is a methyl. Therefore, I'm gonna say 2, 4 dimethyl hexane. Is it correct? You're gonna say yes. No, it's not yet correct. Why? 2 is a figure and a figure by a comma, but a figure and a word is by dash. So 2, 4 dash dimethyl hexane. Now it's correct. So that is how you're supposed to write it. IPAC name of compound A, we are done with that. IPAC name of position isomer of B. Where's B now? Okay, this is an alcohol. 1, 2, 3. Yes. So when you talk about position isomer, you see now, yeah, it can't be a structural isomer. It can only be positional isomer. It can't be structural isomer. Why? Because it's not more than 3 carbon atoms. It only has 3 carbon atoms. So if it's 1, 2, 3, and then alcohol here, so it means that what you're gonna do is just to change this primary alcohol into a secondary alcohol, then you have formed an isomer. How do you do that? Change this, bring it there. Bring this hydrogen this side. 1, 2, 3. Bring alcohol here, and then the rest of the hydrogen. The structure is done. Simple. Then we go to the next question. IPAC name of IPAC name of compound D. Where is compound D? Is this one which we talked about. So is 3 is 1 plus 4, then a 2. So I'm gonna have, it said is 1 CH3, and then these ones are 4 of them. 1, 2, 3, 4, and then a double bond there. So it's like that. If you look at it here, let me just clear here so that you understand it. 4 of them plus this, that's 5, 6, 7. So meaning that C is gonna be hep 10, but it has a double bond, so it is gonna be in. So hept in. But what's the position of this double bond is on carbon atom number 1, so it's gonna be hept 1 in. Simple. Hept 1 in. So you get the marks. How many marks are there? 2 marks. Mahala. Let's go to question. Question. Which balanced equation of technology. So all right, so they're saying that identify the balanced equation of the molecular formula for complete combustion of A. How do I go about that? So you come here, let's write here in this space, saying that the balanced equation of complete combustion of A. Let's go to combustion of A. Where is A? Oh, is this one. So let me clear it so that I can count the hydrogen properly. Yes. Okay, how many carbon atoms are there? We say that is 1, is 2, is 3, is 4, is 5, is 6, 7, 8. So when I say here, carbon is 8. But this is an alkane. Don't forget that when you're saying that it's an alkane, it has this formula. You can count the number of hydrogen direct, but if you don't want, you can still use this. Since N is 8, automatically it's going to be 8 times 2 plus 2. This is 10 plus 2, which is 12. So carbon is going to be 8. Hydrogen is going to be 12. Yes. But they're saying combustion, which means oxygen. Then you react with this. Always when you talk about hydrocarbon burning, we only produce one product. That is carbon dioxide plus H2O. So this is a liquid, this is a gas, this is a gas, this is a gas. This can also be a gaseous form because it is hot. It's hot. So you won't be able to see water there. You just have to see steam. Yeah, steaming. Yeah, steaming. All right. The most complicated thing here is balancing the equation. And this has been a problem for students from grade when they get to know what is called chemistry until they finish their university. Yeah. Anyway, let's try to balance. Carbon, how many carbons do I have? 8. This side I have 1. So I'm gonna have put 8 here. Cool. If I put 8 there, what's next? So if I put 8 here, hydrogen 12. Hydrogen here I have 12. Here I have 6. I have 12. I have 2. Put 6. So it's gonna be 12. Now the most complicated answer here, the most complicated problem here is the oxygen. The moment oxygen is not balanced, everything you have to do them again. Okay, 6 plus 8. 6 plus 8. Wait, something is not right here. Something is not right here. You know why? Yes, I'm just seeing it here. That I didn't add here. I did add. I said this is 10 is 10 plus 2, which is 12. It's not supposed to be 12. 12. plus this 8. Is it? Yes. Is 8. 8, it's 16, eh? 16. It's not 10. This is not addition. It's multiplication. Is 16 plus 2, which makes it 18. So this is 18, not 8. All right. Now we have to balance. You have to rebalance here. So it means that you have 18 here. Here carbon. If I put here 18, it's too much, ne? I have carbon. What's happening now? It's not carbon. This is 8. Hydrogen is down, which is 18. Hydrogen is 18. Eh? Ask is, all right, hydrogen is 18. Carbon is 8, cool. Hydrogen is 18. So what am I doing here? What am I putting here? If I put 9 here, the moment you bring 9 here, this oxygen won't be able to balance. Anyway, let's continue and we see. So now you have oxygen here is 9 plus 8. How much is that? 9. But this 8 is times 2. So it is 16 plus 9, which gives me 25. This side I have how much? See, if I put a 12 here, it's going to be 24. 1 is short. So what am I supposed to do? Let me increase. Let me put a 2 here. Yes. So I have 16 carbon. And then now I have increased the hydrogen. So hydrogen is going to become 18 times 2, which gives me 36. Okay. Now, if I have 36 carbon, hydrogen, how much do I have this side? So what am I going to do? I'm going to increase this to 18. So that is 36. So if I have 36 here, I'm going to have, yes, 18 oxygen here. Now, how much I'm supposed to put here? Because now this carbon is 16 now. You see, it's 16, but here I only have 8. So I have to increase this to 16. Yes, that's what you call balancing. 16. Yes. Let's see. 16. Yes, 16. So now it means that here I have 18 oxygen. 16 times 2 is 32. 32, yes, plus this 18. So is 18. This is 0. This is 5. So it gives me 50. So now, if that is 50, then how do I make this oxygen 50? So I'm going to make this oxygen 50 by putting a 25. I think it's balanced. Ne? Yeah, ne? Yeah. So now let's go back and see how this is balanced. I know that balancing is a problem to everybody. Yes, everybody. Yeah, who is writing a paper. Why? Because you are rushing. So that is 2. We say that is 2. So we say that this is 25. Yes, we say this is 25. 25. And then we say this is 16. And then we say this is, let me remove this one. This is 18. Yes. Yes, I think it's balanced. This is 16. And then this is 50. And then this carbon, this is 36. Hydrogen is 36. So I must have the same order. Carbon is 16, you see. 16. So this one is correct. And then oxygen, let me go to hydrogen first. Hydrogen is 36, you see. 18 times 2 is 36. 36, so correct. I have to look for 50. If I don't get 50, then I have to change until I get them balanced. Okay, 16. Yes, this is 16 times 2 is 32 plus 18 here. Yeah, it gives me 50. So it means that it's balanced. So you see, I always advise my students that when you write these equations, make sure that you write. If you see that the balancing is a problem, first leave it, continue, and then you come back and see if you can balance it. Ne? See if you can do what? You can balance it. If you see that you can't balance it, ne? Then balance when you are done answering other questions, or otherwise you're going to spend a lot of time just for 1 mark, and then you could have got other marks somewhere else. Yes, so basically that's how you supposed to write that equation. Yeah, I think now I see that. Yeah, someone said that this paper was difficult. Maybe found that question and then killed him. All right, let's go. Formula. This represent two compounds that are functional isomer of each other. All right, what is a functional isomer? A functional isomer is a molecule which has the same molecular formula but different. Remember, functional. What is different is the functional. Structure, what is different is the structure. Ne? You see? Position, what is different? Position isomer, what is different is the position of the functional group. So here, the functional isomer, what is different is the functional group. Molecules with the same molecular formula but different functional group. Example, we can talk about aldehyde and ketones, esters and carboxylic acids, alcohols and ethers, but we don't teach ethers here. Ne? Yes, so all those are functional isomers. So they're saying write down the structure formula of each of the functional isomers. Hey, now from where? Oh, here. So they're saying that C480, C4H80. So functional isomer 1, 2, 3, 4. So I put hydrogens. Let me make sure that each bond has four bonds, each carbon atom. Hydrogen, hydrogen, hydrogen. That is 3. Ne? So 3 gone. Hydrogen, hydrogen, so plus 2, so that is 5. Hydrogen, hydrogen, plus 2, that is 7, meaning that I am remaining with 1. Oh, so if I'm remaining with 1, I put oxygen, I put the hydrogen there, so that I have 8 hydrogens. So it means that this is an aldehyde. So it means that if I'm going to write the functional isomer, I'm just going to write the keton. Simple. Just change this, put it there. I've got the marks. 1, 2, 3, 4. Put it there. Either here or here is the same thing. When you are doing the nomenclature or naming, it's going to be the same thing. Don't forget that these things you're supposed to put hydrogens, but for the case of time, so that's why I just put dash, dash, dash. Ne? Yes. So that is it. I get it there. And then the next question. What is the next question? The next question, they are saying that is a calculation. 2 grams of, just a moment, 2 grams of sample. Yes. Yes. Switch. Good. All right. 2 grams of E contains 1.09 grams of carbon and 0.8 grams of hydrogen. The molecular mass of the compound E is 88 grams. Ne? Okay, determine the molecular formula of compound E by means of calculation. Okay, so here what you need to do is to find the first structure. And to find the first structure, you have to draw which elements do we have here. We have carbon, hydrogen, and oxygen. Because they're saying the molecular formula of this compound E, and if you look at this compound E, it looks like this. X, C, H, O. So it means that I have C, X, H, Y, or Z. Meaning that these are numbers. These are numbers. So what do you do is to find out. So these are the elements I have. I need to know the mass they have. Mass, if you go here, they say that, what did they say about carbon? they said that carbon is 1.09, and then hydrogen is 0.18, if I'm not mistaken, 0.18. And then what about oxygen? But they said a sample of E contains 2 grams. So it means that if I add this and this, when I subtract, I must get the balance of E. So this plus this, you're gonna get 1.7. Yes, you must get 1. Let me just get a calculator. Calculator is here. Let me add and then I see. So is 109 plus 0.18. Answer is 1.27. 1.27 minus 2 minus 1.27, the answer, so it's minus 2. Answer is 0.73. So it means that oxygen is 0.73. So what is the atomic mass of carbon? You find this in the periodic table. The atomic mass of carbon is gonna be 12. Hydrogen is 1 and oxygen is 16. Yeah, so that is the atomic mass of that. So if that is the atomic mass, so it means that I'm going to say I'm going to find out the number of moles. Number of moles is obtained by mass over atomic mass. So I'm going to say 1.09 divided by 12. Answer is 0.09. And then obviously this one's going to be 0.18 because they divide by 1. And then 0.73 divided by 16. Answer is going to be 0.046. Yes. So I divide by the simplest so that I can find the ratio. Ratio. So I'm going to divide by the simplest. Which one is the smallest? Is this one. So I'm going to say divide by the same answer. I'm going to get 1, meaning divide by 0.46, divided by 0.046, divided by 0.046. So I'm going to have 1 here. What about here? I'm going to say 0.18 divided by that answer. So it's going to be 0.39, approximately 4. And then what about here? 0.09 divided by 0.04. 46. Answer is 1.95. You can calculate and see, just in case I miscalculate. Okay, so it's gonna be the answer is going to be 2, approximately 2. So now that's not the answer. The answer is gonna be C is gonna be 2, H is gonna be 4, and O is gonna be 1. But they say that the molecular mass of the whole molecule is 88. So it means that I have to introduce here the number of moles and equate them to 88. So remember we said that hydrogen is 12, yes, times 2 plus 1 is carbon is 12, hydrogen is 1 times 4, and then oxygen is oxygen is 1 times 16. So when you add here is 14, is 4, yeah, this one is 16, so this one goes here 20, yeah, 20, 30, yeah, 44, meaning that 44, all this is n, so 44n is equal to 88. So divided by 44, divided by 44, 44 here, so n is equal to 2. That's not the answer. So the final answer is gonna be, therefore, remember n is equal to 2. So if I have C2H4O, and then we are saying that n and n is equal to 2, then automatically I'm gonna have this structure, which is C. This C is times 2, so it's gonna be 4. H is times 2, it's gonna be 8, and then oxygen is gonna be 1 times 2, which is that. So this is the answer they are looking for. So when they say determine the molecular formula of the compound E, so basically that is it. The question. Let's go to the next question. The next question is saying, if you have a question, yeah, let me know, let me know. Gift, if you have a question, let me know, yeah, so that I can smash it before I go to the next question. All right. Question 3. They're saying that learners investigated the boiling point of 4 organic compounds given below. Okay. You have the first compound is butanone. You need to first analyze this. The good thing is these ones, they have the same molecular mass. What about these ones? Sorry, they don't have the same, but this one is an alcohol, this is an alcohol, this is a carboxylic acid, this is a ketone. Now, okay, that's fine. Define the boiling point. Boiling point is the point at which the vapor pressure of that liquid is equal to the atmospheric pressure. So it's a point. Don't say that is when. Don't just say that boiling point is when. The boiling point of when is the point at which the vapor pressure of that liquid is equal to the atmospheric pressure. That's when the boiling. There is a difference between a boiling point and boiling. Ne? Yes. So if the question comes and is asking boiling, define boiling. If the question is asking boiling point, so make sure that you define boiling point. So the question is saying which compound butan 1-ol or 2-methyl propane will have the highest boiling point. Here you look at these two. When you're saying that butan 1-ol is this. This and this, these two are isomers. Ne? Yes, the isomers. And this one has a straight chain while this one has a branched chain. Based on the factors which affect the boiling point, melting point, vapor pressure, to find out that the one which is straight is going to have a higher boiling point and a low vapor pressure because of the stronger intermolecular forces of attraction, as long as the mass is the same. So this one is going to have a higher intermolecular forces of attraction, which will require more heat to be broken down, hence a higher boiling point. Why? Because the molecules are packed. Therefore, there is strong intermolecular forces of attraction compared to the one which is branched. Hence, butan 1-ol is going to have a higher boiling point than 2-methyl propane 1-ol. Let's go to question. The next question. P, Q, R, and S below were obtained from results of investigation. X represents specific temperature. Okay. X represents specific temperature. They're saying that the first question, which physical property is represented by temperature X? That's boiling. Because they're talking about boiling, heating, boiling. So now, they're asking you, which graph P, Q, R, and S represents butanone, propanoic acid, 2-methyl propane 1. So here, you have to know which one has the highest, the strongest intermolecular forces of attraction. If you look at this one will have London force and dipole. This one will have London force and hydrogen bond. This one is going to have London force, hydrogen bond, and dipole. This one is going to have London force and hydrogen. But this one is a branched, but this one is straight. So this one is going to be number 1 in the temperature, highest, followed by, don't forget that hydrogen bond is stronger than London force. So this one than London force, and also stronger than dipole. So the butan 1-ol is going to be number 2 in the temperature, and then it's going to be 3, and then it's going to be 4. So let's go and find out. Let's go and find out which P, Q, R, and S butanone. Okay. is butanon. Butanon is going to be number 4. So the one which has the lowest boiling point. So it's going to be S. So the answer is going to be S. Propanoic acid has the highest. It must be number 1. Highest boiling point. Highest is P. So it's going to be P. And then 2-methylpropan-1-ol. 2-methylpropan-1-ol is going to be 3, number 3, based on this. So it's going to be 1, 2, 3. It's going to be Q. So yeah, that's it. The next question they're asking, give a reason for your answer for this one. For P, why propanoic acid is having a highest boiling point? We say that it has the strongest intermolecular forces of attraction. That is the London force, hydrogen bond, and dipole. It has all the three. Intermolecular forces of attraction. Yes, let's go to the next question, which is the next organic molecule. Question 4. Okay, question 4, what are they saying? Question number 4, they're saying the following diagram below shows the different organic reactions. Okay, it's showing the different organic reactions. PQR and the PQR are organic compounds. Okay, reaction 1, 2, 3, and 4. Okay, sharp. Reaction 1, it means that my focus must be on reaction 1. The type of additional reaction. Okay, reaction 1 is here. But what if it is this? If this is addition, it means that this was having a double bond somewhere. And what are you adding? You are adding the bromo to bromo. It means that you're adding this bromine. Oh, they have even showed it here. You're adding the bromine. So it's gonna be bromination. Yes, you get your mark. Observable change which occurs in the container during the reaction. Guys, this reaction is very important in confirming. Whether the compound is saturated or unsaturated. If the compound is saturated, then it means that it's going to have to decarboxylize. If the compound is unsaturated, is having a double bond somewhere, is going to decarboxylize the bromine water. Don't forget that the bromine water is red in color. So the red color is going to disappear. So what you see here, you're going to see the decarboxylation of bromine water, or the red color is disappearing. Yes. So the structure formula of compound Q is Q. Okay, say that he has a double bond. But now look, how many carbon atoms are there? I need to know. Look here, they are saying that propan, but methyl. So it has propan is 3. So 1, 2, 3. But it has a methyl, meaning that it has another carbon atom there. Yes. But don't forget that it was a double bond. It has a double bond here. It was unsaturated, so it means that this bond will go. And then now I'm gonna have another bond here. You see? So that now 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. Yeah. 1, 2, 3, 4. Yeah. So the reaction is gonna be like this. But don't forget to put hydrogens everywhere. Yes. Then you're saying write down the APAC name. Consider reaction 2. What's the reaction 2? Where is reaction 2? Reaction 2 is from the same molecule, but I'm adding hydrogen chloride. If I'm adding hydrogen chloride, write down the APAC name of compound R. What is compound R? Compound R is here, the major product. So if it is a major product, it's going to follow what's called the Markovnikov rule. Yes. The richer must get richer. The rich must get richer, and the poor must become poorer. That's Markovnikov rule. If you have more hydrogen, the carbon atom with the more hydrogen will take the hydrogen, and the carbon atom without hydrogen will take the halogen. So the structure was like this. Let me see. Saying this. Okay, sharp. So remember, it was like this. Yes, it was like this. Okay, this one has a hydrogen and a hydrogen. So it has 2 hydrogen, while this one has nothing. So it's like this. So I want to add hydrogen chloride or hydrochloric acid, whatever. Look. So now this hydrogen is gonna go to the richer, and then this one is gonna go to the poorer. The poor person, the poor atom. So now it becomes, this one is gonna be C. Now it's gonna have 3 hydrogen. With the double bond is gonna break. I'm gonna have a chloride here, and then I'm gonna have the methyl down, and then I'm gonna have this here. I'm gonna have this here. So that's the structure they're looking at. Don't forget to put the hydrogen. This is a chloride. Yes. So basically that is it. Reaction 3, a balanced equation using structure formula for the organic compound. Reaction 3. Let's go to reaction 3 and see. So from there to alcohol. So here I have to add some bit of OH. So how am I going to add that OH? It means that I have to add dilute acid, acidified water, basically. So I'm gonna have, did I say structure formula? Let me check. Did I say structure formula? Yes. So it's gonna be 1, 2, 3. Yes. Don't forget the hydrogens. So, and then now I'm gonna have, so you don't forget to acidify it, so that I have the OH in abundance, so that it replaces that. So it's gonna have, yes, so this, but don't forget that this is chloride. So the chloride is going to be replaced by OH, and the moment you form the OH there, automatically that becomes an alcohol. Hence the structure is done. You have to put the hydrogens there. Guys, if you don't put those hydrogen, you will get 0. You see those 6 marks they're talking about? You will get 0. So make sure that you draw your structures properly, 100%. Alpha name of compound of alcohol, P. Where is alcohol, P? Oh, the alcohol we have formed here. So it's gonna be 1, 2, 3, 4. Okay, it's gonna be 3. It's gonna be pan, but it's on carbon. This one is on carbon atom number 2, 2 or, but it has a side group. Side group is on carbon atom number 2, so it's 2 methyl, because the side group has 1 carbon atom. 2 methyl propan 2 or. Hence, that's the answer. Then we got to the next question. So this is done, and this is done. Reaction 4. I know that synthesis sometimes is a problem to students. We call this synthesis. Synthesis sometimes is a problem to the students. So if I'm explaining something and you don't understand it, please let me know. Yeah, let me know before. Yeah. All right. Reaction 4 is elimination reaction. Write down the type of elimination reaction. Where is it? Reaction 4. You're from alcohol to this one. What are you eliminating? You're eliminating water. So it means that you change the alcohol to alkene. So the elimination reaction there is going to be dehydration. Dehydration, because you are removing the water molecule there, or you are removing the OH from there. OH. The type of reaction that takes place, okay, butane 1-ol reacts with propanoic acid. When you say butane 1-ol, that's an alcohol, reacts with the carboxylic acid to form in presence of a catalyst. Write down. The moment an alcohol with a carboxylic acid reacts in presence of a catalyst, and this one is sulfuric acid, and it must be conc in presence of heat. Yes, then it's going to be esterification. So this answer is esterification. Sometimes you can call it condensation. Yes. But now, butane 1-ol, propanoic acid, butane 1-ol, butane 1-ol, 1, 2, 1, 2, 3, butane, 3, 4. It's saying 1-ol, then propanoic acid, 1, 2, 3. Then, oh, yes. So meaning that this one is going to be lost, and then this one is going to be lost. You form water. That's why you call it condensation. Yes. Now, after that, don't forget that these ones you're supposed to put the hydrogens, né? The hydrogens. If you don't put the hydrogens, you're gonna get it 0. 0. And we love to give a 0 than a tick. So if you are just negligent on your work, you'll score a 0 with eyes. Big eyes. Sorry if you have big eyes. So what happens here is gonna be 1, 2, 3, 4. Yes, you have this oxygen there. Yes, but oxygen now is gonna combine with this carbon, so you form that carbon. This oxygen is gonna go up, and then you form another carbon here, and then another carbon. Basically, that is it. 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 So now, question: how do you name this? Because this is coming from alcohol, then it's gonna become 1, 2, 3, 4. It's gonna become butyl, and then this one 1, 2, 3, it's going to become propanoate, butyl propanoate. That's it. You get your 2 marks. Question 5. Question 5, I said that I'm gonna go up to question 5, then I'll get another time, and then I shoot from question 6, 7, 8, and 9. Yes. So let's go to question number 5. Question number 5. Welcome to question number 5. Are you there? All right, let's go. Saying that, consider the following decomposition reaction that takes place in a sealed 2 decimeter cubed container. All right. So what is happening there? We are saying that here you have dinitrogen tetraoxide. Yeah, I told you that this is the problem with the students. They don't know how to say these chemical names. Ne? Dinitrogen tetraoxide reacts with it decomposes to form nitrogen dioxide plus oxygen. The graph below shows the concentration of dinitrogen tetraoxide and the nitrogen dioxide. Okay, sharp. Let's go. It changes to the time. All right. So which one is dinitrogen tetraoxide? Because this is dinitrogen tetraoxide is a reactant, therefore is supposed to be going down, meaning that this is dinitrogen tetraoxide, and then this is nitrogen dioxide. Okay, because this is a product, and the product is always increasing, and in most cases the products, they start from 0 and then they go up. Refer to the graph above. Give a reason why A represents a change in the concentration of nitrogen dioxide. Nitrogen dioxide, A. Why are you saying that A? Why are you saying that A? Where is A? All right. Why are you saying that is A, which is this? It's because we are saying that it's because A, where is it? Yeah, it's because its concentration is increasing, and here nitrogen dioxide is a product. The concentration of A is increasing because it is a what? Is a product. Yes. Consider the statement below. The rate of decomposition of dinitrogen tetraoxide is half the rate of formation of this. If I have is half the rate of formation of this, meaning that nitrogen tetraoxide, the rate, if I have 1 here, then here nitrogen dioxide, the rate of decomposition of this is half the rate of formation of this, meaning that if this one must be half the rate of decomposition of nitrogen tetroxide is half the rate of formation of this. Now here you have to come back here to the mole ratio and see the rate of decomposition of this is half of this. Is it true? Is this half of this? You come back here, meaning that if here I have half, yes, here I have 1. The rate of decomposition of these, yes, is half the rate of formation of this, meaning that if this one is 1, this one is half. Half of this is this. Let's go. Is half of this, half of this one is 4, is half of 4 equals to this? Is half of 4 equals to 2? Yes. So the answer is yes. Is the statement true? Yes. Give a reason for your answer. Why? Is because 2 moles of nitrogen tetroxide produce 4 moles of nitrogen dioxide. Yes, that's it. Calculate. Oh, you're going for calculation. Calculation time. Mass of nitrogen dioxide present in the container at the 40 minutes, 400 minutes, seconds, not minute. So if you look at this, you come here on 400 is here. Ne? Yes. But they are saying they are looking for the mass. Ne? Are they looking for the mass? What are they saying here? What are they saying here? Mass of nitrogen dioxide present. So how am I going to find the mass? Yes, we have 2 formulas, but let's first find out what do we have so that we can use the mass. We can calculate with the mass. Okay, first of all, I have at 400 seconds. What do I have here? Here I have concentration. Ne? So the mass is going to be, concentration is 200. Ne? It's 200. It's 200, but it's not 200. Yes, it's not 200. Look at this versus this. So the answer is going to be here. The concentration here is going to be, the concentration here is going to be, okay, let me just do like this. Where is the question? Mass of nitrogen dioxide, okay, present. Okay, let me use this space. They are looking for mass at 400 seconds. But if you are saying 400 seconds, let's come back here. They're looking for mass of nitrogen dioxide. Ne? They're looking for mass of nitrogen dioxide. Let's write it here. We are looking for mass of nitrogen dioxide. But now, let's look at it here. The concentration, what's the concentration? Concentration is equal to, we have said is 200. But look here, times 10 power negative 4 times 10 power negative 4. So that is the concentration. And then now it means that it is 2.0 times 10 power negative 2 molar or moles per decimeter cubed. But now we are looking for mass. So it means that, do we have the volume? Don't forget that mass or number of moles is equal to mass over molar mass. Okay. Number of moles is equal to mass over molar mass. Do I have number of volume, number of moles? No. Do I have molar mass? I can calculate it. Do I have mass? No. So, but I can calculate the number of moles. Number of moles is equal to, yes, is equal to concentration over volume. But this must be a molar volume in decimeter cubed. So it means that number of moles is equal to concentration, which is 2.0 times 10 power negative 2, divided by the volume. What is the volume? What was the volume? Let's go back and they said what? Yeah, they said a 2 decimeter cubed. So it means that I'm going to divide it with 2. So divide by 2. So the answer I get is going to be the number of moles. It's going to be the number of moles. So the number of moles is going to be, let me use the calculator and see, 2 times exponent negative 2, yes, times, not times, divided by 2, answer. The answer is going to be 0.01. So the answer here is going to be 0.01 moles. Yes. So now I've got the moles. I've got the number of moles. Yes. So since I have the number of moles, I can have the mass now. But do I have the molar mass? I can find nitrogen dioxide is equal to nitrogen is 14 plus oxygen 16 times 2. So this is 32 plus 14 plus 14. This is 6, and then this is 4, meaning that is 46. Yeah, 46. So it means that I'm gonna come here and say that number of moles is equal to mass over molar mass, of which number of moles is 0.01 is equal to mass over molar mass. The molar mass is 46. So the number of mass is equal to 0.01 times 46. So mass is equal to dash grams. So 0. Times 46. Answer is going to be, the mass is going to be 0.46 grams. Yes, that is the mass at this specific point. That is the mass at this specific point, which was remaining. Yes, that's the correct answer. Sometimes when we are pressing the calculator, sometimes you end up missing a figure. So you can recalculate, but that's the steps you are supposed to follow when you are doing that calculation. Then average rate of production of oxygen. When we talk about average rate of production of oxygen, then we come here. Let's see, average rate of production of oxygen. Where is it now? Average rate of production of oxygen. Who is oxygen? Oh, yeah. But now we don't have oxygen here. Do we have oxygen here? We don't have oxygen here. But now we can use the rate of production of oxygen. How do we identify this? So we can find the rate of
They said they're writing tomorrow. What they're writing tomorrow was sent to the group, but I did not see in the group under 12. Sorry.
So we are saying that so what we are saying that let's go to the next question and we see. So we are saying that we are calculating. Okay, if you have a question, guys, let me know. Let me know. So we are saying that, yes, the average rate of production of oxygen at they're saying in, meaning that from 0 to 700. But now rate, you're supposed to use what we call the rate of reaction expression, meaning that you're gonna say change in the concentration, but here we can use this. Let me show you. We can use this. If you use this, after that we can use it to mole ratio to find out the rate, because the rate of this formation, yes, this one is 4 times the rate of formation of this. You understand? 4 moles of nitrogen dioxide. When you form 4 moles, you form 1 mole of oxygen. That's the meaning. So now let's come here. Let's come here and then we start calculating. Okay, rate is equal to final concentration minus initial concentration over final time over change in time, that is initial, of which initial time, final time here based on this is going to be, because they said in the first 700 seconds, so it means that it's going to be 700, final is going to be 700 in the first, meaning that minus 0, and then here is going to be, you have to calculate and see each box is what, each box is 20, ne? Each box must be, it must be 20 30. Yes, so it means that this is 250 plus 30, giving me, let me see if this is 1 2 3 4 5 6 7 8 9 10. Yes, ne? Yeah, so it's 10, ne? So if it's 10, this is 250 to this, so it means that each, so it means that this is 10, so it means that each box is 5, not 10, is 5, So now they're saying 700 is here, 700 is here, so how many boxes are I? 5 10 15 20 25 30, so 30 plus this 250, so it means that is 280. Yes, so it means that my concentration is gonna be 280 minus 0, so I'm gonna have 280 divided by 700, so it gives me the answer to be 0.4 moles. Yeah, if it is 0.4 moles, but now don't forget that we saw here that what what they are looking for here is oxygen. Where is it? What they are looking for here is oxygen, and what we have calculated is nitrogen dioxide. So I'm going to have divide, so it's gonna be 4 to 1, so it's gonna be let me check here, let me check something here, because they say that the graph shows the concentration of nitrogen dinitrogen tetraoxide and the nitrogen oxide, dinitrogen tetraoxide and nitrogen dioxide, so they didn't say that this graph is oxygen, so that's why we have to bring in, and then we say that if 4 moles of this is 0.4, then 1 mole is going to be what? X, and then cross multiply, so meaning that X is going to be 0.1, meaning that this is the what was the question? The question was saying that the average rate, so it's going to be rate is going to be, what is this? It's going to be moles per decimeter cubed per second, moles per decimeter cubed, moles per decimeter cubed per second. Yeah, basically that is supposed to be the answer. And then when you go to the next question, okay, they're saying that Maxwell distribution curve for dinitrogen tetraoxide initially present in container is shown below. All right, the initial concentration of dinitrogen tetraoxide is now increased. Okay, redraw the distribution curve above and in the booklet, and then label it P when you increase the concentration. The moment you increase the concentration, it means that you are increasing the number of particles. Yes, since you're increasing the number of particles, what is going to happen is you're going to increase the number of particles which are, yes, the number of particles which the rate is going to increase, therefore it shifts. Let me explain it like this. The rate is going to increase. Why? Because so it shifts to the left. So the number of particles, activation energy is going to remain the same, but the number of particles are going to increase. When the number of particles increase, it means that the number of particles with sufficient energy also going to increase, meaning that the graph is going to look like this. You see? Yes, meaning that it shifted from here to here. What if it was temperature? Temperature, yeah, it was supposed to be like this. I see. Yes, but for this one, yes, temperature does not increase the number of particles. No, it increases the particles which have sufficient energy. But this one now increases the number of particles. It increases the number of particles, and then what happens? It means that these particles will have, many will have sufficient energy to react. You understand? Yes. So they are saying that on the same graph, sketch the graph that will be obtained for the higher concentration. Okay, redraw the graph, answer booklet, and label it P. So we have done that. They're saying, will the rate of decomposition of dinitrogen tetraoxide at a higher temperature or concentration, be higher, lower, or equal to original rate of decomposition? Explain your answer. It will be higher than. Why? Because you have more colliding particles. If you have more colliding particles, it means that more particles will have sufficient energy to form products. Hence, the rate of reaction is gonna increase. Yeah, so basically, that's what you're supposed to explain. Question number 6. Question number 6. Guys, I'm going to stop here. Thank you very much. We're gonna start, when I come back, we're gonna start with question number 6. We do the calculations. We go to question number 7. We do the calculations, or do we answer them? I explain them, and then we go to question number 8, and then we go to question number 9. Thank you very much, guys, for joining me. Don't forget to subscribe, like, and share to others for our daily new videos. M. Saidi, as usual. Look at energy changes in reaction related to bond energy changes. So it means that you're going to be looking at the bond, what energy is found in the bond. And then number 2, we are going to look at definition of heat of reaction, and then exothermic and endothermic reactions. We are going to look at them in detail and then try to understand them better. And then we are going to look at the classification. That is with the reasons. You don't just classify. If you say it is endothermic, why do you say it is endothermic? If you say it's exothermic, why do you say it is exothermic? So that's what we are going to look at. Activation energy. Here is there is a very big point which you need to know, because some students try to confuse the activation energy and kinetic energy. So students try to confuse them. So another one is we're going to look at the graphs. We are going to try to interpret them. We're going to try to interpret them and then see exactly what is really happening. Why do you say this is endothermic graph, this is exothermic graph? So all those we are going to look at them so that we understand them better.
Okay. When there is a reaction, there must be heat either absorbed or released. When heat is absorbed, then we will say that that reaction is endo. We will see it. And when heat is released, then it means that that reaction is exo. When you say exo, it means out. Endo means in. In, you are taking in. Exo, you are taking out. Okay. Energy is absorbed or released in a chemical reaction. Whenever there is a reaction, even if you are fighting, there will be some energy absorbed. One must release the punch, one must absorb the punch. So there must be an absorption and there must be a release. So one must release, one must absorb. So if there are two chemicals, one must absorb, one must release. And then the total, how much is released, how much is absorbed, then we will know that the reaction, the whole reaction is either endothermic or exothermic. For example, you have reactants A and B. You combine them and then you form the products C and D. What will happen? The reactant particle need energy, so that they need energy, yes, so that the existing bonds, it could be covalent bond, it could be ionic, it could be metallic, any kind of bond which is there between these particles can break. They will need energy so that you can break those bonds, and then after that you will form a product. So for a reaction to take place, energy must be present so that they can break down the bonds and then a reaction can take place. Energy is released by particles as new bonds form when the products are being produced. So now, when the energy is released by particles, then it means that some particles are going to use this energy to form the new bonds. As bonds are being broken, energy is released. Look at this. A reaction of petrol. Petrol will produce heat. It will produce fire. But petrol cannot burn without fire. I don't know whether you understand what I'm saying. You have petrol. Petrol, if it is just there, it cannot burn unless you ignite the petrol so that it can burn to produce more fire. So petrol to burn, the reaction to take place, it will require energy. That is the energy you're talking about. But now once the reaction starts, now the energy is too much in there. Now the reaction starts to continue, and then more energy is released. Now we subtract the energy we applied, and then we know that either it is endothermic or it is exothermic. So whenever bonds are formed, energy is either released or it is absorbed. Yes. So now we're saying that change in energy. How do you calculate the energy? The enthalpy, dH or delta H, or change in H. This is energy change, enthalpy. So is equal to energy of the product minus the energy of the reactants. So now if it was petrol, yes, you ignite it. The amount of energy you used, yes, as the reactant, that is the initial, yes, minus the amount of energy you produced at the end of burning process. There is amount of energy which has been released. So if you bring that amount of energy which has been released at the end minus the amount of energy you put in, then you get what you call the enthalpy change, and then we will know either this will be negative or it will be positive. It's like a business. You put in capital and then after that you get the profit. But profit, how do you calculate the profit? You're gonna say what you have gathered, what you have got at the end of the business minus what you put in, and then you get the profit. That's it. It's the same story here. Energy change, what you produced minus what you put in, then you get the energy change. Guys, don't forget this. Sometimes we say that energy of the product minus energy of the reactants. It's the same thing. If you find equations like this, it means that enthalpy change. And then sometimes you say energy final minus energy initial. It still is the same story. It's just a different way how we can express these equations. Or we can say you can write it in this way, yes, or you can write it in this way. Substitution, it will make you earn a mark. So it means that the final, you substitute it nicely as the final product or final energy and minus the initial. Make sure that you substitute it nicely and read the question nicely so that you can obtain the information which is being asked nicely. Then now let's look at the types of reactions. Types of reactions. We said that number one, we have what called the exothermic reaction. Don't make noise. Okay, let's continue. And then you're saying that endothermic reactions, which result in absorption of energy. So when you have absorption of energy, when energy has been absorbed, then it means that is endo. It goes inside. Endo means inside. Thermic means temperature or heat. So it means that heat has been absorbed inside. Okay. Now, note, you need to know about this. More energy is released when new bonds form than is absorbed when existing bonds break. I repeat, more energy is released when new bonds form than is absorbed when the existing bonds break. Then it means that when there is bond formation, more energy is what is released. And then when there is bond breakage, it means that more energy is what is less energy is released. More energy is absorbed when the existing bonds break than is released when the new bonds form. So we are saying that the energy is absorbed when the existing bonds break. It means that you require more energy to break. You require more energy, you require some energy to break the bonds. Yes? And then here, you don't require energy to form the bonds. That's why more energy is released. And then here, more energy is absorbed. You require more energy so that you can break those bonds. Yes? We will see these ones when we go to the graphs so that you can understand it more accurately. Let's look at exothermic reaction. When you talk about exothermic reaction, look at this reaction. You have the enthalpy change of the reactants must be greater than the enthalpy change of the product. Therefore, the enthalpy is always negative. Okay, the enthalpy change of this reaction, for example, let me use this equation as I'm explaining this. Okay, if you are starting with the core, which is carbon, you add the oxygen there, then you produce carbon dioxide. Some heat is released here. Yes, it starts to burn. Yes, so the products will have the energy, the ash which you get will have less energy. That's why if you try to burn them again, the energy is no longer there. Yes, the energy in the ash will be less than the energy which was there in the core. That's why you're saying that the reactants will have more energy than the product. Because now we are saying that the enthalpy change is product minus reactants, and then now the reactants are bigger than the products, then the enthalpy change must be negative. That's why you have a negative answer here. So whenever the enthalpy change is negative, then the reaction is exothermic. I repeat, and let me repeat it again. And then make it more clear so that you can see what I'm talking about. Okay. We are here. We are saying, I'm repeating, that if you have a reaction whereby the products have less energy and the reactants have more energy, it means that energy has been released. You start with a high energy and then you end up with a low energy, then it means that there will be where some energy has been lost somewhere. So now, if you have a reaction like this, yes, you have a reaction like this, and then you have coal combined with oxygen, then you have carbon dioxide, then it means that some energy has been lost as heat. So when some energy has been lost as heat, what will happen? Then it means that the reactants will have more energy and then the products will have less energy. And then if you subtract the products from the, you subtract products minus the reactants, then it means that the answer is going to be negative. Why? Because the reactants are bigger than the products, and then the enthalpy change is going to be negative. That's why we say that the net energy leads to the surrounding in form of heat. That heat is released to the surrounding. The net energy, some energy has been released to the surrounding and then makes the products to have less energy. Hence, the reaction becomes exo because energy has been released to the surrounding. So, delta H negative is always an exothermic reaction. I repeat, delta H or change in enthalpy, whenever it is negative, we say that that reaction is exothermic. If you look at this graph, it's trying to explain what really happened in the exothermic reaction. Look, you start with a high. If this is 0, this is 2, this is 4, this is 6, this is 8, this is 10. You find out that the products, this is the product, because you start from here, then you have to overcome the activation energy. We are going to explain that, and then you end up here, the products. So the reactants have more energy. You see here is higher, and then the products, their energy is what? Is low compared to the reactants. So it means that where is this difference? This difference, the amount of energy which has been lost to the surrounding, which we call change in energy, or delta H, or change in enthalpy. So if they ask you to calculate the enthalpy change graphically or from the graph, then you find this point, the final product, you note it, maybe it's 2, and then the initial, which is maybe it's 4. So it's 2 minus 4, then you get the answer, which is maybe 2. But in this case, because 2 minus 4 is equal to 2, which is a negative. So the magnitude is 2. Negative means that it is exothermic. It released some energy. So that's why you see it here that delta H is less than 0, or 0 is greater than the delta H. So the answer must always be negative. This is A, and then you're saying that A is a reactant. I accept this is a reactant, but it's a reactant for the forward reaction. If I'm going like this, then A is going to be a reactant for the forward reaction. We're going to be talking about forward reaction and reverse reactions in chemical equilibrium, but if you don't know what you're talking about, then chemical equilibrium is going to be a problem to you. So now we are saying, I'm repeating now, this A is a reactant for forward reaction. We call this A is a reactant. Whatever is here is a reactant, but for a reaction which goes like this. Wonderful. But we say product, it can also be a product for a reverse reaction. Now, if I'm starting from here and then I come back like this, now this one is going to be a product for a reverse reaction. I repeat, if they ask you identify the product, they have not told you identify the product for a reverse reaction. No, if they say identify the product or identify the reactant, you just have to give me for a forward reaction, that a reactant is this and the product is this, unless they have specified that identify the reactant or the reverse reaction. Saying that unless they say that identify the reactant for the reverse reaction, then I will say that, okay, because I'm reversing, I'm starting from here, then I go back. So this one becomes the reverse reaction. So it becomes, this is the reactant for the reverse reaction, and then this is the reactant for the forward reaction. B, product. So B is a product for the forward reaction. So if I started from here and I go like this, then this becomes what? It becomes the product for the forward reaction. But we say reactants for the reverse reaction. So if I reverse it, then now B becomes the reactant for the reverse reactions. Okay, then we are looking at C. C is what called the activation complex. Yes, C becomes the activation complex. Before the reactants form products, they must form what you call the activation complex. Yes, without a catalyst, then it is much more higher. With a catalyst, it is a bit lower. We will explain why these come like this when we go to the factors affecting the rate of chemical reaction. So activation complex, it means, what does it mean? It means, for example, let me say Loloetu is going to fight with Aviwe. So when they are going to fight, what happens? They don't just fight. No, there is a time when everyone has energy and you see that even the face has changed. Yeah, whoa, now you know that, yeah. So they're about to fight. Then when the time when this one brings a blow and then also this one brings, that time before collision, but just towards collision, that is the activation complex. So now you have A and B, they react. When they react, they are going to react. There's a time when the bonds are, the reactants are almost together and there is some attraction between the two products. So we call that one activation complex. The moment they touch each other, now they exchange, then they form the what? The products. But to form a product, you need a specific amount of energy. You don't just, you can provoke someone, there's provoke 1, 2, 3, but can't fight. But the moment, the energy is enough, then they fight. So activation complex, it is that period when the bonds are almost linked. Then the activation energy, that's the energy the reactants must have so that they can convert into products. So without that energy, they cannot convert into products. Meaning that without that energy, these two people cannot fight until they reach that energy. Then they start to fight. Then we are saying that activation complex with a catalyst. When there is a catalyst, you know that, for example, Aviwe wants to fight with Loloetu, and then what happens? Tabiso comes and says that, Mofukenge comes and they say that, Aviwe, you can't beat this Loloetu. You can't beat her. Then what happens? Now Tabiso starts to bring in. So it means that Tabiso makes the energy to be fast. So the activation energy to be a little bit lower. And then they will fight. Instead of fighting after maybe 10 minutes, they're going to fight within 3 minutes. And then the fight is already there. So the activation complex with the catalyst tries to lower the energy. That's why you see it here. That the one with the catalyst, it is lower. And then the one without catalyst is a little bit higher. And then the endothermic reactions. When you talk about endothermic reactions, these reactions, you'll find out that it is the reverse for the exothermic. The reactant energy is less than that of the product. It means that the products they have more energy than the reactants. Meaning that the activation energy, meaning that the energy has been absorbed. The energy has been absorbed, and then the enthalpy change is always positive. Why? Because the products have more energy than the reactants. If you say products minus the reactants, you get a positive answer. That's why you say that delta H, or change in energy, is greater than 0. It means that it will never be negative. When it is negative, then we say it is exothermic. And then you're saying that here is the formula whereby you say that products minus reactants. Yes, obviously the answer you get here must be greater than 0, which means that it must be positive. Net energy is absorbed. Since you have reactant A and then you have product B, then product B has absorbed the energy, then obviously the energy is going to be a little bit higher. So energy is absorbed from the surrounding in the surrounding in the form of heat. And then what will happen? What is the best example here? The best example here for exothermic, endothermic, yes. You in winter you try to bath warm water, yes, isn't it? So when you bath warm water, you feel a little bit hot. Yeah, you feel a little bit hot. It means that the body has absorbed the heat. Wonderful. That is endothermic. You have absorbed it. Hey, but okay, don't cover yourself. Leave yourself just like that. After some 1 minute, what will happen? Now you start to feel cold. What does it mean? Now the reaction has reversed. Now the heat is being released to the surrounding. Now it becomes exothermic. Now it means that you are releasing the heat to the surrounding. So the reaction can be reversed. You take in, if you don't take care, then it reverses, or if it becomes full, then it reverses, then it comes back. When you eat, another example, when you eat, just eat. You eat, you take in energy, So we say that is endo. But what will happen? If you overeat, then you regurgitate, you start to vomit. Then now that is exo, you release out. After releasing, whenever you release, you feel much more better. That's how it is. And whenever you take in, you feel uncomfortable. That's why when people overeat, they feel uncomfortable. But once they release, they feel much more better. There are so many examples where you have these things in the day life. When you go to the toilet, you are exothermic. You are releasing the heat, isn't it? After the toilet, you feel much more better. You feel happy, and everything is moving smoothly. I'm not saying this embarrass you, but that's what is happening. And these are the reactions. These reactions, you know them, but sometimes you don't take a keen eye to see that these reactions are happening in real life. Okay. Example is, now we are going back to the chemical way. Example is dissolving ammonium nitrate. If I was at school, we would have done these reactions and then we see them. Unfortunately, corona is the problem. Okay. We are saying that example is ammonium nitrate in water. When you dissolve ammonium nitrate in water, you will find out that the reaction is endothermic. It takes in heat. Okay. Before I explain this, I'm going to ask you.
It's just a friendly reminder that like our video. And don't forget to subscribe for next free videos. At Thundereduc,
increase in the temperature of the reaction. So we are saying that you have two graphs, graph A and graph B. This graph shows that at a higher temperature, the graph looks like this. At a higher temperature, the graph looks like this. And then at a low temperature, you'll find out the graph looks like this. So what is the major difference between this and this? Why is at a higher temperature it looks like this? So this shaded part shows the particles which have enough energy or more than the activation energy so that they can react. So if you look at the number of particles here, if you draw a line here at a low temperature, you find out that only these particles from here to here have enough kinetic energy to react to form into products or more than activation energy. But if you look at this, the number is bigger compared to this. So it shows that here there are few particles which have enough kinetic energy to convert into products. But here it has more particles which can be converted into products. So when you increase the temperature, you are increasing the kinetic energy. You are increasing the speed at which these particles are moving. Increase in the temperature, you are increasing the speed at which these particles are moving. And then this causes more collision. So if the temperature is too high, then it means that there's the activation energy is going to be lowered, or many particles will have more kinetic energy, and then they can be converted into products. That's why you see here that here the reaction or the graph is covering more particles if you draw a line here, and then here it is covering fewer particles. So it means that if you have more kinetic energy, it means that the particles which are going to react are going to be more, and then more products are going to be formed. So increase in temperature increases the rate of chemical reaction. So at higher temperature, the graph is wider and most probably energy is higher. So if you look at it, the graph is wider. It means that it has more particles which can react, which have enough energy, and then the number of additional particles with energy or is greater than the activation energy, therefore enough energy to react with the other reactants. And then this one shows that the most probable energy at low temperature. So at low temperature, this is the most probable energy, and then most probable energy at high temperature. You see that the energy here is, look at this, you see that the particles have a lower energy, kinetic energy. And then if it is a higher temperature, you find out that the energy increases from this point to this point. If this is 0, 2, 4, 8, 10, you find out that this one will have like 8 and this one will have like 12. And then it means that it has more. If it is at higher temperature, it has more kinetic energy. So that's how we can explain this graph. At a higher temperature, the average kinetic energy is higher than at a low temperature. So at a higher temperature, the kinetic energy is higher than, if you look at this is a low temperature, this is at a higher temperature. You see that the speed at which these particles are moving is lower than the speed at this one at which these ones are moving. So when there is a high temperature, then there will be more kinetic energy, and this more kinetic energy will make the collision to happen. So if you look at these ones, you see that anytime they can collide, but these ones, they are slow. The speed at which they are moving is too low, then it means that the rate at which they collide is going to be low. So we are saying that more particles have kinetic energy greater than the activation energy. So if there is a high temperature, you find out that there will be more particles having more kinetic energy greater than the activation energy. And the moment the energy or kinetic energy is greater than the activation energy, then the reactants are going to be converted into products. More effective collision will take place per second. Then it means that reactants can be converted into products. Another factor is the effect of increasing in the concentration of the reactant.
Welcome back to our class. Don't forget to subscribe if it is your first time to visit our channel.
Volatile cells. Last time we talked about electrolytic cells. We say that electrolytic cells, for them, they require external battery. So if it requires external battery, it means that they are not spontaneous. They cannot continue on their own. So they have to be with an external battery which can supply energy to them. And we say that an electrolytic cell, it changes electrical energy into chemical energy. And then the voltaic cell or the galvanic cell, yes, this one, it's the reverse to electrolytic cell. A galvanic cell, it changes the chemical energy into electrical energy. It means that it produces electricity. All right, let's start. So we are saying that a galvanic cell or a voltaic cell is a cell in which chemical energy is converted into electrical energy. It means that use chemicals to produce electricity spontaneously. It means that without any external source. It means that these chemicals are converted into electricity. A cathode is positive. Remember, in electrolytic cell, cathode is negative. And then anode is negative. Remember, in electrolytic, anode is positive. So remember that electrolytic cell, it is the reverse of the galvanic cell. Reduction takes place at the cathode. This one remains the same as even in electrolytic cell. And then oxidation occurs in anode. Still is the same thing with the electrolytic cell. Strong oxidizing agent is put on the cathode. When you say oxidizing agent, guys, don't remember, when you say oxidizing agent, how about it? What is happened to it? It means that if it is an oxidizing agent, for it is reduced. So it means that it's less reactive. It can accept the electrons. Yes, it can accept the electrons. If you are broke, it means that you can accept everything. Yes, so you oxidize others. You make others to be broke. All right. So we are saying strong oxidizing agent, it means that they can accept the what? The electrons. For them, they are reduced. So they are you put them on the cathode, the positive. Because cathode is positive, so they are able to receive electrons from what? From a strong reducing agent, which is put on the anode. Anode is negative. Then it means that the strong reducing agent, for it, if it is a strong reducing agent, then it means that it is oxidized. It is able to release the electrons. It increases in the oxidation state. When you lose electrons, you become more positive. You become more positive. Yes. When you give credits to others, you become more rich, because you know that anytime that money is going to come back to you. All right. So we are saying that we put it on the anode. So you have to understand this, because if you don't understand this criteria, then you won't be able to understand the concept of volatile cells. So I will say that this is a red cat. This is a red cat. This is a red cat. So don't forget that. I'll tell you what it means. All right. So we are saying red cat. What does it mean? Reduction at the cathode. Reduction at the cathode. Consider, now we are going to have an example. We are going to have different examples. Consider copper zinc cell. If you look at them, you'll find out that one is more reactive, one is less reactive. If you look at the reactivity series, this one is less reactive, this one is more reactive. A strip of zinc metal is placed in the zinc ion solution. A strip of copper is placed in a separate beaker in aqueous copper 2 solution. So you have copper, you have zinc metal in zinc solution, and then you have copper metal in copper 2 solution. All right, here is an example. You have zinc, so there is a reaction which takes place here, and there is a reaction which takes place here. Yes, we say that zinc is more reactive. It is oxidized. It can release the electron easily. Therefore, it causes this one to be reduced. So this one becomes a strong reducing agent. Yes, strong reducing agent is supposed to be at the anode. Then copper is less reactive. We're going to look at the reactivity series. And then copper is less reactive. Yes, if it is less reactive compared to zinc, then it means that it's ready to receive from zinc. So copper is ready to receive. To receive what? Electrons. You see them? See them, yes. You see them. Yeah, electrons. So it means that zinc is going to cause this to be reduced. Therefore, zinc becomes a strong reducing agent. It's supposed to be at the anode. And then copper is going to receive the electrons from zinc. Therefore, it's going to be reduced. Therefore, we will say that copper has caused the zinc to be oxidized. Therefore, we shall say that copper is a strong oxidizing agent. Why? Because it has made zinc to be oxidized. That's the meaning. So this is the half cell for zinc and half cell for copper. These two beakers are connected by a salt bridge. Salt bridge is very important in giving these two cells ions. We're going to look at them and you will understand them better. All right. Should we continue? Yes. So we are saying that they have a reaction that occur in each half cell. This is what happens. We say that zinc is more reactive. Yes, it is a strong reducing agent. So it means that for it is oxidized. You start from zinc, the charge is 0, and then here the charge is 2, positive 2. Yes. So it means that this zinc gives out zinc ion plus 2 electrons. This equation must be balanced. Yes. You see, why do we put a 2 here? Because this is positive 2. So if it is positive 2, yes, this positive cancels with the negative, and then the equation becomes neutral. Remember, matter is neither created nor destroyed, but can be changed from one form to another. Yes. So your equation must obey that law. And then copper is going to receive these electrons. Yes, it is copper solution. Yes, it's going to receive the electrons. Yes, these electrons from zinc, and then it forms copper. There is something which is supposed to be noted here. If zinc dissolves to give zinc ion plus electrons, it means that this zinc electrode reduces in size. It means that the anode always reduces in size. Why? Because it dissolves to give out the electrons. It is supposed to be reducing in size. Then copper receives these electrons. Yes. And then what happens? What is happening? The ions here, the electrons from the zinc combining with this copper, yes, to form copper to ions to form copper solid. It means that copper, the copper will increase in size. You see, it will increase in size. Why? Because it forms a solid. Yes, if it forms a solid, then the cathode is always increasing in size. There's something we need also to understand better. Because now the copper ions are being used from the solution and then form a solid. Yes, it means that now the solution will start to fade out. Yes, to be fading. Why? Because the copper ions which make the solution to be blue, they are being used up. Therefore, now the solution becomes pale. It fades until it becomes clear. Once it becomes clear, then it means all the copper ions have been used. So you need to know those small concepts so that when they bring the question, you are able to answer them nicely and clearly. So, all right, let's compare. Let's compare the two half cells. Yes. Number one, zinc half cell, then copper half cell. The one we have talked about, oxidation reaction at the anode, which is always negative electrode. We know that anode is always a negative electrode. Yes. So oxidation occurs there. It means that zinc will ionize. Yes. When it ionizes, then it increases in the charge. Then obviously reduction will occur at the cathode, and it's always a positive electrode. This one is supposed to be a reducing agent because it causes this copper to be reduced. Yes. And then itself it is oxidized. When it releases electrons, you see, it releases electron, comes from 0 to 2. So it has been oxidized, increase in the state. While this one, it has accepted. Therefore, it's a strong oxidizing agent. It has caused this one to be oxidized. And for it, it is reduced from positive 2 to 0. You see, it has been reduced. And it has caused this one to be oxidized. It is a strong oxidizing agent because it has caused this one to be oxidized, and itself it is reduced from 2 to 0. That's the meaning. Then when you go to zinc, okay, the equation, this is the equation, what is happening, we saw it nicely, and also this is what is happening, we saw it nicely. Yes. So you read from right to left. We're going to look at it when we go to the reactivity theory. And then here, read from left to right. You're going to look at it when you go to the reactivity theory. All right. So when you're writing the cell notations, we're going to look at it and then you're going to get it better. All right. We are saying that zinc is a strong, zinc is the stronger reducing agent, while copper 2 is a stronger oxidizing agent. I've explained this. How is this is a strong strong oxidizing agent? Because it causes zinc to be what? To be oxidized. Then it becomes an agent for oxidizing. But itself is what? Is reduced. And then zinc is a strong reducing agent. Yeah, it is an agent for reducing. So it causes copper to be reduced. But itself is done what? Is oxidized. Then we are saying that the anode always decrease in mass if the reducing agent is solid. I've tried to explain it that if you look at zinc, because zinc is dissolving into the solution, then the mass must be reducing as long as it is this electrode is a solid. So it means that it keeps on reducing in size. It is corroded. Yeah, it starts to disappear. All right, and then they're saying the cathode always increase as long as it is a solid, always increase in mass if the reduced product is a solid. Yes, so we saw that since copper is a solid, if you look at it here in the equation, copper is a solid. Even you can look at it here. Yes, is a solid. Then it means that the terminal must be increasing in size always as long as it is a solid. Since now you know the concept, now it means that we can apply these concepts in different versions. All right, net cell reaction. It means that we're going to combine the half equations and then we see what we're going to form. Make sure the half equations balanced. Balance them, including the electrons. I tried to show you on the equation that the electron must be balanced. Add the two half reaction together, eliminating the electrons from both sides. So that now when you add them, then you eliminate the electrons and then it cancels out, then you form a full equation. Let's look at it. Here is oxidation, which is taking place on this side. Yes, on this side of the half cell. Zinc metal, yes, or solid, dissolves to give zinc ion plus 2 electrons. The 2 electrons, they start to move. These electrons, they will come to this side. So what happens? This one will receive. We'll receive these ones here. When they come here, and then they combine with this copper. So copper 2 ions plus 2 electrons, which came from zinc, and then you form copper solid. So this one forms a solid. It is deposited here. While this one starts to dissolve, which is this, dissolves and then becomes small. Becomes small, becomes big. Husband and wife, one must be becoming smaller, one must be becoming bigger. All right, let's continue. I don't know what is happening in your family. If your father is becoming small or your mother is becoming small, then one must be oxidizing agent, another one must be a reducing agent. All right. Maybe you are the one, you kids, who are making them to be oxidized. Or to be oxidized, or to be reduced, whatsoever, I don't know. All right, net cell reaction. So now how do we form? You have reaction which is taking place here, reaction which is taking place here. So arrange them like this and then start cancelling what is. So I check what is before the arrow compared to what is after the arrow. Zinc solid, this side before the arrow. Do I have it? I don't have a zinc solid. I leave it. I go to copper ions this side. Yes. Do I have copper ions this side? No, I don't have it. I have 2 electrons. Yes, I have 2 electrons here. Do I have 2 electrons here? Yes, I cancel them out. So those ones, they go. I come this side. I have zinc 2 ions. Do I have zinc 2 ions? No, I leave them. I have copper 2 solid. Copper solid. Do I have copper solid this side? No, so I leave them. So now I combine zinc plus copper 2, zinc plus copper 2. This is a solid, this is aqueous. Always, whenever you have a charge, it is aqueous. You should just have to know that. Then the arrow, yes, and then I have zinc 2 aqueous plus copper solid. These ones, they cancel it. That's how you can write the full equation. Simple. Know what is the anode, what is the cathode, find the equation there. One must be reduced, one must be oxidized. Find the equation, write the equation down, then combine them. Simple. No stress. Then, salt bridge. Part of an electrochemical cell. It's usually a tube. It's usually a tube. It can be containing electrolyte, providing electrical contact between the two solutions. So we are saying that it's a part of electrochemical cell. Yes, usually it's a tube. It means that the chemicals are being put into the tube. Containing an electrical contact. It must be containing an electrolyte. It must be containing an electrolyte. It means that it can, the substances you have put there, it must be able to conduct electricity, and it should be able to release the ions. Actually, if they can conduct electricity, then it means that it can release the ions and electrons. Providing an electrical contact, it means that it is there is a contact. It's not physical contact. It means electrical contact. Then it means that ions must be exchanged there. It's like an exchange. Functions of salt bridge. Number one, to complete the circuit. Simple. Anode and the cathode are being connected. That salt bridge must be there so that the circuit is complete. Number two, it keeps the two electrolytes in the two half cell separate so that they don't mix. They must not mix. However, it ensures electrical neutrality. So these two must be neutralized. If they are not neutralized, then it means that the cells will be impaired. The cells will not work. They will not work anymore. So what they do, they bring about charge, it brings about ion exchange. It brings about an exchange. So by doing that, it ensures that an electrical neutrality is obtained in that cell, so that the ions are neutralized, so that the cell can continue working or functioning normally. All right. Number three, this allows movement of ions between the two electrolytes from the cathode cell and then the anode cell. The two must be able to communicate with one another, even if there is a distance. So the salt bridge connect them. Note, electrolyte in the salt bridge must contain ions, which are weak. They must be weak reducing agents and must be weak oxidizing agents. The reason why they must be like this, so that they don't take part in being oxidized and being reduced. Because if they take a part in being oxidized and being reduced, then it means that they are going to be used up. So then the reaction will stop. So they must be strong, so very weak reducing agents and must be very weak oxidizing agents, so that they are suppressed by the other ones. This will ensure that ions are not oxidized nor reduced, but act as a spectator ions. So it's just like to neutralize, to bring about neutrality. It's just like that. Nothing else. It's just to connect. So these are the functions of the salt bridge. 1, 2, 3. Let's continue. Very simple. Electrolyte. Let's look at now electrolyte in simple term, and then we understand it better. So once you understand it better, then you'll be able now to combine all of them, and then you go for any question concerning about it.
It's just a friendly reminder that like our video, and don't forget to subscribe for next free videos at Thundereduc.
Adding a catalyst. So what will happen to a catalyst? Remember, catalyst can increase the speed or can reduce the speed. So the suitable positive catalyst, it will lower the activation energy, and then more reactants are going to be converted into products.
then you're saying that more particles have enough energy to form an activated complex. So the activated complex, that molecule which is in transition to change from reactants to products, you're going to have many particles which can form that, and then more products will be formed. Therefore, the number of possible effective collision per second is going to increase. And if it increases, then it automatically, the rate of chemical reaction is going to increase also. So the number of possible effective collisions per second increases, and this therefore increases the rate of what? Chemical reaction. So a catalyst increases the rate of chemical reaction by lowering the activation energy. So here you have the number of particles, here you have the kinetic energy, here you have the kinetic energy without a catalyst, and then here you have activation kinetic energy at with a catalyst. So it means that this reaction has been catalyzed, this one is not being catalyzed. So the number of additional particles with energy greater than activation energy, therefore enough energy to react. So if you look at this, I say that catalyst does not change anything here. It only lowers the activation energy. So if it lowers the activation energy, then it means that even those which couldn't react, now they have the ability to react. Then this leads us to the techniques we use to measure the rate of chemical reaction. Welcome back to our class. Don't forget to subscribe if it is your first time to visit our channel.
Electrolyte. Let's look at now electrolyte in simple term, and then we understand it better. So once you understand it better, then you'll be able now to combine all of them, and then you go for any question concerning about this. The salt of the compounds need to be soluble. It means that they need to be able to dissolve in the solvent. For example, water. Yes, it must be able to dissolve. The suitable soluble salts of zinc and the copper are, for zinc, it's better to use zinc nitrate. When you're talking about the chemistry of nitrates, all nitrates are soluble. They are able to dissolve. And the copper nitrate, and the copper nitrate. So these are the solutions. So on the side of the half cell of the zinc, you put zinc nitrate solution. And on the side of half cell of copper, you put copper nitrate solution. That's what it means. So in here, zinc nitrate solution, and then in here, you put copper nitrate solution. Now someone will ask you, but you talked about copper sulfate. Yes, but they are saying the suitable. You can use any other, but the suitable, the one which is much more better is that zinc is oxidized to zinc ion. You know that? And the concentration of zinc ion increases. Now look at this. How is the salt bridge very important? Let me just open your mind so that you know where we are going. Zinc is oxidized to zinc 2 ions. The concentration of zinc 2 ion increases, yes, building up a positive charge. So the concentration of zinc ions here, yes? Yes, they increase because it dissolves here. The electrons will move away from the negative potential. Remember, this is a negative potential. And then it goes to where copper is here. They go. When they go, they come this side to copper. What happens? The electron will move away from the negative potential, yes, the terminal, making it impaired. It means that now we have too much positive here. Remember, this is supposed to be a negative terminal. And then now you have too much positive. What will happen? Then it's going to be impaired. We need something which is going to neutralize this. This is a negative terminal, but now the positive charges are building there. So what is supposed to happen? Yes, we need to keep it negative, because if you don't keep it negative, it's going to turn into a positive, and then the reaction is not going to take place. All right. So copper 2 ion. So what is happening to this? We're going to look at the solution for this. But copper 2 ion are reduced. When they are reduced, they form copper solid. Wonderful. Then you are saying that the concentration of copper 2 ion decreases. It means that now when it comes like this, these electrons, they react with copper 2 ion. Remember, I told you that now it starts to fade. Yes, because we have used all the copper 2 ions. So the concentration of copper to iron decreases. This leads to copper to becoming less positive. It becomes less positive because now the positive charges have been used up. It has formed a solid. And remember, this is a positive terminal. So if the problem comes in now, what is happening really? So we have to make sure that this one remains positive. The electrons are therefore not attracted. It means that now these electrons from this side of zinc will not come to the copper. Why? They are no longer attracted. Why? Because now the copper to ions have been used up. It's no longer that strong positive side. Then what happens? Attracted to the cathode as strongly, making it impaired. It means that it can't work anymore. So what happens? We have to look for a solution for impairment of the cell. So what should we do? Number one, we are saying that the migration of nitrate anions is a negatively charged particle. Yes? Negatively charged particles are called anions, and positively charged particles are called cations. So we are saying that the migration of nitrate anions in this salt bridge to the anode. Remember, we say that here this one becomes it forms this, yes, and then it becomes more positive. It reduces the negative part of it. So what we need to neutralize this. So because it is positive, it is zinc to ions, yes. What is happening? The zinc to ions have accumulated, so we need a negative anion. Where is it going to come from? It's going to come from the salt bridge. Potassium ion, remember it is made up of, the salt bridge is made up of potassium and nitrate, yes, in the salt bridge to the cathode. So it means that this one will go to the anode, while this one will go to the cathode. Yes, it is potassium nitrate in the salt bridge. So what happens? It means that the positive will go to the copper, and then the negative will go to the zinc. Let's go back here and we see. We say that this one accumulates. When it accumulates, it forms more positive. So we need to reduce it so that it goes back to a negative terminal. So we send it potassium, we have potassium nitrate. We send here the nitrate. So it neutralizes this. So it means that now this terminal remains negative. Now here, when this one comes in, when it comes in, it uses these copper 2 ions. When it uses the copper 2 ions, what is now happening? It's gonna make it lose its positive ability. Yes? So what do we need? We need a positive charge to come here. Remember, it is potassium nitrate. The nitrate has come here and the potassium is positive. So the potassium will come this side and then makes this one to be positive. So it means that now the terminal will be able to attract more electrons. That's it. That's how you can explain. You're saying that this cancels this build up of undesirable charge, maintaining the cell's electric neurality. It means that it will be neutral. There will be no more this fluctuation in the polarity, and the negative will remain negative. That is the function of the salt bridge. That's why we say that it brings about what you call neutrality. All right. So we are saying that the cell, therefore, continues to form or to function properly. It is going to continue functioning properly without any problem. Electron current. Let's look at it now. Electrons are always moving from anode, from the negative terminal to a positive terminal, from zinc terminal to copper terminal, through an external circuit to the cathode. So it moves from the anode, zinc, to the cathode, which is copper. Then you're saying that in copper zinc cell, electrons therefore flow from zinc to copper. I've tried to explain that. It means that it moves from a more reactive element, which is able to be oxidized, to a less reactive element, which is able to be reduced. Cell notation. How do we write now the notation? How do you write the notation? Always start with the anode. which is the negative on the left, and end with the cathode on the right. Cathode is the positive. Are we there? Anode, negative, cathode, positive. All right. Use this separator. Use this. Use a dash. Use a dash. Use this to separate anode or cathode. I'm gonna show you from its electrolytes. Represent the salt bridge. The salt bridge. When you use this two double slash, forward slash, because you have a back slash and a forward slash. The two forward slashes, yes, it means that you are representing a salt bridge. When you use one slash, it means that you are separating anode or you are separating the cathode. Components of the cathode and components of the anode. For example, zinc, which is a solid, slash, it means that it gives out zinc to ions. It means that it is oxidized, which is aqueous. Then I have a salt bridge, yes. Then the copper receives the electrons from zinc, remember? And then you have copper, 2 ions. Once you receive the electrons, then it is reduced to copper. Then I have to separate it, that this copper give me copper solid. That's how you're supposed to explain it. Let me repeat. Zinc gives me zinc 2 ions. And then the copper 2 ions gives me copper solid. That's the meaning. What happens in the half cell of the zinc? What happens in the half cell of the copper? Electrode, this is the electrode, yes. Slash, the electrode, the solid dissolves into what? Into electrolyte. Electrolyte, it means a solution. Electrode, it means a solid. Dissolve into the solution by giving the ions. Yes, salt bridge. Now, what is in the solution? The copper 2, yes, which is the electrolyte solution. It gives me, or it gives the electrode, which is a solid. You understand? That's how it's supposed to be interpreted. Or you can say, this is what needed, but these ones are trying to explain. Anode, which is a negative, salt bridge, cathode, which is a positive. That's it means. All right. Here is what we are talking about diagrammatically. Zinc gives me zinc 2 ions. Yes. Zinc gives me zinc 2 ions here. Yes. Then I have copper. Copper 2 ions gives me copper. Is this? And then you have in between here, I have a salt bridge. Salt bridge which connects them. That's the meaning. Unless you have a question, next time we're gonna start with the standard electrode potential. Standard electrode potential. Make sure that you come to class on time.
On a weekly basis, which are going to help you to get a distinction. This is the only channel which you can use.
Welcome back to our class. Don't forget to subscribe if it is your first time to visit our channel.
So today we are looking at the standard electrode potential. The reactivity series is a list of substances which are arranged in order of their ability to act as reducing agents or oxidizing agents. So now we are going to look at which one is a strong reducing agent, which one is a weak reducing agent. And then if you know that, then you know how to interpret the reactivity series, then you will be able to know which one is going to be on the cathode, which one is going to be on the anode. So we are saying that a table of standard reduction potential can be used to, number one, we're going to look at that table and interpret it better. Number one, identifying the oxidizing and reducing agents. So we are able to know that this is a strong reducing agent, this is a strong oxidizing agent. Number two, writing a balanced redox reaction equation. You can be able to write this, predict whether the reaction is a redox, yes, is taking place spontaneously or not. So you can predict whether this redox reaction is spontaneous or it's not spontaneous. It can continue without an external battery. It can continue without an external source, power source, or it can't continue without an external power source. That's the meaning of spontaneous. And then you're saying that you can calculate the EMF, electromotive force, that is EMF, of this cell. So basically, this is the formula you are going to be using. This is the formula you're going to be using. Electrode potential of the cell is equal to electrode potential of the cathode. Remember, the anode is the negative terminal. So the positive terminal minus the negative terminal. So we need to know which one is supposed to be at the cathode and which one is supposed to be at the anode. Or you can use this equation. The electrode potential of a cell is equal to electrode potential of the oxidizing agent minus electrode potential of reducing agent. So you can use this, and then this is the formula you're going to be using so that we can calculate. But the problem is, how do we get this and how do we get this? So we need to understand how do we get this figure and how do we get this figure so that we can substitute in this formula, and then we'll be able to write the electrode potential of that cell. Standard hydrogen potential. Let's look at standard hydrogen potential. Why do we start with the standard hydrogen potential? Because hydrogen is regarded to be the benchmark, is the one which we compare to. We compare to hydrogen. Whatever we do, we compare it to hydrogen. So it's the standard. Above it, then it means that the cell can continue. Below it, it means that the cell cannot continue. So we are saying that hydrogen gas, or what you call the hydrozonium ion, electrode has been chosen to be a standard half cell. So we are saying that it's regarded as the standard half cell. We compare to hydrogen. Basically, what happens is, if you look at this, you have hydrochloric acid. The reason why you have hydrochloric acid is just to increase the conductivity. Then you have platinum. Platinum or electrode has been coated with platinum. Yes. Why do we put a platinum here? Why? Because hydrogen is a gas. So we need something where hydrogen is supposed to go to so that it can react. So this platinum is just used so that it provides a surface area for this hydrogen to react. So it comes like this to platinum. When it reaches platinum, then it can react from here. So the reason why this one is there is just to increase the surface area or to give the ground for hydrogen to react. So we are saying that the standard hydrogen electrode is a redox reaction. It means that it can have oxidation and reduction, which form a basis of the thermodynamics scale of oxidation reduction potential. So it means that whatever we are going to be doing, we are going to be relating it to hydrogen. So we regard this one to be 0, 0. You start from 0, 0. When you are numbering or you are counting, you start from 0, 1, 2, 3, 4, until whatever you want to reach. Or you start from 0 and then you go to negative, -1, -2, -3. So in this case, hydrogen is the standard where we are supposed to start from. Oh, here is the standard electrode potential. You need to know. You see, hydrogen is here in the middle. Yes. Above it, it means that this one is more reactive than hydrogen. Below it, it means that it is less reactive than hydrogen. So if it is above it, yes, if it is more reactive, then it means that these ones are going to be anodes to produce electrons, whereby hydrogen is going to receive them. Below them, below hydrogen, it means that these ones are less reactive. Then it shows that hydrogen is going to be at the anode, which means that hydrogen is going to be the negative terminal. So hydrogen will be dissolving to produce electrons which are going to be accepted by this. Now, look at this. If you are comparing two of them, for example, calcium and the copper, yes? Calcium is at a top level, while copper at a lower level. The one which is at a top level is supposed to be the anode. You must know that. It's supposed to be the anode. And then the one which is at lower level, is supposed to be the cathode. Remember, anode is the negative, and then the cathode is the positive. So the anode will dissolve to give electrons, and then which are being accepted by the cathode. So we shall say that the anode is what is oxidized. Therefore, it's a strong reducing agent. So that's why you see that as you go up, the reducing agent increases the strength. So as you go up, it becomes more strong. It becomes more reactive. It becomes more easily release the electrons. It can easily release the what? The electrons. Or electrons can be easily released. So it becomes a strong reducing agent. A strong reducing agent is supposed to be at the anode, yes? And then a weak reducing agent is supposed to be at the cathode. Why? Because this one is positive, this one is negative. So this one gives electrons to this. So now we are going to compare copper, yes, copper with hydrogen. So I will come here and say, hydrogen is here, yes? Copper, you have copper 2 to copper 1. It's not yet fully reduced. The one which is fully reduced is this one. So I have hydrogen and the copper. So which one is going to be at the cathode? Which one is going to be at the anode? We say that the one which is on top is supposed to be the anode. The one which is down is supposed to be the what? The cathode. So now I will say that hydrogen is going to be at the anode. So it's going to become the negative electrode, the negative electrode. And then copper is going to be at the cathode, the positive electrode. What about when I compare hydrogen and zinc? We have seen here that now here hydrogen is at the anode and the copper is at the cathode. What about hydrogen and zinc? You have zinc here and then you have hydrogen here. So it means that zinc is more reactive than hydrogen. Therefore, zinc is going to be at the anode while hydrogen is going to be at the cathode. You see? So the one which is more reactive must be at the anode. The one which is less reactive must be at the cathode. The one which is on top, even if you don't read this, it's fine. The one which is on top is more reactive, is easy in releasing electrons. You must have that concept. The one which is on top is easy to release electrons. So this one, it easily releases electrons. You understand? So it becomes the anode. And then the one which is below hydrogen, it becomes the cathode. It means that it's easy in accepting the what? Electrons. So let's go back to determining the standard electrode potential of copper half cell. Here you have the copper half cell. You have hydrogen this side, you have copper this side. We don't know which one is the cathode, we don't know which one is the anode. Now, how do I identify that this is the cathode, this is the anode? This is what you are supposed to do. Hydrogen and the copper. Hydrogen is more reactive than copper. So what does it mean? Hydrogen must be at the anode. Copper must be at the cathode. I go back. I have to find out. So we say that hydrogen is more reactive than copper. So this one becomes my cathode. Why? Because hydrogen is more reactive than copper. And then the one which is more reactive, the one which is above the reactivity series is supposed to be the anode. The one which is below the reactivity series is supposed to be the cathode. This is a negative terminal. This is a positive terminal. Negative terminal give out electrons. Positive terminal receive the electrons. You see? Now I'm going to go to identify which one is a positive, which one is the cathode, which is an anode. Now I have to know which reaction is happening on each. If this is negative terminal, yes, and it gives out electron. So I have to show a reaction here where the electrons are forming. It means that when hydrogen comes, yes, it's gonna react here to form hydrogen ions plus electrons. Yes, these electrons will move to the cathode, where copper is going to receive these electrons, so copper 2 ions, plus these 2 electrons to form copper solid. You see here, hydrogen comes in, yes, it forms hydrogen, hydrogen gas. It's supposed to have a gas here, and then hydrogen ions. So it dissolves here, it reacts here at the platinum, and then it forms hydrogen ions, which is aqueous, plus 2 electrons. These 2 electrons, they move. When they move, they come to copper. Here you have copper copper solution. Yes, these copper 2 ions, they accept these electrons, yes, and then forms copper solid. So what is happening? But all this, you have identified it from this. You have identified this from this point, that hydrogen is above, copper is below. So hydrogen becomes the anode, while copper becomes the cathode. How do you write the full reaction equation? Hydrogen, that's before the arrow, plus copper 2 ions, giving me after the arrow 2 hydrogen ions plus copper solid. This is what I'm trying to say. Hydrogen gas, yes, plus copper 2 ions, which is here, giving me hydrogen, 2 hydrogen ions, which is this, plus copper solid. That's it. So before the arrow and then after the arrow. Before the arrow and after the arrow. So it's supposed to be like that. So, and then you cancel out what is similar. Electrons this side, I have electrons this side, I have electrons this side. So I cancel them out. So how do I write the cell notation? How do I write the cell notation? This is the cell net cell reaction. This is the half cell reaction. And then this is the half cell reaction for copper. This is the full when I combine them. What about the cell notation? How do I represent this in form of equation? So I will start with this. Yes. So I will say that I have with the anode. Yes, when you write the cell notation. I have hydrogen. Yes, the hydrogen. This hydrogen goes to platinum. So I have hydrogen gas, comma, it goes to platinum because I don't, this platinum shows that this is just an electrode. But if, okay, I'll explain it. It is showing just an electrode. So this hydrogen, the hydrogen gas, comes to platinum. Yes. When it comes to platinum, it reacts, you see, it reacts to form hydrogen ions. So it reacts to form hydrogen ions. Are you seeing? Which is aqueous. Then I've completed this one. But in between here, we have a salt bridge. Remember I said that the salt bridge is indicated by a double forward slash. So forward slash, then I go to copper. So when these electrons come, they will find the solution here of copper. Yes. So this copper 2 ions, yes, which is aqueous. Yes, it will give me copper solid, which is this. So basically, that's how you're supposed to write it. In this cell notation, we don't balance the equation. You don't put the 2. No, you just have to write what is really happening. But in the net cell reaction, we balance. It's supposed to be balanced. That's why you have here only hydrogen ion, and yet here you have 2 hydrogen ions. Let's look at another example. So we have said that this is zinc. The reaction is talking about zinc, measuring electrode potential of zinc to iron, zinc to iron in the system. All right, what happens? So now I have to know, this side I have hydrogen, this side I have what? I have zinc. Now I don't know which one is the, don't cram, I don't know which one is a cathode, which one is anode. So we have to go back to the reactivity theory, and then we see zinc versus hydrogen. Zinc is here, yes, versus hydrogen. Hydrogen is here, yes. So it means that zinc is more reactive than hydrogen. So it means that zinc is going to be the anode while hydrogen is going to be the cathode. Let's go back. So now if you are saying that now we have understood that zinc is the anode, is the negative, it's more reactive anode. Which one is on top? Anode. And then the one which is at below becomes the cathode. So this one becomes negative. So this one becomes positive. This one becomes negative. So this is anode, this is cathode. This is anode, this is cathode. It means that this one gives electrons to this. So let's interpret. It shows that zinc is going to react, yes, to form zinc ions. Then these two electrons are going to move, yes, to go to hydrogen electrode. You see? Now, what happens? The hydrogen ions, which are in the solution here, yes, are going to accept the two electrons from the zinc to form hydrogen gas. That's how it's supposed to be. We find oxidation. This one is oxidized from zinc, which is 0, to zinc 2 ion. It's oxidized. So it releases electrons. Electrons will travel to this. Now, this one is what? Is now negative. It shows that now it can continue on its own. Yes, this, yes, it means that it's a strong, this one, it shows that is a strong reducing agent. If it is negative, it shows that is a strong reducing agent. If it is positive, it shows that it's a weak reducing agent. So basically, that's it. So how do we write this full cell equation or net cell reaction? So you have, you're supposed to start with the anode, then you end with the cathode. In this case, this is the anode, and then this is the cathode. So let's see. Zinc, yes, which is zinc, this one, for the arrow, plus 2 electrons, plus 2 hydrogen ions, which is this. Electrons have cancelled, giving me hydrogen after the arrow, plus zinc 2, which is after the arrow. That's how you're supposed to write. Cell notation. Remember, you start with the anode. So zinc, which is a solid, yes, is oxidized, yes, is oxidized, or it dissolves. This electrode dissolves to give zinc 2 ions. So zinc, which is a solid, is oxidized to zinc 2 ions, yes. So now I don't have anything in this side. Then I'm separating this by a short bridge, slash, yes. When it goes here, these electrons, they will find the ions here, or hydrogen. So it will find the hydrogen ions, yes. It will find the hydrogen ions. When they find hydrogen ions, these electrons will react with the hydrogen ions to form hydrogen gas. So I have hydrogen ions to give me hydrogen gas. And then this is taking place. The hydrogen gas is being produced at this plate or this electrode, which is a platinum. So you see how it's supposed to be. So now the platinum is at the end. So that's how you can write the cell notation. If this was a solid, then I won't need this platinum there. Why? Because I have, maybe if it was copper, then it means that I'll just have to stop here. Why? Because copper is a solid. But if it is a gas and then I use another electrode like platinum, then I have to put the platinum there. Electromotive force of a electrochemical cell. So how do I calculate now this?
That if you look at this, it's not. This is not, because this is it's having this, and then this is just a straight chain, and then this is not. They're saying secondary. So because there is no hydrogen here, it shows that this is here on top here. So if you draw the structure formula, you see that this one is here, which shows that now this hydrocarbon, sorry, this carbon, it has this side and also has this carbon which is attached to the carbon atom with a functional group. So D becomes the most correct answer. Yes. So just guys, these are just my suggestions. There are so many ways how we can do so many questions we're gonna see, because we have different methods we use when you are doing these calculations. So let's see if we can what you wrote is what I'm going to write. So if it's a different method but you get the answer, then it's cool. Which one of the following is hydrolysis? Hydrolysis, people who watched my prediction, you saw. So this one is they're saying that which one of the following is hydrolysis. It means that which one of the following is hydrolysis reaction. So here you have this to form this. You have this from this. This can't be hydrolysis because you are not adding water there. So you see this and this is the same reaction, but it's a reverse reaction. So this is not, this is hydration, and then this is obviously not, it's no because we're not adding water there. So this one becomes the most correct answer. So yeah, then we go to the next question, which is 1.4. They are saying that hydrochloric acid react with the excess. When you talk about excess, it means that it cannot be a limiting factor in that regard. So it means that just a moment. Just a moment, guys.
Recording in progress.
Right. Let's continue. Let's continue from where we stopped. I hope everyone is hearing me, né? Yeah, because it is just a live. Né? Yes. All right. If you don't hear me, okay. We go to the next question. What are they saying? Hello, everybody. Yeah. Go to the next question. What are they saying here? Zinc plus hydrochloric acid gives you zinc chloride plus hydrogen. Different conditions are shown in the diagram below. The mass of zinc is used is the same in both test tubes. Okay, meaning that the mass of zinc which is used is the same, but what is different? Remember, zinc is in excess, so it means that zinc cannot be a limiting reagent. But now what is happening here? If you look at here, is the same concentration. What is different here is the number, the volume. So what are they saying? Will the initial rate and the final volume of hydrogen produced in the test tube Y compared with that of X? So what will happen here? Initially, saying that how will the initial rate of reaction and the final volume, initial rate. So because it's initial rate, okay, produced in test tube Y, as compared to test tube X. So if you look at this, in test tube Y, what will happen here? Initial rate of reaction in Y, and then initial volume of hydrogen in Y. So in here, we shall see that we're going to have more of Y, and then we're going to have initial rate of reaction in Y. So here is going to be this, and this is the most correct answer. So the answer becomes B. Then we go to the next question. We see that 1.5, the diagram below represent the mixture of nitrogen dioxide and nitrogen dioxide and dinitrogen tetraoxide. The nitrogen tetraoxide molecule at equilibrium in 1 decimeter cubed of container at T. All right. They're saying that the balanced equation for this reaction is this. Okay. What is here? We have 2 moles. Here we have 1 mole. Okay. None of the following is true for the equilibrium constant Kc for the reaction at Tc. So they are saying that Kc is 24. No, Kc is greater than 1. Kc is greater than 1. Yes, it could be. Is Kc greater than 1? Let's have to find out. We have to find out, because now Kc, remember Kc is equal to the product concentration to the exponent, maybe X in the product, okay, over reactant. So if you look at this is the product, but they say this is this. So how many are they? 1, 2, 3, 4, 5, 6. Just in case that this is 6. We don't have any unit here. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If this is 12, and then this is 2 of them, so automatically this can't be 1. So Kc can't be greater than 1. Why? Because of this. So this is out. Kc is equal to 1. It can't be because they're not equal. Kc is greater than 0, yes, but is less than 1. I think that is the perfect answer for this, and then that becomes D, the most correct answer. Then we go to the next question. The next question, they are saying that all right, they are saying that next question, they are saying that the volume, okay, the reaction is at equilibrium in a closed container according to the following balanced equation. Copper is equal to copper 2. Copper oxide is equal to copper 2. Still is the same as copper. This is copper 2. This is copper 1. Gives you copper 1 plus oxygen. This is already as copper 1. This is already as copper 2. So if you don't know, sorry, but it's not for explanation everything. It's just to see which one is the most correct answer. Yes. The volume of container is now increased while the temperature remains constant. The new equilibrium is, okay, the volume is increased. So volume, how is the volume affect the Kc? Okay, we shall see. While the temperature remains the same. The moment temperature remains the same means that Kc is always the same. But if you increase the volume, what does it mean? If you increase the volume, so here you have 4 units, 4 moles, while here you have 3 moles. So if you increase the volume, it's going to favor the reverse reaction. So let's go to the table and we see. Concentration of this decrease, no. Concentration of this one increases. So whenever there is remains the same, it is probably to be correct. But now the number of moles of this is gonna decrease. So we look at this. So now this one goes. So there is no any other option. So B becomes the most correct answer. So the concentration of oxygen remains the same. So 1.7 nitric acid and the ethanoic acid. Yes, what happens? Nitric acid and ethanoic acid of the volume and the concentration are compared, meaning that you have nitric acid, you have ethanoic acid. Yes, so you compare the volume, they have equal volume, and the concentrations, these two are compared. Consider consider the following statement regarding to this what solution. And what are they saying? That they have the same pH. They have different pH. They can't be with the same pH. Why? Because this is a weak acid, so it ionizes partially, while this is a strong acid, meaning that the pH of this is a little bit lower and this one is higher. Remember, when it's higher, it means that it's a weak acid. So now what happens? Both have the same electrical conductivity. No, amino acids, they have a strong electrical conductivity compared to others. So this is out. Both solutions require the same number of moles of potassium hydroxide for complementation. They're saying the same number of moles. I'm not saying the same concentration, meaning that now the volume can be different. Let's see if both of them, they are monoprotic acids. Yes, if you look at nitric acid here, it has one hydrogen. And also if you look at this, it produces one hydrogen. So both of them are monoprotic acid. However much one is different. So therefore, it requires the same number of moles. I'm saying not concentration, meaning that the concentration might be different to reach neutralization. In other words, the volume used will be different, because if the volume is different and then the number of moles are the same, definitely the concentration will be different. So this and this, they become most correct answer. So do we have any option which has that? Yes. So C becomes the most correct answer. Yeah. We go to the next question, and then we see the apparatus in the diagram below is used for titration. Yeah, we use this to do the titration. But they are saying that hydrochloric acid and potassium hydroxide. Cool. In titration, the learner accidentally exceed the endpoint. Which one of the following will be true for titration mixture? If you are, both of them are strong acid and strong bases, so we expect the pH to be at least 7. But now the learner accidentally, remember, you have hydrochloric acid, you are pouring it into you're not having the other way around. So it means that the pH is gonna be a little bit lower, or it's gonna be a little bit of acidic. So now the hydrogen ions will be greater than potassium hydroxyl ions, and the pH will be greater. Then now this one messes it up. And they're saying that hydrogen ions will be less, no, because we have more acid now. Then you're saying that then this one is also no. Then automatically this one becomes the most correct answer. But let's go through it. Hydrogen ions are greater than OH, yes, and the pH is less than. Is less than what? Is less than 0. Did I say that? This pH is greater than 7. No, man. No. It's this one. This means pH is supposed to be less than 7, meaning that 7, yeah. So this one becomes the most correct answer, not this one. Yeah. So the pH here, this one, hydrogen ion, will be greater than this, cool, and the pH is supposed to be less than 7, so that now it is acidic. This one makes it to be wrong, né? Yeah. So the most correct answer there is A. Then we go to 1.9. 1.9, what are they saying here? The following hypothetical statement, standard reduction potentials relate to a galvanic cell. Okay, you have this, gives you this. You have this, gives you this. Okay, consider a statement in the galvanic cell. The EMF of the cell is equal to 20. standard condition. If you have this minus this, then it gives you the volume, the voltage as that, or EMF. Okay, cool. Why is an anode? Why an anode? No. Why can't be an anode? Why? Because, and then X is oxidized. So if X is oxidized, let's see. Yes, X is gonna be oxidized. If this is oxidized, yes, this is cool. And don't forget, yes, so X is oxidized, then automatically Y is gonna be reduced. So it can't be the what? The anode. So the most correct answer is this and this. So you have to look at 1 and 3, where is C becomes the most correct answer. Then 10, they're saying that which one of the following have equation below will be the main reaction at anode during the electrolysis of concentrated. Now this word, that's why they even put it in capital letter. The moment they say concentrated copper chloride, yes, so it means that they are looking like molten copper chloride. It means that we're gonna have much more of, remember, we're gonna have much more of chloride, understand? And the anode is a positive in electrolytic cell, so the chloride will go to the positive charge. Therefore, chlorine is gonna be released there. So the most correct answer here is chlorine is gonna be released, so therefore D is gonna become the most correct answer. Then we go to the next question, that is now the section whereby just we have to talk about the naming, the nomenclature. Okay. Here, yes, let's go to the nomenclature and then we see how this one is going to be. Then here we are saying that A to H, below the table, 8 compounds. Okay, sharp. Let's say A is B, right? Okay, let's go. Define the organic molecule. Basically, organic molecules are compounds with the one or more carbon atoms that are covalently linked to one another, or to one another, or with another element. So basically, the organic molecule, organic compound, it must be basically carbon atoms. If it's more than one, it must be linked to one another. That's why we call them that carbon atom can have that ability of catenation, like joining one atom of carbon with another and then forms a long chain. It's one of the good properties of carbons, of carbon, yes. So basically that's an organic molecule. Write down the IUPAC name of compound E. So if you look at compound E, what are you going to say here? First, find out the longest chain. Compound E. 1, 1, 2, 3, 4. No, 1, 2, 3, 4. Because here I have the double bond. But when I was going through this structure, as you see it there, something was not right. I don't know whether they did it on purpose, but it can't be, because this is a mistake. I don't know how it did happen. Maybe through printing. This molecule does not exist. See this? It's supposed to have 3, but they didn't put a 3 there. I don't know how they will mark it, but it had to be with a 3 so that it is a methyl. Yes, but let's just assume that we put a 3 there so that we have a correct naming as methyl, right? So it's gonna be 1, 2, 3, 4. So it's gonna be beauty. It's gonna be but, but because it's a double bond, so it's gonna be but. So it's 1 is on carbon atom number 1. But 1, you see, it's on carbon atom number 1. So it's gonna be but 1 in. But 1 in. Now I have this side group and I have this side group. So you have the first side group is on carbon atom number 2. So it's gonna be 2, comma. The second side group is 1, 2, 3, 3. Then dash di. What is it? These are methyls. Dimethyl butene 1 in. 2, 3 dimethyl butene 1 in. So basically, how many marks are there? They'll give you a mark there, and they'll also give you a mark there. At least you get those 2 marks. Yes. Then we go to the next question, which is what is H? Impact name of H. Where is H? H is here. This is a carboxylic acid. It is a carboxylic acid. So, oh, this no, they're not looking for this. They're looking for H. So this is a ketone. So 1, 2, 3, 4. So it's gonna be butane. Remember, I told you that when it's not alkyl, if it's not alkene. So here you have to write up to there. Butane. This is a ketone which ends with on. So it's gonna be butane 1, 2, 2 on. So butane 2 on. So basically that is it. So that you get you 2 marks for the chain and then the position there. Then we go to write down the structure formula of compound B. When they say the structure formula of compound B, let me just clear it up so that we see exactly what are they saying. The structure formula of compound B. What is compound B? Okay, it's here. What is it? It looks to be an ester. So it's gonna be CH3. You put hydrogens. The hydrogens are supposed to be there. Might not put them here. And then this one, because there's no shortage of hydrogen here, so automatically this becomes a chain. CH, that's 1. CH, that's 2. CH, that's 3. Now I put C. 1, 2, 3. O there, and then O, and then hydrogen. So you put the hydrogens. No man. Yes, you put the hydrogens. Yeah, it doesn't end with it's an ester. So it's C. You put the hydrogens completely. Yeah, so that's what the structure formula, what they are talking about in here for compound B. Then we go to structure formula for compound C. Now it is compound C. So here they want the structure formula for compound C. Okay, let's write it. Xn. Xn is 1, 2, 3, 4, 5, 6. It's Xn. Difluoro is 3, 3. 3, 3 difluoro. Let me just count from here. 1, 1, 2, 3. So I have a fluoride here and I have a fluoride here. Okay. And then you have 4 methyl, meaning that if I come from this 1, 2, 3, 4, so I have a methyl here. Is it methyl? It's ethyl. So I put hydrogens. So you're supposed to have now the hydrogens. You fill it with the hydrogens. So that's the structure which you're supposed to draw when it came to that. Then I don't understand what you are saying. Aneliswa. Don't understand, but I think we are getting there. Hope you are hearing me properly. Yes. If you're not hearing me properly, let me know in the comment section. Yeah. All right. Let's go to the next question, and then we see how did we perform this paper. You guys, I salute you. At this time, you are awake. Okay, all right. Let's go to question 2 point. Yes, H, we are done with it. Write down the structure formula of B. Did I write? Yes, I'm done with this. I'm done with this. I'm done with that. The general formula of homologous series to which compound E belong. Where is compound E? Compound E is an alkene. Remember when I was reminding you how to write this? I said that alkene is CH2N. We don't add anything because alkane we add 2 and alkyne we subtract 2. Yes. Structure formula for functional group of F. So we go to functional group of F. F, it is a keton. Therefore, here you just come and write the structure formula of so that's basically what you're supposed to write like that. However, sometimes some people they put a bracket like that, so it's the same thing. It's cool, né? Yes. And then sometimes people add alkyl group that side and alkyl group that side. Still, it's cool. You'll get a mark in that regard. So in that case, the structure formula, we say that it looks like that. Whatever you write it is cool. Then IPAC name of alcohol needed to produce compound B. Where is compound B? Compound B is, we say that compound B is an ester. Né? Since compound B is an ester, let's see which alcohol is used to do what? To remove or to form this ester. Remember I told you guys that the alcohol comes from the carbon atom without a double without the hydrogen. No, that's the carboxylic acid. So you see this carbon atom, then it means that this part came from the carboxylic acid because this carbon atom didn't have a hydrogen. And then this is where the alcohol is coming from. Since it's one carbon atom, therefore it's going to be CH3 or H. Did I say structure formula? If they say the structure formula, IPAC name of alcohol, they just want the IPAC name. Therefore, if the IPAC name, then I'm just going to say methanol. That's it. Because methanol doesn't have the name, the position, because it's just one carbon atom, and ethane doesn't have the position because it's two carbon atoms. Yes. They are saying that write down letters of the compound that is functional isomer of compound G. Functional isomer of compound G. So now we go back to compound G. G is carboxylic acid. They are saying functional isomer. If it comes to functional isomer, then it means that they want an ester. So you have to look for the what? For the ester. But it must have the same number of carbon atoms. So the only ester we have here is this. But we have to find out if they have the same number. 1, 2 times 3. Meaning that 1, 4, yes, 5, 6. So we come here and we count 1, 2, 3, 4, 5, 6. So automatically B and G are functional isomer. What did they say? So the answer here becomes B because they are looking for the functional isomer of G. A chain isomer for each other. Chain isomer. Let me check here. Functional isomer of G. Functional isomer of G. Yes. Okay. We got it. Then they're saying that chain isomer of each other. Chain isomer. Chain isomer. Okay. This is a carboxylic acid. Do you have any other carboxylic acid? This is another carboxylic acid, but this is heptanoic acid. This is hexanoic acid, so it can't work. This one is a carboxylic acid. Let's look. 1, 2, 3, 4, 5, 6. So it has 6 carbons. And even hexanoic acid is also having 6 carbons. Yeah, so definitely D and G. D and G. So D and G, they are chain isomer. Remember that it's supposed to be the same functional group. It's just the different arrangement of atoms on the parent chain. It's the one which changes, so that now, yeah. So we go to the next one, the next question, and then we see. So we have got it. You have got that one. You have got that one. Oh, you finished question 2. Okay, let's go to question 3, and then we find out how did you perform this question 2. They're saying the relationship between the boiling point and the molecular mass of aldehydes, carboxylic acid, aldehydes, carboxylic acids, and primary alcohol is investigated. Okay, the curve P2, PR, and S are obtained. All compounds used a straight chain. This is a key point, a straight chain. So it means that you won't be disturbed. Define boiling point. This one you know. Temperature at which the vapor pressure of a substance is equal to the atmospheric pressure. And then, yes. So definition you know. In most cases, I don't talk about them. Yes, 3.2, because it doesn't change. Write down the conclusion that could be. Okay, could be made for P. So where is P? Without even looking at what is P, but you see that it increases. The boiling point increases as this is increasing. We always start with the y-axis, because the y-axis depends on x-axis. You can't say that the mass increases as boiling point increases. No, it's the boiling point increases as the mass increases. Yes, why? Because the mass caused the boiling point to increase. If you have reversed, maybe they could give you a tick, but that's the most correct answer. Then they're saying that explain the answer and the structure. Okay. In this case, because it is the same molecule, because the same molecule, it means that you will have the same type of intermolecular forces of attraction. But as the mass increase, the London forces increase. So it means that as the mass increase, the London forces for this compound P increase, and then this will require more heat to break these bonds so that it can boil. You understand? So that's how we're supposed to explain, talking about London forces increasing the boiling point because of the high amount of energy which will be required to break those bonds. Then you get it. Yes. Then they're saying that curve R represents alcohol. Curve R, where is curve R? Represents the alcohol. Okay, if this is alcohol, then automatically this is carboxylic acid. And then this is aldehyde. Yes. So if this is alcohol, then this is carboxylic acid. So why am I saying that? I'm just saying because they have said R is alcohol. And then if you look at the intermolecular forces of attraction here on S, on this one has dipole forces and London forces. This one has hydrogen bonds and the London force. This one has London, hydrogen, and then dipole. You see, it means that this will require more heat to be broken down. Therefore, its boiling point is a little bit higher compared to alcohol. And then this one, hydrogen bonds is stronger than dipole. Therefore, the boiling point is higher than that of. Okay, let's go to the question and then we see. which homologous series is represented by S. So we have said it. So it is an aldehyde. Then they are saying that explain your answer. So I've tried to explain that it has London force, and London force and dipole forces which are weaker than the hydrogen bond, yes, which are, and London force which are found in alcohol. Therefore, alcohol will require more heat to break its bond so that it can boil. Hence, its boiling point is higher than that of the aldehyde. So basically, that's what you're supposed to explain. My words could be that too much. Maybe you explained in a different version. Yeah, still it's not a big deal. As long as you have talked about the things which they want you to talk about. Then we go to the next question, which is saying that molecular mass of compound with a boiling point 97. Okay, R is right, graph R, write down the molecular mass. Okay, we have to go back and we'll find out where it's 97. They say 97. Yeah, unfortunately, boiling point 97. The graph can't show nice of R, the boiling point around 97. So if you look at 97, just check here on this paper if I can find 97 is around here. So I have to draw a line touching down. Yes, and basically if you check here, it's gonna be was 50, 70, then automatically it's 60. But if you calculate the boxes, the small boxes, you'll find out that it is 60. So the answer here will become 60 because that's the molecular mass. So the molecular mass is going to be 60. So the IPAC name of compound is, this is 2 marks. 2 marks there. Where do I get those 2 marks from? So basically here, you need to find out which alcohol has 60. That's all. Yes, which alcohol has a 60. So it's easy.